With the increase in size of data that generates every second, it is important to analyze this data to get important business insights in a lesser time. This is where Apache Spark comes in to process real-time big data. So keeping the importance of Spark in mind, we have come up with this full course. Now, before we go ahead with the session, I'd like to inform you guys that we have launched a completely free platform called Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below. Now, let's have a quick glance at the agenda. We'll start off with an introduction to Spark and we'll also understand its ecosystem. Then we'll understand what are RDDs in Spark and look at some fundamentals with respect to RDDs. After that, we'll learn about Spark transformations and actions. So we'll work with different transformations and actions in Spark. Going ahead, we'll work with Spark SQL. Following which, we'll understand what are data frames in Spark and also work with data frames in Spark. Then we'll see how to read data from different sources. And then finally, we'll work with Spark streaming. So guys, let's start with the session.
So we will get started with Spark anyway, and the other points we will discuss later. Anyway, we have to do Spark, that's for sure, right? And Spark requires some level of understanding before we actually go to the hands-on side. We can do the hands-on in Spark for sure. We'll be doing a lot of hands-on. But if I directly start with, okay, write a program, you will not understand what we are doing, right? So that is why some slides are there. I'm not really a slides person, but still some topics we have to understand and only you can go to Spark, right? So first thing you need to understand is what is Spark and from where we got Spark, right? So why people are so excited about Spark. So your previous session trainer, right? What is his name? He was asking me that, can I learn Spark? I really want to learn Spark. That's the power of Spark. I'm not saying, I mean, even I want to learn machine learning. I'm not saying that way, but he want to leverage Spark. So he was asking me some doubts like, can I get started with Spark? I want to do machine learning on Spark because everybody is excited about Spark. So, and all my trainings these days are on Spark. Majority of trainings are on Spark. So there is a lot of excitement about this tool. And why is it? Why Spark is so popular? Or is it some magic or something what Spark is doing, right? So it's very easy to understand why it is so popular. Somewhere in 2009, okay, we had a project called AMPLab. In the University of Berkeley, there is a research project called AMPLab. So this AMPLab project is even live today. It's a research project in University of Berkeley. So there people were trying to create a new cluster manager. Do you remember Yarn? Yeah, so Yarn is what your resource manager in Hadoop. And Hadoop version 2 came in 2012, what you're seeing today. So Yarn came in 2012, right? Yarn came with Hadoop. We are talking about 2009. So in 2009, there is no Yarn. We were running Hadoop 1, old Hadoop version, and there was no good cluster managers. So some folks at the University of Berkeley, they were trying to create a cluster manager very similar to Yarn. Okay, at that time there is no Yarn. Okay, and they call this project as Mesos. Mesos. Mesos is the project name they have given for this project. Okay, and these guys were doing some R&D, and at last they created the cluster manager, like very similar to Yarn. Mesos is there even now. It's an Apache project, very similar to Yarn. So why Yarn became so popular? Because Yarn is coming by default with Hadoop. If you download Hadoop, you will get Yarn. If I want to use Mesos, I have to install it separately. But Hadoop will run on top of Mesos also. There the only difference will be that your Yarn layer will be handled by Mesos. Okay. So Mesos is a very famous project. Even today, some of the folks use it actually. Not everybody use it. And Mesos was created in 2009 in AMPLab. So they created Mesos and they said that it's a great cluster manager. We're going to use it, blah, 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 right? Now, in order to test the power of Mesos, okay, first they ran some MapReduce programs. Of course, MapReduce was what we had originally, and it was running fine. So then they thought, why don't we just use a different programming framework, and they created something called Spark. So Spark was created actually to test Mesos, meaning Mesos is your cluster manager, and they created a new programming framework called Spark. So you can write a program using Spark, it will run on Mesos. And the only difference was that Spark was completely in-memory execution, like it will use most of your RAM. So if you have a cluster manager, and if there is a lot of RAM getting used, you can actually test, right, whether the cluster manager is good or bad. So they created this Spark programming framework, wherein if you write a Spark program, it will use majority of your RAM for faster processing. And they tested Mesos. And Mesos became a success. Everybody was happy. People never thought much about Spark. They just created as a sub project. Okay. But after an year, like 2010 or 11, people thought that, hey, this Spark is good, because if you write a program in Spark, first thing people noticed is that it is running faster compared with MapReduce. I'll tell you why it is running faster. So people thought that, why don't we develop Spark a bit more? If people can write a Spark program and if it is running faster, it should be great, right? And the development started, and somewhere in 2012, I believe, Spark became an Apache project. So they contributed to Apache and said that, you know, we have created a new product. It's an make it open source. And this is a framework like MapReduce. If you write a Spark program instead of a MapReduce program, it will run faster than MapReduce. Apache thought, okay, let's try that. It became an Apache top level project. Okay. From there, everything changed. From 2012, so actually Spark is quite new, because it became widely popular somewhere around 2015 only, and I started using Spark from 2016 only. This is me, this is the world, right? So I'm like good, right? Because it became popular somewhere in 15. In 16 I started using Spark, okay? And even in 2016 there were very less trainings in Spark, because people were like excited, but nobody knew what is Spark. So we started using in 2016. All of a sudden, end of like December 2016, it became the most active Apache project in the history. And in 2018, 17, 18, now this is the biggest contributed Apache project. So in a span of 2-3 years, it gained a lot of popularity, right? And now Spark is, like I said, the most popular Apache project so far. So Apache has around 300 plus projects. In that, the number one is Spark as of now, right? Also, originally there was a Spark version 0, then we got a Spark version 1, now we are in Spark version 2.3. This is the latest version. And many companies run something called Spark 1.6. This is very stable, a very stable version. That is the reason they run it, probably, I don't know, right? After 1.6, you have 2.0. There is no 1.7. After 1.6, the next Spark version is major release 2.0. Okay, and we are on 2.3 right now. If you go to the Spark website, it will say we are on 2.3 currently. 2.3 is not pretty stable because it's the latest version, so not so stable. But 2.1, 2.2, they are very, very stable actually. And we are learning Spark 2. We are not learning Spark 1. You are not missing anything, because in Spark 2 you have some improvements and all the features of 1 are available in 2. So that part is covered. And in most of the trainings, they will request you please start with Spark 2. I mean, don't start with Spark 1. Meaning it's not so old, but people want to start with Spark 2. So the major version right now is 2 or 2.3, I can say, and that we are using. And something else happened. So what actually made Spark more popular is that in 2012, these guys, the founders of Spark, there is 2 guys, they gave to Apache and said that take Spark and go. But they were not so happy. So what these guys did parallelly, they found a company called Databricks. So the founders of Spark, they gave it to Apache because it became open source, obviously. But they also want to make money, right? So it is open source, you can't make money. So if you give something to Apache, you are actually contributing to the world. Probably like for the good scenario. If I don't give it to Apache, like Microsoft Windows is not available with Apache, right? So it's only money making, and so you are not getting any chance to modify anything or add your contributions or anything if it is not in Apache. The only contributions for commercial versions are done by the company. So the growth will be limited. Very simple. The growth will be limited. Like you will have your own developers who can modify and all, but others will not be allowed. So when it went to Apache, now what happened is that Apache has a Spark version, Apache Spark, that anybody can download. That is 100% free open source. Again, the Spark is available with Cloudera, Hortonworks, MapR. Sure, that we know. So we are using a Cloudera cluster that has Spark installed. So that is again same Spark only, we can use it. But these guys in 2012 found this Databricks, okay, company, and their sole purpose is to sell Spark, nothing else. But this company is so special because it is created by the founders of Spark. The people who actually wrote the source code found this company. So if I want only Spark, I can probably go to these guys because they are the best. But people don't go here, people go to Cloudera or Hortonworks because chances are very rare you want only Spark. You want other tools also, like Scoop you want, Flume you want. Now Databricks has nothing to do with Scoop or Flume. They have only Spark, right? Now, one of the participants asked this question. I'll get back to that in a moment, but still, Spark is an independent project, which means it does not require Hadoop. But mostly you will see it on top of Hadoop. Okay, Spark is actually an independent project, which means I can download Spark. I have Spark running on my Windows 10 laptop. Beautifully works. Doesn't require anything, right? NTFS file system. It will work. Okay. So, but people don't do it because the point is, like right now we have a migration happening in GE. So I was with GE last week before coming here. So there we have a migration happening. GE is migrating to Spark and Hadoop, right? So GE already has a Hadoop cluster. So why should they install Spark separately, right? So they are already having a Hadoop cluster. So they will install Spark on top of Hadoop as an ecosystem tool. So it will start leveraging HDFS for storage and then processing and all. So most of the times you will see Spark on top of Hadoop. But that does not mean it will run only on top of Hadoop. You can run it anywhere practically. And I will show you in the slides wherever you can run, however you can run, so on and so forth. So Databricks is popular in that case, and it is available almost everywhere, right? So I think we'll run some slides to get you an idea. The best resource to learn Spark. Okay, so a couple of things which I know I can teach you, right? A lot of people ask like, give me the best book to learn Spark. And I suggest one book, then they will never come back to me. So the best book to learn Spark is something called Spark, the Definitive Guide. Don't buy it, don't read it. Just make a note. Spark, the Definitive Guide. This is the best book. Don't even touch it. Why I'm saying this? Okay, you can probably buy, I don't mind. This is written by Zetay Maharia and the founder of Spark. The guy who wrote the source code wrote the book. And the book is pretty much like the source code. You won't understand anything. Even I don't understand half of the book. But very good. So buy it and keep it. So people ask, then you can show this is a Spark book, right? Very difficult to understand. But it has like accurate information. Because the guy who wrote Spark is writing this book, right? So if you read about it as RDD, he will go to any level to explain what it is. So it's a bit difficult to understand. Probably don't read it immediately. Once you complete the Spark class and do some assignments, then you start with this book, it will give you a very good idea to read. So this is one place where you can. Second is the documentation from Apache and Databricks. This is where I learn actually. So you open Apache documentation, you open Databricks documentation, they will give you a lot of ideas. I mean, basics at least if you want to learn, right? Okay, so that's learning Spark. Spark, the Definitive Guide. Amazon also. This is the Matej Zaharia and Bill Chambers. These are the people who wrote Spark. So this is paperback 2018, actually, right? So it was latest edition it is, right? And basic operations and a lot of things are there. So try this if you want, up to you. This is Spark, the Definitive Guide. You also have for Hadoop, the Definitive Guide. Then there is one more good book for Hadoop. Hadoop in Action, I think. That's also a good book. Okay. Hadoop books are a bit more easy to understand in the sense like this Spark book is more oriented on the source code side, like how exactly stuff work. Hadoop books are a bit more easy. This is the slide which you need to understand if you want to learn Spark, right? And this slide is very important also if you really want to learn Spark. Why it is important? So somewhere in 2004 Hadoop came, that's what the year there. And with Hadoop you got something called MapReduce. You know what is MapReduce, I don't have to teach, right? Till 2015, I can say, you can say 2007 till 2015, what happened was that one of the problems with Hadoop was that you have MapReduce, fine, no problem. But what MapReduce does is batch processing. It is slow and it does batch processing. So people wanted to try different type of workloads in Hadoop. So some of them wanted to write SQL queries on top of Hadoop. That is where you got Hive, then we got Impala, then we got Presto. Now here you have Drill and many tools. So around 10 plus different SQL tools are there which can explore the data in Hadoop. And some other people wanted machine learning to be done on top of Hadoop. So if you, in the earlier versions before Spark, when people want to do machine learning, they use something called Mahout, Apache Mahout. Here you can see Mahout somewhere, here. This is your machine learning library. But what is the problem? Machine learning is what? It is about iteration. What do you mean by iteration? Like you are taking the same data and iterating over and over again, right? One of the things which MapReduce cannot do is iteration. Because if you write a MapReduce program, the mapper will run, reducer will run, it will push the data to hard disk. Again, the second iteration, again you have to read it. So when Mahout was doing machine learning, the problem was that it was very slow because internally it uses MapReduce on top of Hadoop. So Mahout came, but this became your machine learning tool, okay? And so interactive we covered. For graph processing, we got GraphLag, Pregel. So these are the tools which you use for graph processing on Hadoop, traditional Hadoop, no Spark or nothing. Then people wanted to do a streaming data analysis, real-time data. That is where you got Storm, right? So you see the problem, right? Over the period of 8 to 10 years, people started developing different tools to handle different workload. So if today I go to a Hadoop system and if I am very new to Hadoop and if I ask somebody what tool I should learn, then he will be confused because all these things you have to learn, Pig, Hive, Mahout, everything to start working with Hadoop. Another problem is if let's say one fine day you start learning Storm. Storm is real-time processing. You have to first learn Storm's API, Storm's language, then you have to install it on top of Hadoop. You should learn the integration, then only it starts working. So learning all these different tools actually became a problem, okay? And what happened in 2014 when Spark came, the biggest USP of Spark is that it is a unified processing engine. What these 50 plus tools on Hadoop are doing, Spark alone can do. That is the real advantage of Spark. Now many people confuse here because if you go to anybody and ask like why somebody should learn Spark, they will say because it is faster. Now speed is a byproduct of Spark. It is faster, I know, but the real reason why people are migrating to Spark is that all these tools, whatever they are doing, Spark alone can do. So you don't have to learn like hundreds of tools. You learn one tool, one language, and you can do everything. But you need to have some basic idea about what you're going to do. For example, if you want to do machine learning, Spark has something called MLlib, machine learning library. That will allow you to do machine learning. But you should know what is machine learning, then only you can do. Otherwise, you cannot explore it. But I don't have to install 10 tools or 20 tools. Spark alone can do it. So the primary reason why people are going for Spark is this general unified engine. In my experience, the second reason is speed. Obviously, it is faster. I will tell you why it is faster, how it is faster and all. The third reason is ease of programming. Like, you know Python now. So you can get started with Python in Spark. the language is Python. And if you want to write SQL queries or streaming or machine learning, for everything you can use Python in Spark. That is not the case in the traditional world. Pig uses a different language, Storm uses a different language. So every tool here actually uses a different language. Even for graph processing in Spark, you can use Python, normal Python. So ease of programming is another thing. Because I have struggled a lot, because I have worked a couple of these tools. I have worked as part of the project. And then the major problem is that you will take some 3-4 months to learn the tool first. Then when you come back, that tool will be obsolete. They'll say, go and learn some other tool. So with Spark, that gap is gone. So that is why every company want to migrate to Spark. And it is easy to write, faster also. So I say that MapReduce is almost obsolete. That is a use case. And also another problem is that, yes, these tools are going to get obsolete, but tomorrow they will not be obsolete. So what happens is that these tools are already in production in many companies, and they cannot one fine day come and say, we'll remove everything. But yes, going over, already MapReduce is gone, I told you, right? MapReduce is obsolete. Pig is gone. There is a tool called Apache Pig. Nobody is using Pig. I was teaching a lot of folks on Pig, but now Pig is gone. So some of them are almost extinct. Storm is gone. Very interesting use case, because Storm was once like the king of the industry in streaming data processing. The problem was that Storm is actually 100% real time. So, but Spark Streaming is batch, micro batch. That was the only competition. Now Flink came, Apache Flink. Flink is again same thing, streaming, but real time. Not like micro batching. So what people are doing, most of the use cases you can handle with Spark Streaming. It's very rare you want micro level event processing. There they will have a Flink installed and that will handle it. So Storm is totally gone. So Flink is a kind of like a competition to Spark Streaming because it is real time. But I am seeing that most of the companies are doing most of their case studies using Spark Streaming only, because you get only one thing they have to make, like real 100% real time. It is near real time now. If it is 100% real time then in Spark, so there is something called streaming. We will come to that. Streaming data means you want to process real time data. Say I gave you an example, right? So let's say credit card fraud detection. I swipe my credit card and that has to be immediately captured by some system, and it has to say whether it is fraud or not. This is real time, right? Now to implement this, one solution I have is Spark Streaming. In Spark I can do it, okay? But Spark does something called micro batching, meaning it is not able to capture a single swipe as it is. It will collect 1 second worth data. So I cannot go below 1 second, 1 second worth data. But if I'm using something like Storm, it can even pick one swipe in that microsecond and say there is a swipe. But I'm saying that is not so important. Like 1 second worth delay you can suffer at least. Still you can manage with Spark most of the cases. But yes, Spark supports streaming. So in this and this Pregel, Giraffe, these guys are gone. So graph processing is totally gone. We have Spark for that. Most of the Mahout is gone, I told you, right? Taze is there, soon will be gone. Almost soon will be gone, because Taze is middle of MapReduce and Spark. What Taze does, it makes your MapReduce faster. That is what Taze does basically. So Spark makes it more faster. So it is in the middle. So almost it will be gone in a couple of years. Hortonworks is the company who's promoting Taze. So probably they'll keep it because they want market share, right? That is the reason. Okay, let's see what is Spark, right? So in Spark, you have scheduling, monitoring, and distributing. I will show you this practically. And I like this diagram a lot because this will show you the Spark architecture in a very nice way, actually. So how does it look to you? Like if you look at this diagram, what do you think it is? Yeah, so it looks like a solar system anyway, right? I mean, yeah. Or you can say atom, right? Probably. So the point is, at the core, you have Spark. So when you download Spark, you get something called Spark Core, okay? And that is the lowest layer of abstraction in Spark, where you can start programming directly. And I will show you what to do there. And you see there is a RAM and hard disk picture which came up, which means Spark can use both RAM and hard disk. And I'll tell you why this is very important later. Usually other systems can also use. And these are the 4 languages currently supported in Spark core programming. So this is Scala, this icon is Scala, this is Python, R and Java. As of now in 2.3.0, only 4 languages are supported. So you should either learn any of this. And you already know Python, so it makes sense you can continue with Python. I teach Spark with Scala. That is also a very, the source code of Spark is actually written in Scala. That is the reason some of the folks want to learn Scala and do it. But now, so earlier in Spark 1.6 version and all, if you write a Python code, it was slower. There is one thing you have to understand. If you are in Spark 1.6 and if you write your Spark code in Python, it will be slow. And Scala code will be twice faster. It was like that because they didn't do any optimization. Java also slow, slower than Scala. Fastest one was Scala at that point in time. Still it will be a bit slow because they didn't implement certain libraries that was related to Java to support the optimizations in Java. So this is only in 1.6 and 1.6 is very rare. In Spark 2 what they have written, they have written an abstraction layer so that you write the code in any of these languages, your program will run at the same speed. So it doesn't matter you write in Python or Scala or Java, everything will be same. So as of now we don't have to worry about it. SQL is also there, but SQL is not a language as such. I mean, you can also write queries and all using SQL. Okay, go for one more orbit. Yeah. So these are the, so you will be thinking that if Spark is able to do everything, right? How it is able to do it? So these are the libraries available in Spark. Meaning, when you download Spark, you get something called Core Spark. Fine. And that is like MapReduce. You can write. But maybe I'm not a core programmer. I know only SQL. I want to write SQL. You use something called Spark SQL. In Spark SQL, very much like Hive and all, you can create tables and there's something called data frame. Okay, you can create them and query the data. And the good news is they integrated Spark SQL with Hive by default. So what will happen in a Hadoop cluster, if you install Spark, okay, and if I open Spark SQL, I can read the data from my Hive table. So previously when you are running queries in Hive, it is very, very slow. Now the same tables you can read in Spark SQL and then query. So these days Hive is just used as a storage. Most of the processing will be done by your Spark SQL because it is faster ideally, right? Another library is MLlib. This is what I was saying, your machine learning libraries. So whatever you are learning, you can implement here. I don't think deep learning and all are supported because for deep learning and all, you will be using TensorFlow. And GraphX is the framework where you can represent your data using a graph. Have you ever done graph processing? No, right? I have done. Okay. Because why this is important? If you have studied engineering, computer science, you could have learned graph theory, right? I mean, I have learned, I don't know, it was there in your syllabus. There is something called graph theory. So there you have some stuff like you have edges and relations, you have to define like this, right? So this will be me, this will be you, this will be you1, and then you write relations between them, like I like you, probably you don't like me, so you like someone else, like this. So I mean, you have property graphs where you have an edges, okay, which represents some property, and then you have relations between them, okay, and then you can query the structure. So for some type of, we partially work with a social media company in one of our projects, not like Facebook and all, they were a startup actually. Their entire data was like this. Even Facebook, right? If you download the data from Facebook, it's very difficult to do it. Okay, you can't directly do it, but there is a way to get the data. Data means all the publicly available data. They will give you in the Graph API format. The format in which the data comes is graph. It doesn't come in JSON or XML, it's Graph API format. Because Facebook is actually using this graph structure to store. Not the Spark graph, I think they have their own some system, but the representation is in the form of a graph actually. So many times this is required, this graph representation of data. And Spark can do this GraphX library, which can represent your data. And then streaming data. Streaming data is where I was saying you have real-time data coming in and you want to process it real time. and then make a decision based on that. Yeah, so some of the queries, if you write like this, it will be much more efficient. The multi-relational queries. Say, for example, this guy like this guy, this guy. So if you want to find out patterns and relations, representation using graph is easy in some cases. Let me give you another example. This airport data we had. If you're having airports and flight data, right? So let's say I represent airports like this, Bangalore, Chennai, I don't know, USA, somewhere, right? And if I represent all the flights which are going in, I can do this using SQL also, but the graph queries will be much, much more faster for me because this directory structure, right? The graph structure it is easy to traverse in the graph API. So probably between two airports, you have like thousands of flights currently flying. So you want to query them and track something. So always for airport data, we use graph type of a system rather than SQL will work, but it will be slower if the data is really high. Even Spark SQL will be slower. So there's airport management, right? How many flights are flying in real time and so on and so forth. They use this graph API a lot. So only for certain use cases where you are having, let's say, two edges and lot of relations between them. Social media is another example, right? So I want to find out what you like in Facebook, let's say. So I have to do a lot of comparison. How many friends you have and what your friends actually like. Do you actually like that? So traversing these queries in SQL is very difficult. In graph, I can easily traverse. I can just say that these nodes find me these type of relation. It'll easily tell me. So social media companies do use a lot of graphics actually. Even Twitter use. Twitter, how many people are you following and how many were followed by you? So these relations, right? These are all learned from graph APIs in Twitter. So if I have a graph and a property, the property can be an image. I can't directly query the image, but I have the URL and all, right? So I can say that find similar images or with this keyword, so on and so forth. So you can directly handle unstructured data a lot. So, and there is a NoSQL, this is different, okay. There is a NoSQL database called Neo4j. Neo4j. It's a NoSQL database. They store data in graph format. So, I mean, that is a different use case. That is for real-time queries and all. But this company actually uses only graph to store the data. Okay. Graphics is different. That comes part of Spark. Neo4j is a NoSQL database. I had worked in a small project where they were using Neo4j. I didn't learn it actually, but I've seen that people are actually using it. We went one circle further, right? So we are in one more orbit. Okay. Now, let me ask you, what do you make out of this? Who is this? Is there anything special about this picture? Flamingo, okay. What is the flamingo doing? Waiting for who? Be creative, right? So what is the flamingo doing? Standing on one. Yeah, you are very creative. Exactly. This is called standalone mode of Spark. I didn't create this slide. It is Databricks slide. So if you have to blame them. Exactly. Flamingo is standing in one leg, right? So you have to be more creative, okay, for learning Spark. So these are different modes in which you can run Spark, basically. Okay. So don't get confused with the name. So the top one, this single PC, that is called local. Local mode means you are running it locally on one machine. Okay. You cannot expand to more than one machine. And you use only for development and testing purpose. And that's understood. This mode is Mesos, M. This is the icon of Mesos. So originally Spark was created on top of Mesos, I told you, right? So still, if you want, you can install a Mesos cluster, right? And then install Spark on top of that. It will run, no problem, right? And this is standalone mode. So what is standalone mode? I want to install Spark in a cluster, but I don't have Yarn, I don't have Mesos, I don't have anything. Then Spark give you its own cluster manager. That's called standalone. But this is very rare because ideally it will be on Yarn, and this is Yarn, Spark on Yarn. This is Yarn. So ideally in most cases what you see is Yarn, this blue ball. I mean that is Yarn because most of the organizations will already have a Hadoop cluster and Yarn, and it just makes sense to integrate Spark on top of that. Another very important point, lot of people get confused. That is why I'm writing it. Spark has no storage. There is nothing called storage in Spark because it is an execution engine like MapReduce. Is MapReduce having any storage? No. It reads the data from Hadoop, process it, then probably store it back in Hadoop, right? Similar to that, Spark also has no storage. There is no storage component in Spark. It is just an execution engine, which means you should provide the data somewhere. So if you are running Spark on Hadoop, the data is on HDFS. If you are running Spark on, let's say, your PC file system has the data, standalone or Mesos, whichever, up to you to decide. So Mesos, the problem is that some of the other components integration may be difficult. So the real problem is that if you want to purchase, so always organizations will go for vendors, right? That is understood. If I am an organization, I want Hadoop or Spark something, I'll go to either Cloudera or Hortonworks. And if I go to them, they will say what? We'll give you Hadoop and Yarn. There is no Mesos. So commercial vendor support is not there. That is one drawback. That means your engineer should install it separately, everything. So people don't go actually for that. There are some, Apple has a cluster where they run Mesos. I don't know why, but they have a Mesos cluster for some analytics purpose and all. I have never seen in my life, no. Because nobody uses, most of them use Yarn only. Standalone I have seen, but Mesos I have not seen, very rare. Okay, if you are interested, some extra knowledge, Spark can also run on Kubernetes. Spark on Kubernetes is, I think, production ready now. You know what is Kubernetes? Container orchestration, right? You know what is Docker? So you have something called Docker, right? There is something called Docker. This is a very old tool, very old, like 4 or 5 years, I think, I don't know. What Docker allows you to do, you know what is a virtual machine, right? You know what is a VM. So in your laptop, if you create a VM, what will happen? Let's say I install a Windows VM. The problem is that this VM will use a lot of resources, right? Operating system, you have to install everything. So if my laptop has 8 GB RAM, I need to give 4 GB RAM only for the VM. What Docker does, it allows you to create something called a container. Okay, meaning on one laptop, I can run like 10 Docker containers, one Linux, one Windows. It will use the libraries that are already available on my base operating system. So it will not install a full operating system. That's what I'm saying. So instead of giving 4 GB RAM to a VM, I can give 1 GB to a Docker or 512 MB to a Docker. And if it is on Linux, it is much, much good performance. So Docker became a big hit because if you are a programmer, you wrote a Java program, you want to test it. You want to test it on Apple, you want to test it on Linux, Windows. How do you do all of this, right? So you can just launch Docker containers on your PC itself, like 10 of them, run your code, see whether it is working. Very easy, right? Kubernetes is the next level of Docker, where you have something called container orchestration. In a data center, you are able to run multiple containers like Docker containers. You can manage all of them using Kubernetes. If I am correct, it is a Google project. Okay, so it is a data center orchestration. So Docker is like you are running it on one machine, probably 10 machines max. So here, once you install Kubernetes, it becomes a data center manager actually. So you can give like hundreds and thousands of servers to Kubernetes and say that I want these many containers, Docker-like containers. It will launch them and manage them for you. So Kubernetes can become one of this. Instead of Yarn or Mesos or this thing, Kubernetes can become your resource manager. I can install Spark and then I can say that I want to run Spark program. If I say hit enter, it will go to Kubernetes. It will launch containers for me to run the Spark code. So in cloud, you have multiple options. Either you can directly run, say I go to Amazon, I create some machines myself, or I can use these services like EMR, Elastic MapReduce. I can go to Amazon and say that, hey Amazon, I need you to create a Spark cluster for me, say 10 machines, 100 machines. In 5 minutes, it will create and give it to me. And then I can run all my workload. But these are like disposable clusters. Once you complete your job, you have to delete them. Otherwise, you're paying money continuously, right? So Kubernetes is on the cloud also. I mean, it is local data center as well as cloud. So it is available everywhere. I don't know. I have not extensively gone to Kubernetes, but I think you can search because it is something which is coming up in a big way. I think Google is the Kubernetes, whatever you call it. So this is production grade container orchestration. So the problem with your Docker and all is that it is very difficult to manage the containers. With Kubernetes, you can manage them. I don't know the exact architecture of Kubernetes, like whether they launch their own container or Docker container, but basically, so it is all coming to an abstraction now. Previously, everything was very clear. For example, you buy a server and you can see the hard disk, right? Then you install the operating system. Now what Kubernetes says that give me a data center, you don't worry. Data center means group of servers. Give me a group of servers like a data center and I will launch as many resources as you want. You just tell me how many containers you want. I will ensure from where I need to launch, how I need to launch. So like, same like that. So like an abstraction it is getting, right? So, but probably, so it says, Kubernetes built upon 15 years of experience of running production workloads at Google. Yeah. So originally this came from Google. Google was already running this, not in this name, some other name. So they now, even Hadoop came from Google, right? So same like that, they are creating this Kubernetes. I think Spark on Kubernetes is available. That is why I was speaking about this. Spark on Kubernetes. Yeah, very much available. Spark 2.2.0. You must have a running Kubernetes cluster, blah, blah, blah. It is Docker only, okay? Docker images, see? So internally it is using Docker only, nothing else. Blah, blah, blah. Yeah, so it is supported. So it is not in the slide, that's why I'm saying. In the slide, you don't see Kubernetes. Slide is a bit older. And if you pay attention to the slide, I can show you one small change. You have to tell me what is the change, okay, if you pay attention. Somebody is on top of this, right? That is Zookeeper. Zookeeper. Oh, you didn't say I'll show you once more. See, it's gone. Now it will come up. You saw that? So what it technically means is that all these three modes, whether you are running on standalone or Mesos or Yarn, can be highly available using Zookeeper. Zookeeper supports your high availability. If you, like Spark, if you are running, if one machine crashes or you know, if all these states are maintained by Zookeeper. So Zookeeper is integrated with Spark. Zookeeper is another Hadoop ecosystem tool. Why it is used is for communication between the machines, actually, to put it very simply. Like in a very large cluster, if one machine goes down, then how do you know? So I'll give you a simple example, otherwise Zookeeper might become another big problem, right? And Zookeeper is an admin thing mostly, so you don't have to worry about it too much, but still. Do you remember I told you you can have a active name node and standby name node, right? So in a Hadoop cluster, you have two name nodes, right? This is active, this is standby, correct? Now what is the idea? Only one should be working, only active. If the active crashes, this question, who will tell this? That's the question. Let's say I am connecting to the cluster. How do I know who is active? I can't connect to two machines, right? So this guy will have an IP address, this guy will have an IP address. One way is that I can keep on pinging who is active currently. How do I know who is active? Who will tell me, right? There is nobody to tell. So one way is that I can keep on pinging both the machines to see who is alive, who is not alive. So like that, there are many situations in which you have to understand which machine is alive or not alive. So with Zookeeper, what happens is very simple. It is a service. So this active name node will register with Zookeeper. Okay. Standby will also register with Zookeeper. Now you just ask Zookeeper who is active. It will tell this is active. If this guy crashes, okay, this guy will inform Zookeeper that I am the new active. You again ask Zookeeper, Zookeeper will tell you. So it's a coordination mechanism. Zookeeper is used for coordination and high availability. What this slide means is that Spark supports Zookeeper. So for talking between the machines and management and all, it can use Zookeeper if possible, if available, right? So this is the icon of Zookeeper. It didn't just come. This is the actual icon of Zookeeper. You are asking, I know, because normally people are not much aware of Zookeeper. No, it is for all the services actually. Let me show you. So Zookeeper is for any service to coordinate. So one example I gave you is that how do you know name node is working? Ideally, this will not automatically come up. The Zookeeper has to inform this guy to come up. If you look at the architecture, okay, if you implement high availability in Hadoop, normally what happens if I don't have Zookeeper, if this guy goes down, I have to write a command to make this up. That is actually a wastage of time, right? It should automatically come up. So these guys will be connected with Zookeeper and there will be a keep alive message sent. So if heartbeat. So if this guy goes down, Zookeeper will know that this guy is gone. After let's say a second or two, there is a timer you can configure. It will ask this guy come up, okay, and update the metadata here. So basically this guy holds metadata, who is doing what in the cluster. Otherwise you see there are a lot of services in a Hadoop cluster where there is an active and standby. Not only name node, resource manager, your Yarn resource manager is an active and standby. If you take HBase, there is a service called NoSQL. HBase has a master and standby. So if I go to a Hadoop cluster, if I start asking everybody who is the master, who is the slave, it's very difficult. So I go to Zookeeper and this guy will have all this knowledge. Even for Spark, you have an active and standby master, okay, if you're installing Spark independently, and that can be coordinated with Zookeeper. That is what the slide is saying. So any machine which is running, so who will orchestrate all this? That is managed by Zookeeper. The slave machines, if they go down, the driver should know, right? This machine went down, so processing has stopped. So Zookeeper is internally coordinating all these things. See, Yarn has resource manager, right? Resource manager is the master in Yarn, and resource manager by default talk to Zookeeper when you install. So that is the coordination happens between them. Like if you run a program, it is allocating the RAM, and Zookeeper doesn't do resource management. It just remembers who is alive, who is not alive, this information. So Zookeeper by default will be available in most of the clusters. We again went back. Now what? So this orbit is over. Spark can read from almost any file system, and that's by default. HDFS, I don't know what is this cube, by the way. This I don't know. This is S3, Amazon. This is local file system. That is some other file system, maybe in any file system basically. So it supports a lot of file systems even which we are not aware of, right? Local file systems. It can read from all these things, any NoSQL database, any RDBMS. That is, I think, a very cool feature, because I will show you if you have a MySQL DB, Spark can directly read from the table. Or if you have MongoDB or any NoSQL database, it can read from the table and process the data. Output probably it can store back it into that table, right? It also supports Hadoop input formats. Spark streaming can work with Flume and Kafka, meaning you are doing real-time streaming, right? So the question is that how do you get the data? So this is always a challenge, because what happens is that normally you will have a Spark cluster running. So let's say this is a Spark cluster, Hadoop cluster only, where you have Spark installed. So let's say you have a Spark cluster running. I want to get Twitter data. So actually Spark can directly get the Twitter data. There is no problem. It can directly come to the cluster and you can process it. But the problem is, if one of the machine who is receiving this data crashes, you will lose the data for some time, right, in Spark. So what you can do in this architecture is that for high availability, you can either use Flume or Kafka. So you can ask these guys to get the data for you. Flume or Kafka. So Flume is point-to-point delivery of data. Like I can configure a Flume agent, we will see in the webinar, which can get the data from Twitter to here. Kafka is a message queue. So you can get the data from here. So even if your machines are not working, data will come here, right? You are not losing the data. So for that reliability, you are using Flume and Kafka. There is a different thing you have to be aware of. If you have a Spark cluster, right? So this is a Spark cluster. And I'm talking only about Spark streaming, okay? Not like normal processing. When you configure Spark streaming, one of the machine will start working as something called a receiver. Okay? So what is this machine's job? To get the data. That's all it cares. And it is a normal data node. Now, the drawback of Spark streaming, not the drawback, I can say, if this machine crashes, okay, your stream will be lost. Of course, it will switch to another machine, but it may take some time. So that, let's say 5 seconds or 10 seconds, you are losing the data, right? You are not storing it anywhere. Correct. So if I want to avoid this, if this machine goes down, then my stream will be gone. If I want to avoid this, what I can do, I can say Kafka, hey, get the data in Kafka. Okay. From there, I'll get it to Spark. Even if this machine crashes, another machine will come up, the data will be available here. So Spark streaming, if you want reliability, you have to use Kafka or Flume. Direct stream, you may not have reliability. Slide, some of you are asking, will some of the tools go extinct? Yes. Your Hive, now nobody is running a lot of Hive queries, everything is Spark SQL queries these days. And Mahout for machine learning, everybody has migrated to Spark MLlib. Storm, most of them are in Spark streaming now. And this slide just compares the different ways in you can run Spark. For example, instead of MapReduce, now most of us are using Spark. The resource manager can be Yarn or Mesos. Doesn't matter, any of this. And the storage level in Hadoop is HDFS. This Tachyon is not there now. Tachyon was a storage manager like in 2009, long back. When originally Mesos came, the storage was handled by a system called Tachyon. Now this is renamed as Aluxio, this project. It is still there. It is a storage layer like HDFS only, distributed storage you can get. So one common problem in Spark is that you will try to bring the data from different places. Like Spark will be running on Hadoop, but maybe some of your data is in Hadoop, some of them is in DBMS, some of them is in Cassandra. So if you use normal HDFS, it's fine. If you are using this Tachyon, or now it is known as Aluxio, it has a caching layer. So it can speed up your processing by caching the data. That is only advantage. Not extensively used because setting it up and all are a mess actually. Okay, I have seen it once. That time it was called Tachyon only, not Aluxio. I think they renamed it. If my memory serves me well, Tachyon is Aluxio now. Spelling I have to look into. Aluxio or Aluxio, whatever you call it, I don't know. Aluxio, formerly Tachyon. Open source, memory, speed, virtual distributed storage. I don't know how many technologies are there, so many other actually. This is like, so let's say you have tons of data and you need a storage layer in between, caching layer to make it faster, then you use Aluxio. That is only use case. Otherwise, everybody is using HDFS only, normal HDFS. In SSD caching it will do. So it is costly, also it is costly but faster. But only use case is that if you are processing a huge amount of data, like we had like Bank of America. Bank of America, they had like tons and tons of data to process, like terabytes of data. And it keeps on coming. So storing them on HDFS, first time read will be very slow. Anyway, will be very slow. So they push directly to your this thing, Aluxio, because that's an SSD caching layer. From there they read it. So the read is faster actually. That is only use case you are seeing for Aluxio. And this is another use case of it, right? You have on-premise storage and cloud storage, and you are getting the data. It comes to an Aluxio layer. From there, you can start your computing. So it is a storage layer abstraction. You can store data in multiple places, okay? And Aluxio will get it in one place. From there, you can start processing. So it is like bringing the data into a caching layer and then processing it. Okay. Don't worry, if you don't know Lucy also, it's perfectly fine. It's not like an a mandatory component or something. Okay, now can you tell me what is a drawback of MapReduce, if there is any drawback? What do you think? So Spark is replacing MapReduce, right? So what is a drawback of MapReduce that you saw? Yeah, so mapper output you persist, then shuffle output you persist, then of course reducer output you have to finally persist, right? So that is why MapReduce is very, very slow. So that is what is in the slide actually written. So, and if I have to do an iterative processing, right, I read the data and 10 times I have to process it, then I have to schedule the jobs, 10 MapReduce jobs I have to run, because it is very difficult to chain them together. Intermediate read and write always will be there, right? That is where Spark becomes very different, because, and this slide just says that you can use Oozie to schedule all these jobs, nothing else. Spark does something called in-memory processing. And this is very confusing for many people. The first thing you need to understand is that in-memory processing means it will use RAM if available. It doesn't mean that you always need to give RAM. If RAM is provided, so let's say you want to process 10 GB file, and if your cluster has 10 GB free RAM, it will read it into the RAM and it will do all the calculation. Only the final output it will push it into your hard disk. Intermediate results are not stored onto hard disk. Second point is that it will, what if RAM is not available? Then it will start using hard disk also. Step by step it will read. It will read whatever data that fits into the RAM, process it, then again it will read it and process it. Like that it has to go. There is no other way, right? If you don't have RAM, still it is faster than MapReduce. Okay, because from ground up they have designed the code of Spark. They have not modified MapReduce code or something to create Spark, and that is why here it says 10 to 100 times faster than MapReduce, typical MapReduce, right? So in memory processing we will see how it is faster and all. That end is Cassandra, that I, there is Cassandra. It just demonstrates that you can store the result in Cassandra. From anywhere you can read and store also. These are the distributors and applications which uses Spark. So of course Databricks is the major distributor, and Hortonworks, Cloudera, all these guys are having Spark as of now. And these all applications can use Spark for processing. So mostly BI tools and all, right? Visualization tools. So previously, if I'm using something like, where is it? Pentaho BI, okay, to visualize my data, what it will do, it will fire a query to my Hadoop cluster. Hive will run the query and visualize it. And now Spark SQL will run the query. So it's much, much faster. So all the BI tools and the ETL tools now use Spark for moving the data and processing the data and so on and so forth. Okay. This slide is a bit old. This is the 100 terabyte sort competition in 2014. So every year there is a sorting competition that will happen. Even you can participate if you want. So the thing is that they will give you 1 terabyte of data. Okay. You have to sort it. Okay. And the data, they will already give you the format and all based on how you have to sort it. Is it integer sorting or quick sort or what sort, they will tell you. They'll already give you the data also, sample data. And you have to write an algorithm to sort. Can be a Java program, any program you can write. And whoever sorts the data fastest will win. That is the conclusion. And in 2014, when this ran, Spark did it in 23 minutes, Hadoop in MapReduce in 72 minutes. But look at the cluster size. Spark was running on 206 machines. MapReduce was in 2100 machines. That is a difference. 1/10th of machine, still it is faster. Because a lot of RAM was available, everything was in memory, so faster sorting will happen. And even for 1 petabyte, they did a sorting, and again, Spark became the winner there. Okay? Do you know what is a driver? These are some things you require, otherwise you cannot understand Spark, that's why. What is a driver, you know? Not device driver, okay? Which drives the program. That's actually correct, right? Driver is the guy which, So when you're writing a Spark program, the program will have something called a driver. Okay, and this is the master of the program. Driver is the master of the program. And then you have something called executor. This is the slave. So let's say I wrote a Spark program. In the Spark program, definitely there will be a driver and an executor. Without that, the Spark program cannot run. I mean, these are logical concepts I'm saying. Okay. Now, when you want to run that program, okay, one way you can run is that you can say run it locally. I can say that, hey, I wrote a Spark program, okay, run the program local. When I say local, what will happen is that a JVM will be created, like a JVM, okay. Both my driver, executor, everything will be inside this. So this is the local mode of Spark. Java virtual machine. Still a container will be created similar to this. JVM in a general I'm saying, okay. So a container will be allocated. So this is like a yarn container. So a container will be allocated. In that both your driver and executor will run. So the local mode is not very efficient because you will get only one container and everything is running inside that. Right? So if you're submitting the Spark code, actually when you say you have a Python code, right? It will read your logic and will convert and run it inside a JVM. End of the day, everything is inside a JVM only. Without that, it cannot run. Even MapReduce programs, we wrote in Java, right? We can write Python code in MapReduce. So if I'm writing a Python MapReduce program, if I run, I will say submit the program, then I have to mention some jar files. And those jar files will be in Hadoop. They will read your Python code and convert that into a format which will run inside a JVM and execute inside a JVM only. Because end of the day, it is written in Java. Or if it is Spark, it is written in Scala, right? So everything has to be inside a JVM. So the local mode, the problem is you get only one container. Inside that, the driver and executor, everything will run, okay? So this is only good for testing purpose, right? So you just want to test a Spark program or you want to learn Spark, you will normally say that, hey, Spark run in the local mode. I write some code, it just runs. If you are in a cluster, this is where things becomes more interesting. And this is a bit confusing also, okay? So this is my Hadoop cluster, right? And I have 4 data nodes. Imagine. I have 4 data nodes. Imagine. I created a Spark program. Now the first question is that when you are running the Spark program, what are you analyzing? Okay, I am analyzing a file. What is the size of the file? Right. So let's imagine the file is in Hadoop, okay? Just a simple use case. The file is here, here, and here. Just an example. And somewhere. The total size of the file is, let's say, 10 GB. So I have a 10 GB file in Hadoop. That may be in blocks and all, so that's understood. And I want to process it using Spark. Now, and that is in a cluster, right? So when I submit my program to a cluster, I have to ask Yarn for executors. How many executors you want and what is their capacity? Meaning, I can either say, hey Yarn, give me 1 executor. And in that executor, 20 GB RAM I want. No problem. What will happen? An executor will come here. This is your executor. It's a container, nothing but a container. And this has, let's say, 20 GB RAM, okay, and some 4 processor core or something. And then your entire Spark code will get executed inside this. But normally people will not do this. This is like one machine is executing everything. So possibly what I will do is that I will ask Yarn, hey Yarn, give me, let's say, 4 executors. Just an example I'm saying. Give me 4 executors. So Yarn will give me 4 executors, right? And each executor, I tell Yarn, give me 5 GB each executor. This is 5 GB, this is 5 GB, this is 5 GB, this is 5 GB. RAM in memory. So total 20, but 5 GB, right? And so imagine there is, and then there is a driver, right? So this is executor. Imagine you have 5 nodes in this Hadoop cluster. So here my driver is running. Okay, so what will happen when you submit the program in one of the machine, the driver will start running. And in the program you have asked Yarn, give me 4 executors, and each executor I want 5 GB RAM, 2 processor core, blah blah blah. So Yarn will launch 1, 2, 3, 4 here, and whatever code you have written, this driver will push into all 4 machines at the same time, and each machine will process your code. This is how in a cluster Spark is processing. But this is not so easy as it looks like, because you should know how much memory you need for processing, right? And how many executors you want. Will Yarn actually give you those? I cannot say that give me 100 executors each with 100 GB RAM. Yarn will say that I don't have capacity, I can't give you. So normally wherever I have went for consulting and all, if you write a Spark program, you will discuss with your admin. Okay, I want to write a Spark program, because in Spark, if you want to get the full performance, it should be in memory. You need maximum RAM, and that is a challenge in every Hadoop cluster. So you will go to your Hadoop admin or Spark admin and say that I have written a program, I need 100 GB RAM in the cluster. So he will tell you, in your program you ask for, let's say, 10 executor, 10 GB each, something like that, right? That you will configure as the number of executor, how much RAM you want, and then you submit your program. So Yarn will launch these things, and the driver will be running on a separate machine, right? And whatever logic you have written, so driver will read and start pushing to all executors. And the output normally comes back to the driver, whatever output you have. In the driver, you can write a logic, either store the output on Hadoop or store it in Cassandra or wherever you want. That is possible. And this driver normally will be your app master. This is your app master. Remember app master from Yarn? That is your driver. So a lot of people ask, what if this machine goes down? My driver machine goes down. Obviously, if your driver machine goes down, then the processing will be disturbed. Now Spark program will not crash. Okay. In Yarn, you can configure application master restart timer. So restart. So if this machine goes down, it will restart your AM on another machine, application master on another machine, so that it can continue processing. This application master is in constant touch with your resource manager. So there is an ID, application ID, where it will not tell what you have processed or what execution is going on currently. It knows those things. So your resource manager will launch one more application master that will become your Spark driver, get the code, it starts running from there. So the driver is the master part of your program, and these executors are where you push your code. So depending on your cluster, you can ask for the number of executors and how much memory you want for each executor. That is how it actually runs. And there is something called application master restart timer you have to configure in Yarn. There you can say 3, 5. So it will try to restart it, the application master, on the same machine. Sometimes what happens is machine will not crash. Your application master will crash. The driver process will crash. So it will restart it on the same machine. Can be due to many reasons. Maybe the resource not available. So you can configure that timer. And if it doesn't work, then only you'll go to another machine and say start from there. You need to understand something called RDD. Okay. So that is why RDD fundamentals it is written. So RDDs are the basic building blocks of Spark. So first thing you need to understand is that in Spark, your data is represented as something called RDD, right? Any data that you have, if you want to process in Spark, the first step you do is that you create something called an RDD. RDD stands for Resilient Distributed Data Set. It is like a variable or a pointer, you can say, right? So these slides will give you some idea about RDD. I will also practically show what is an RDD, right? So, just look at this picture. This picture is very good in understanding how Spark is working, right? So I have 4 blocks of data in Hadoop. So that is what is represented there. HDFS, right? So you know 4 blocks of data is there, right? And I want to process them. Now that is one file. Even though it is divided into 4 blocks, it is one single file I want to process. And what is this data? It's some text data. Imagine each block has like this, error, then a timestamp and a message. Again, warning, some timestamp and a message. Some log file, imagine, right? 4 blocks of data. So we are assuming they are on 4 data nodes and you want to process them. Now from here onwards, it is going to confuse you. Okay, so I'm saying in advance, you will get confused. Okay, but don't worry. So where is your original data? In hard disk, right? As blocks in HDFS. So that you have to keep it in your mind. Now, I have already written a program, imagine, to process the data, right? In the program, the first step I need to do is to create an RDD. Okay, so I have to say that create an RDD. An RDD is like a variable, you can say, or a pointer. So here, the name of my RDD is called log lines RDD. You can call it Raghu if you want. I just say create, hey Spark, create something called log lines RDD by reading the data from this file. You can give the location, where is the file. And if I run this, what is going to happen? And imagine in this case, I have asked for 4 executors. In my Spark program, I said, I want 4 executors for some reason. So what will happen in each data node, one executor will be launched in ideal situation, right? And I have one block on each data node. And I say, hey Spark, create an RDD called loglines RDD for me. And if I hit enter, all this data will be copied into the RAM or the main memory. Because RDDs represent your data in memory, assuming RAM is available, ideal condition. So if I redraw this picture, this is actually a Databricks picture, right? But if I redraw this picture, now don't think that always the file is in Hadoop, right? In my typical example, I have the file in Hadoop. But there is one small thing here. Let's say you have 6 nodes in Hadoop cluster. 1, 2, 3, 4, 5, 6. That is the same architecture. And block 1, 2, 3, 4. Now the big question. You want 4 executors. Which machines will launch the executor? Yarn. Yarn has no data locality awareness, right? Yarn doesn't know where is your data, right? In MapReduce, data locality is there because your blocks are residing here. Let's say your blocks are here, right? So these are the 4 blocks. I write a MapReduce program. What is going to happen? In my MapReduce framework, it is written that, okay, I need to have 4 mappers. One more very important point you need to remember. In MapReduce, if I'm processing the same data, 4 JVMs will get launched. Correct? 1 here, 1 here, 1 here, 1 here. And this will copy here, this will copy here, this will copy here, this will copy here. That is how your mapper runs. Because can you process 4 blocks using 1 mapper? Not possible. You will have number of mappers equal to number of blocks or number of input splits, we say, right? Ideally, you can say number of mappers equal to 1, but then what is going to happen? This block will process, this will go, then the next block will come and it will process. This is your yarn container in MapReduce. So when yarn is launching containers for your mapper, ideally how it launches is that it will launch one container for each block, right? And your block size is fixed at 128 MB, right? So in yarn settings, you will say that my container size is 1 GB. I want 1 GB container, right? And what will happen? 1 GB, 1 GB, 1 GB, 1 GB, 4 containers will be used. It is very rare that manually you mention number of mappers. You can't ideally do that because that will affect your performance. And also if you are launching 1 container only, you can't resize it. So this is like a 1 GB container. And I have never seen anybody using static mappers. In 99.99% of the programs, you will never touch the number of mappers. You will just say, I want to process it. And ideally, if you have, let's say, ideal situation saying 4 blocks, you will launch 4 mappers, right? Each block will copy to 1 mapper, your mapping phase is over, then reduce or whatever. Spark is different. In Spark, one of the core principles is that you can control how many containers you want and what is their size also. So I can say I want 4 containers in Spark. So now we are talking about Spark, okay? In Spark, I can say I want either a single container, that's what I'm saying, executor. I can say I want only one executor and this guy has 8 GB RAM. So it will launch only one. And these 4 blocks can come inside this and get processed. Fine. Or I can say I don't want one executor. Probably I want to leverage parallelism. I want, let's say, 4 executors. But the point is, when you say you want 4 executors, there is no guarantee these 4 will come here. It can be here, 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 here also. In that case, this block need to be copied into the RAM of this machine. So initially there may be a delay to get the data to that RAM, then it will be same. There are 2 things. There is something called Spark dynamic execution allocation. You can enable it and disable it. If you enable it, what will happen? It will launch 8, kill 7. Only 1 will remain. If you disable it, it will keep 8 as it is. So there is a property called set spark dot dynamic execution enable or disable. That is to Yarn. So you are telling Yarn, I want 8 executors, but don't kill everybody. I may use it or may not use it. So it will keep it for you. If you enable it, that is where it will kill. You are saying that if it is not getting used, just kill them. I don't want them. So if your data size is small, it will kill them. Remember, you can actually see in the Spark UI 5 of them coming up and then remaining them will getting deleted automatically. You can do that, right? But coming back to RDDs and our discussion, I am saying that in that example, you have 4 blocks of data. So that is these 4 blocks. My Hadoop cluster is, let's say, 6 nodes. And you want to read this data and process it. So what you say, I want to create an RDD. The name of the RDD is called loglines RDD or whatever. RDD is just like a pointer, okay? And when you do that, when that code runs, what is going to happen is that you ask for 4 executors also. And let's assume the executors are launched here. So there is an executor here, okay? There is one more guy here, one more guy here, and one more guy here. So these blocks will be copied to here. So now where is your data? Your data is residing inside the RAM of 4 machines or 4 executors. This is called an RDD. Because otherwise, how do you call it is your data? You need some way to mention like a variable. So that is called your RDD. So now once the data is available in the RAM, let's say now the data is there, you have a representation to your data. So this entire log file is now called loglines RDD. Also, in Spark, there is something called partitions, meaning right now your data is lying as 4 blocks. So we say that this is a 4 partition RDD. So normally when you're reading from Hadoop, you will have blocks. Each block will become a partition. What if you're not reading from Hadoop? Let's say I'm reading from my local PC. I can mention how many partitions I need for the data. Say on my Windows laptop, okay, I have a 1 GB file. If I simply read it, it will come as a single 1 GB partition. Okay. If I want, I can say that, hey, this is in my Windows laptop. Okay. I can say that, hey, Spark, read this 1 GB, but create 4 partitions for me on this. What is the advantage? Each partition can go to an executor. An executor will process a partition, not a file. So always your data has to be partitioned. The more partitions you have, the more parallelism you will get. Or let's say you're reading from Cassandra, a typical example. Cassandra is a NoSQL database. Cassandra doesn't have blocks or anything. Blocks are on Hadoop. So if I get the data from Cassandra, I read a table, I will get 1 million rows, right? 1 million rows, I cannot give it to an executor, right? Then the processing will be very slow. So what I will do, I have to have an idea about my data. Let's say 1 million data is 1 GB or something. I will say that when I'm creating an RDD, I can say that take this data from Cassandra and divide it into 4 partitions. Each partition will go to an executor. An executor can manage more than 1 partition also. Minimum 1 partition it should get. Depending, so let's say I have an executor with 20 GB memory. So let's say a partition size is 1 GB. It can manage 20 partitions. So data locality is not 100% guaranteed when you launch an executor. 100% it is not guaranteed. So is this clear? Because you have to figure out the number of executors. Okay, first thing, that depends on what is the size of your data. So in Hadoop, normally this is not required, because in Hadoop what happens, by default a block is a partition. right? But again, that will make sense because what is the block size in Hadoop? 128 MB. 128 MB is the block size, right? So I have a file with that is divided into 10 blocks. So total size of the file is this MB, that is 1.2 GB. I want to process 1.2 GB file. Now the question is that how many executors I need. That depends on your cluster configuration. I can even process this in a single executor. I can ask, hey Yarn, give me one executor, 2 GB RAM or 3 GB RAM, just a safe side I'm saying. So Yarn will launch one executor, let's say 3 GB RAM, okay? And this has 10 partitions. This file has 10 partitions, 10 blocks. All 10 partitions will come in that single, container, get processed. So this executor, right? So this executor you are launching, okay? So you can ask how many executors you want. So the more partitions you have, more processing speed you will get. This same example if you take, so I have 4 partitions, right? 4 executors I launched and each is getting loaded into one partition. This will be faster. I can also launch a single executor here, copy all this 4 here. It may not be so fast. And another very important point. So these are all related to resource management, but you should also understand this stuff, right? An executor is a container, right? A JVM. One processor core is required to manage one container. Meaning, if this is a dual core machine, how many maximum executors you can launch? 2. If you ask for 8 executors, what will happen? It doesn't work. So an executor is a JVM. To manage a JVM, JVM has RAM and CPU. RAM, you can say, I want 8 GB RAM, 10 GB RAM, fine. But within that, to manage, ideally, for a single JVM, one processor core will be allocated. Minimum one processor core, right? But again the question, if I have 16 GB RAM, 16 GB RAM for a container, that will have lot of partitions inside that. Maybe one CPU core is enough to run all of them. Depends on what is the processing power of your machine. But you have to keep all these things when you're launching a cluster. Performance side I'm saying. So to put it short, ideally you don't have to do these many things. When you're launching a Spark program, you should know the size of your data and how it should be chunked. So the idea is, if the number of partitions are more, so let's say I have a file, whatever the size may be, X, size is X, right? If the number of partitions are more, that means the number of splits are more, ideally. So I'm saying that I want 10 partitions. So I get 10 partitions. Now, if each partition can be inside an executor, 10 executors can process that data. So parallelism you get. But if it is less, let's say I want only 2 partitions, then they are in 2 executors, then 2 executors. So ideally your this is less, what you say, processing. So the more partitions you have, the more processing power you can get. So if you are loading, let's say, a text file, right? So if I am loading a text file, I can say that create an RDD, number of partition 5. So what, it will equally split that text file into 5 and then give it to one executor. But the point is you need 5 executors to process it. So if you go to Yarn, Yarn will say, I don't have enough, so I'll give you only 2 executor. So 2 executor will get 5 partition. One guy will get 2, another will get 3. So, and each executor is having 1 CPU core, right? So it will be a bit slow. So if you have enough resources, parallelism works actually better. Ideally, in a Hadoop world, your data is divided into blocks. Each block is in a data node, and that is one partition. So if I'm reading a file from Hadoop, if that file has, let's say, 20 blocks, 20 partitions will be created. But now when I get 20 partition, the question is that should I load them into 20 executors? Can I get 20 executors? Maybe not. I will have only 10 executors maybe. Also, in that executor, how much RAM you have, how much CPU core you have. But these are not just admin topics. The developer has to make a choice here. If you have a file, this is your file, right? This is your file. And this file is divided into 10 blocks in Hadoop. Okay. So I have what? I won't exactly write it, but let's say 1, 2, 3, 4, 5, 6, up to 10 blocks you have. Okay. Now to answer your question, right? When I read the data into Spark, it will automatically do something called partitioning, and each block will become one partition by default, and you cannot change it. Okay, by default it is one, and most of the cases we keep it. But what you can do, so I get, this is one block, this is one block, so all this is red. So this is my partition 1, partition 2, partition 3, right? This is what? Partition 4, and I have partition 10, similar to input splits. So you have 10 partition. Now you want to process it. That is where the speed and all matters, right? To process it, what you need? You need RAM, you need CPU power, right? So where this partition will go, this is hard disk. Blocks are where? This is hard disk. Blocks are in your hard disk. When I say I create a partition, partition is in RAM. It won't just sit in the RAM. It has to be inside an executor or a JVM, right? That is where the data should come. Then only the processing should start, right? So then you can decide, I have 10 partitions. Okay, how many executors I need? Can I ask for 10 executors? Yes, you can do. You can say I want 10 executors. Okay, so you will get what? Executor 1, and here you will get executor 10. And each partition will go to an executor. Partitions always go to executor. So this P1 will go to this executor. Now this executor, I have asked for 1 GB RAM for this executor. I also have 1 processor core. That means this partition can be managed by this executor. Same, your P10 will go here. Okay, this executor also have 1 processor and 1 GB RAM. But the point is, your yarn should allow you to give you 10 these things. The same thing I can do in another way. I ask for only 2 executors. Example, okay? I ask for 2 executors. This executor has 5 GB. This executor also have 5 GB. This has 1 processor core. This has 1 processor core. And P1, P2, P3 up to P5 will come here. P6, P7, P10 will come here. Logically, Spark actually segregate them. Partitioning is just to understand that you have different splits on the data. But now if you write a program, so let's say I wrote a program, I say filter the data. So my driver is here, right? This is what? My driver. In my driver, I said filter the data. Where is the data? In partition. So this filter is your logic. This logic will be pushed to this executor, and this filter will apply here, 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 here. Who will apply? This processor and RAM together, right? So 1 processor core I have. Using that 1 processor core, can I parallelly run this? Probably. I have multi-threading and all. I can parallelly process this much amount of data. Good. Otherwise, one by one it will process. It will take some time. Depends on how much you have. Yes, your processor core you can increase. You can even say I want 4 cores for the container. When you are launching this executor, I said 1 core by default, right? I can also say, hey yarn, give me my executor. Each executor requires 4 core. But then the problem is, if this is a quad core data node, only 1 executor can be launched because you already took 4 cores. If you ask 1 more, you will not get, right? If this is a quad core data node, if you launch 1 executor, you cannot launch another executor. Already you have taken 4 cores. So in production, how we do it is that once we design our application, we look at the data, from where the data is coming. Will it already come partition, or you have to partition? Because if you are reading from Hadoop, it already is partition, like blocks and all. But if you are reading from Cassandra, Cassandra doesn't by default partition the data. So you get like 1 big chunk. So while reading, we decide, should we partition? Yes, we partition. How many? 10. So 10 means what will be the size? This much. So how many executors you need? So then you go to your admin and say that, can I launch a Spark job with this many? Will I be getting? He will say, yes, you will be getting. Then you launch them. Now, if you have understood this much, I'm going to again confuse you, because if you ask for an executor, right? You say, I want an executor. And how much memory you want executor? You say, I want 10 GB. By default, you get only 90% of it. Okay, because 10% is allocated for system calls. It is a container. It has to accept system calls and respond. So you say 10 GB is full, it will not give you full 10 GB. 10% system will take. So what you get? 9 GB. In this you will not get. In this you get only 60%. So ultimately some 54% of the RAM only you will get. Because it is a JVM, right? There is garbage collection, JVM management, all that requires memory. So in reality, if you look at a Spark cluster, if you ask for 10 GB container, you get around 5.8 GB for RDD. Remaining all system will take. Please keep it in your mind because this is an interview question. So you will go and say, 100 GB RAM I will get. They will say, no, it will not, boss. So by default, if you ask for 10 GB, 10% system calls will take. Container has to communicate with your operating system, right? And yarn. So for these things, it will reserve some memory, right? So from 10 GB, you became 9 GB. In this 9 GB, your JVM has to manage its garbage collection and communication. All this, it will take another, I think, I don't know the exact number, 30% or something it will take. It will drill down to total, I think 54 or 56% of this 10 GB only your RDD memory you will get to actually fit the partition. Which means in 10 GB you get roughly around 6 GB to fit the partition. So don't think that you get a JVM 10 size, you can fit 10 GB of worth partition. No, it doesn't work like that. So these are actually internal to Spark, but when we run, we will understand. I mean, in production when we run, because then your calculation will be wrong, right? If you don't understand this, your calculation will be wrong. So these calculations will matter for your interviews and all. That's what I'm saying, because if you go for a typical interview where if you say, you know, Spark, these are the things people ask usually. I mean, they won't ask like, hey, what is the difference between Spark and Map? Anybody will say that. They know that, right? So these are kind of questions they will ask, from where you get memory, who will give memory, what will happen if I do this? Even I'm not an expert on Spark. I have started working like 3 years almost, but you know, some of the things even I am very surprised. Sometimes you will say, oh, this is possible. I didn't know this. So then you run it and see that, okay, I can see this, right? Not everything you can't learn also in Spark, right? Okay, so this part, partitions and parallelism. So now if you look at the picture, does it make more sense, this picture? So you have 4 blocks. You ask for 4 containers, 4 partitions, ideal case. Each is loaded and that's called your RDD, right? Now the real question, how do you write a Spark program, right? Basically, that is what you want to do. Apart from RDD or RAM and all, once you get the data, you should analyze the data. So how do I analyze the data? In Python, did you learn something called a higher order function? So normally when you write a Python function, you will say function, then function name, blah, blah, blah. That's how def and all, then you write a function. And you will reuse the function. Why are you creating a function? You can call it anytime. There is something called anonymous function or disposable function. Let's say I want to create a function. I will use it only once. I don't want it anymore. So you don't have to really give a name for the function or definite. You can create it on the fly. That is called anonymous function. It's called anonymous function. Anonymous. Okay. In Spark programming, what we do is that we have something called higher order function. There is something called higher order function. What is a higher order function? Let's say I have a function called ABC. I can pass another function to this function. That's called a higher order function. Meaning this ABC is a function. And normally you will pass some parameter or something, some value, right? You will say A is this, B is this, that is what you send. But I can have a function and I can pass another function to this function. That's called a higher order function. So we will be passing anonymous functions here. This lambda is an anonymous function. I will show you the code, it will become better. But in Spark, basically what we do is that once you create an RDD, now you have the data ready. Your data is, now I want to process the data. How do you process the data? You have something called transformations. So it is actually there in a Spark website. It's also good that you can look at Spark official website. How do you go? Spark spark.apache.org. Yeah, so spark.apache.org is the official website of Spark. And if you go to documentation, it will say latest release is 2.3.0, right? And these are the older versions and all. If you click on here, you can see all the Spark versions. You can see that 163 was the last Spark 1 version. Now we are on 2.3.0. This is our version, I mean latest version. And if you go to documentation, let's say latest release, imagine latest release, okay? If you scroll down, okay, here you can see RDD programming guide, see? And if you click on this, okay, and scroll down a bit, this we will come back. You can see Resiliant Distributed Dataset or RDD. This is what we created, right? So we just created an RDD, at least theoretically. So once you create an RDD, I will show you how to create it, okay? You have RDD operations. So now my data is available as an RDD. What can I do with the RDD, right? So that is where you can start writing your functions, okay? Anonymous function. And yeah, these are the transformations. This is what you need to understand. So these are all transformations you can use in Spark. Map, filter, flap map. There are many actually. So if I want to filter my data, I will just call this filter, okay? If I call filter, it will ask me, what do you want me to filter? Within this bracket, I will write my expression to filter. That is how you filter your data. Map is another, it is like for each, okay? Map I will call, map will ask me like, what do you want me to do? So you will write an expression within map, what map has to perform. So these are all higher order functions, map, filter, flat map, these are all higher order functions actually. So you do something called transformations. In one RDD, if you apply any of these functions, it will create a new RDD. That's called transformation. That is how you analyze your data. Let's say I want to filter my data, I will call the filter transformation. And RDDs are immutable, very important point. Once you create an RDD, you cannot change it. You can only create another one by applying some logic. You can never edit an RDD, they are immutable, right? So if I go to my PPT, yeah, so we have created our log lines RDD, fine, till this we have understood. And then what I did, probably I'm interested only in error messages from this RDD. So you see there are a lot of data, info, warning, error. I want only error messages to filter. So what I can do, I can call the filter transformation, okay? So I can call a filter transformation and then I can say that, hey Spark, okay, match only error lines and give it to me. And I'll show you how to write the logic. This will produce another RDD and I can call it as errors RDD. This is the steps in which you write a Spark program. First you create your RDD and now I want to do a filter. I will call a filter and it will, change whatever. I mean, it will filter only error messages and that I will store it as another RDD. Now somebody was asking me what will happen to the memory, right? So it will delete this RDD. I mean, if there is not enough memory. So let's say this RDD fit into the memory and then you call this filter action. It will filter whatever is required and this will be gone. This is not required now because you have this, right? Because next processing will start from this step, okay? Originally, let's say, assume in the normal use case, you call a function, it creates another RDD and this RDD is gone now. Now this is your current data. So if you have enabled in Yarn dynamic allocation, then this will be gone. I told you, right? This is actually a partition and there is an executor running here. Now this guy will be idle because it doesn't know what to do. It cannot predict that there will be no data, right? So that is one more problem. Now your problem is you have 4 executors. The second executor has no data to process because it filtered all the error. There is no error. Now this guy will be sitting idle. So one data node will be there, one executor will be there that has no data. It will simply sit idle. So that becomes a problem, right? How can I solve that problem? It's actually very easy. In Spark, there is a transformation called coalesce. Coalesce is a very common transformation. And why do you call coalesce? You pass a number, it will reduce the number of partitions. You can resize it. Because, and you have to calculate this, but in this example, assume you know that. See, now if you look at the data, Second partition is empty. Third partition has only one line. That's also not so. So I am assuming that I want only two. So I can tell Spark, take this RDD, apply coalesce, keep all the data, but delete two partition and two JVM. I want only two. So it will just bring it into two partitions now. So you have to do tests. So normally what you do is that you sample it. For example, just an example, if you are having 1 terabyte of data, right, and you take a good sample of that data, let's say 10 GB or 100 GB, and you run it once. So then you can understand, after the filter, okay, you can call a collect action. So let's say after the filter, I want to see the data, I can do it. So I know that originally I loaded, let's say, I don't know, 1 GB data or 10 GB data. After the filter, when I get the data, it's only 5 GB. That means half is reduced. So I can calculate, okay, if I'm loading 1 terabyte of data, I don't have to manage these many JVM. So after this step, I should call a coalesce. I can do that. So there are two transformations, coalesce and repartition. Coalesce will always decrease. There is no way you can increase. If you want to increase, you can say repartition. From 4, probably you want to go to 8. Maybe you want to increase the processing power. Let's say I want to divide it further. I have probably some JVMs free. Okay, so I can increase the repartition the data. So I can say from 4, I want 8. So I can say repartition, in bracket I can say 8. So even though if a partition is empty, the JVM will keep it. There will be no data in the partition, but it will remember that I have a partition called P1. There is nothing. So Yarn will not delete it. Yarn will think there is something inside it. Yarn cannot actually go inside and see whether you have something. Where I told you is that initially when you're creating the RDD, right? So let's say you mentioned 10 partition. Okay, you ask for 20 container. Only 10 will be created, 20 will be ideal, nothing will be there. Then it will delete. Here you have to manually do a coalesce to reduce this actually. Okay. So now you have two partitions actually, because we just wanted to optimize the code. So now you have 4, I say repartition 8. Okay. It will read the whole data, do a full shuffle and just keep them on 8 partitions. Now, since you have asked this much, repartition can also be used to decrease the number of partition. Coalesce is actually intelligent because if you're doing coalesce, okay, what will happen is that this message might go here. This message might go here or there and we'll just delete these two. If I'm doing a coalesce, there is very minimum data movement. If I do a repartition, it'll do a full shuffle. Meaning from here I can say repartition 2. It will do it for me. But before doing that, it will read all this data into the RAM and do a full shuffle. Then only it will reduce. So there is maximum data movement in repartition. So ideally to reduce your number of partition, use coalesce. To increase, there is only one way, that is repartition. There is no other way you can use. Now the most important point, surprising to you, is that let's say you wrote a Spark code in which you wrote these 3 lines. Create an RDD, filter the RDD, you say coalesce. And you say run, nothing will happen. This is the surprise actually. You wrote a Spark code where you wrote all these 3 lines. Okay, read from HDFS, filter error message, then you set coalesce and you submit the job to the cluster. Nothing will happen in the cluster because all of these are lazy. There is something called lazy execution, meaning Spark will not start execution unless you call something called an action. These are transformations, meaning you are changing the data. But you are never saying that show me the output, right? You are saying repartition the data, filter the data. Okay, so what? Where are you saying show me the output? You are not doing that. So unless you call something called an action, where you say that give me the output, nothing will work. To do that, you can call an action called collect. Collect is a most common action in Spark. When you call collect, okay, you are telling Spark that I want to see the final output. That's it. So collect will look at this cleaned RDD. So you are asking, give me the output of this cleaned RDD. And Spark will understand, if I want cleaned RDD, I should have errors RDD. If I want errors RDD, I should read first. It will go to your hard disk, read the data, do all this stuff, and then show this is the output, right? Show this on your screen. And then the entire pipeline is emptied. Spark never keeps your data in memory. Once the processing is over, okay, you got the result on your screen, right? This you saw. Everything is gone. No RDD, nothing is there. No container, no partition, nothing will be there. Everything is gone. So only for that split second, all these things happens. So if you call a collect here, you will see this output. Okay. Now, if I want to know whether I should rerun or repartition, what I should do is that I should go back here. Okay. I will do a save of this error. You can also do a save method on an RDD. When you say save, it will save as a file, a text file. So I will say save as an action on this filter RDD. And then I have to check what is the size. Right. My original data is 10 GB. After the filter, it is 5 GB. So to process 5 GB, why I'm launching these many things? So I can rewrite my code in that way. So collect will simply display the output on the screen. There is also an action called save as text file. Okay, I'm not just talking, I'm showing stuff. So if it is text data, line by line, it will partition, that's all. And the same logic is applied, because if there is a line which is divided between two partitions, it will calculate the input split. Same logic of MapReduce is applied here. Now his question was, what if I don't want to do it? So he had a very good question. So he is asking, so the problem with this is, if I run the Spark code in a split second, everything will happen, and then I see the output on my screen. No RDD, nothing is there in the memory, because this is called DAG, Directed Acyclic Graph. Spark will create a DAG, a graph of execution, and will perform step 1, step 2, step 3, step 4, a result, and then everything is gone. Again you run, again it will load. That's a different thing. So collect is an action where you return all the elements in the driver program, meaning you see the output. You can also say save as text file. There is an action that will save, save as text file. If I say save as text file for an RDD, whatever data is there in the RDD, it will save as a text file. So I can see that in a Hadoop or wherever you are storing it, right? Now, is this the only action available? No, I have save as Cassandra table or many other ways to save the data. Ideally, text file save we do just to see the data. Okay. So in the initial phase of reading the data, even MapReduce or Spark, everything will be same because it is blocks you are reading, no difference it makes. Once the data is available in memory, then the difference comes. Because here you see we did a filter, then what's that, coalesce, and then let's say something else also we did. For doing all this, the data is still in the memory. You are not writing anything. There is no intermediate result you are pushing to hard disk. Once you call collect, you can write 100 functions and then call collect. All those manipulation will happen. Final, the collect only will display the output. That is the speed. So there are many actions, or let's say collect and save as text file. Collect is one action. I cannot say collect and save as text file. No. So first collect will run. Again, if I say save as text file, again the whole operation has to start. So you will be wondering, is there a way I can improve it? I will show you. Okay, so probably that is his question. So here I will show you this. So once you execute the DAG. DAG is nothing but directed acyclic graph. It is a fancy way of saying Spark creates all the steps to be executed in a graph format. And I will practically show you the DAG when we run Spark job. You can see that. You can see partitions, you can see the DAG, you can see how many executors it is launching, everything is visible. It's not just theory I'm saying. But unless I speak about it and just show, then you will say how this came, you know, how the partitions actually came. You will be confused, right? And the driver collects the data. So this is the full step if you want to look at it once more. If you look at the picture, I have a very good picture to explain this. Just see this picture. Same stuff I'm doing. There is loglines RDD, errors RDD, cleaned RDD. And finally, I'm calling an action called count. Count is another action. So if you say count, everything will work from the beginning because it has to count, right? So count action called, and what happened? It showed me the result as 5 because there are 5 lines in the RDD. No surprises. Now I also want to call one more action on the RDD called save to Cassandra. The problem is if I call this action, pipeline is empty. Spark has to start from reading from the block, creating the original RDD, then filtering, then errors, then I can save to Cassandra. Okay. Now one more thing, then after I'm doing one more filter, I want only messages 1 from this data. See, message 1, message 1, message 1. I just get only message 1 and then I say collect. So I just want to see this. But again, what will happen? It will start from the top. So if you look at this 3 actions, you can see all 3 actions depend on this RDD. Everything is starting from here, right? that is where you can cache an RDD. It is possible to cache an RDD. So when I say caching, whatever data you have in that RDD along with the RDD will be cached. And then where can you cache? You can cache in RAM, you can cache in hard disk. And you can also say RAM plus hard disk, like wherever you want. So there are multiple options to cache it. And once you cache an RDD, let's say you say count, it will count. Then you say save to Cassandra, it will start from here because this RDD data is already cached. And don't think if you're caching for 1 month. Once your Spark program is over, caching is deleted. Caching is holding the data in memory without flushing. So normally when you say collect, temporary. So this is caching is valid only till your program completes all the action. Once all the actions are over, you exit, everything is gone. Then you are not. So I will show you tomorrow when you start a Spark application. If I am a developer, I will create something called Spark context object. Okay, there is an object I create and that represents my program. And ideally when my program finishes, I'll kill that object. If I kill that, everything is gone, even caching will be gone. Because that caching is valid only to speed up my existing program. I'm not caching it for a program I'll write next month. That is not possible. During that execution time, I want to speed it up. So you have to call the RDD and say .cache. Then it will cache it. Otherwise, it will not cache. Once you say cache, cache is a transformation. So if I say cache, it will not cache it. I have to call an action to cache it after that. Right. So I have to say .cache, then count. Then it will count it and cache it, the previous RDD. Then whatever action I call, it will start from there. It is in memory, but once you call an action, everything is deleted from memory, right? So that is where caching makes sense, right? If you cache it, even if you call an action, it will not delete it from memory. It will keep it. See, I create this cleaned RDD or whatever, and I say count. It will count and delete all this thing from memory, right? So it is not in memory. During the execution, it is in memory. After the execution is over, nothing is in memory. Then you should keep the intermediate data in memory, right? You should tell Spark, I will call an action, show me the output, but this RDD, whatever data you have, don't delete from your pipeline, keep it because I want to reuse it for some other action. Then it'll keep, that's called caching. So there is a command called unpersist. Unpersist is an action, it's not a transformation. If you say unpersist, it will delete it from cache. I'll show you how to cache tomorrow, it's very easy. Otherwise, if you kill your Spark context object, like your session is gone, it will automatically delete it. You can't run 2 parallel pipelines, only one you can run. So basically, so you may be thinking, so how do I start programming with Spark, right? I want to write a Spark program. So first thing you should learn how to create an RDD. If you know how to create an RDD, then you can start with these simple transformations, map, filter. Now, there is also a flip side of all of this. The flip side is, initially when Spark came into the industry, everybody was mad about RDDs, okay, transformations. I'll write a map, filter. People were literally dying on writing these things, okay. But soon there was a problem with this. See, the problem is, if you write your code using these transformations and actions, there is no way Spark can optimize your code. Why am I saying this? Is that you say filter, okay? In the filter, you are saying that filter only error messages, right? Unless Spark runs it, it doesn't know what you're talking about. And these things do not have a very strict schema. RDDs are not having very strict schema. So when you want to process structured data, let's say like CSV file, okay, I want to read a CSV file and I want control, I want schema, everything. RDD is not a good way to process it. You can process it, but Spark internally will not be able to optimize your code. That is where Spark SQL comes into picture, or data frames we call it. So Spark has a module called Spark SQL, and Spark SQL is much more powerful and optimized than core Spark. So when you write Spark SQL, you should know how to create a table and query using SQL. It's end of the day SQL only. So it's easy to program. And more than that, it is much more optimized than core RDDs. Because you are using all Lambda. And Spark has no way to understand what Lambda you are using unless it runs it. Right? I wrote a Lambda code, some weird code. Spark has no way to understand what is the meaning of this Lambda unless it sees the data. But if it is a table, I can say filter on this column. Spark knows what is that column, what is that data type, where it is, right? It can avoid that column by loading the data to optimize, I'm saying, right? So if I write a SQL query, it has a filter, group by, then join and something. Spark can read it, apply the schema and understand what you are talking about. Now I'll tell you, if you write a SQL query where you wrote a join and then a filter, then the filter will come first, right? That is not possible here, I'm saying, because it doesn't know where you are filtering. There is no strict schema, right? It's not a SQL, right? It's an anonymous function. So it doesn't know what you're filtering, where you're filtering. So it has to load the full data, then do a join, then go for whatever you wrote for filter. Correct. So in SQL side, Spark SQL side, it is much more optimized. So what is recommended by Spark is learn RDDs, nice, great, do some transformations and understand, but stick with Spark SQL. So support is more, actually the core RDD transformation and actions are very less used now, because most of the people started writing data frame queries like SQL queries and all. Of course, you need to bring structure to the data, I understand, but most of the data you can get it in a structured format now. Okay. Data frame is a collection of data sets. So every row in a data frame is nothing but a data set. That is a definition. So usually you don't operate on data sets much, because data frame as such contains data sets, right? When you have a cluster, so I'm just connected to the cluster right now, right? Spark gives you a shell to work, like the Hive shell, if you remember. So you started Hive and started typing. So very similar to that, Spark gives you something called a Spark shell. And the Spark shell is available in Python, Scala and R. There is no Java shell. Java as such does not have a shell functionality. You have to write using IDE or something, right? Now, if you want your Spark shell in Scala, we are going to do Python. I think I have to export a path to get started with Spark shell. Okay. So let me try this. Let's try the Python shell PySpark 2. This should work. 9.9. So this is Java 8. As of now, Java 8 is supported. Okay, I think in the cluster they have disabled Scala shell access. Maybe I have to export some configuration to do that. That's why I'm not able to open the Scala shell. But if you want the Python shell, you type PySpark 2. That's the command. Why PySpark 2? Because we are in Spark 2. This cluster has Spark 1 and Spark 2 installed. You can try this. We will just do some basics, not like advanced stuff, but yeah. So started. So very simple. So this is your Python shell. Okay. And what it says when starting the shell, it says type help and blah, 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 logging level for Spark R and all. It says Spark version is 2.2.0. So on the CloudX lab, we are running 2.2.0 using Python version 2.7.5. That's okay. Okay. Spark session available as Spark. I will talk about this later. What is this Spark session? Okay. But it just says Spark session available as Spark. Okay. And this is your Spark shell. So now from here, you can start creating RDDs and then writing transformations and everything that you want. Okay. Now I will just see if I can show you this. So if you type this command PySpark, simply type PySpark, okay, -- help. Sorry, PySpark 2, right? PySpark 2 -- help. Yeah. So I want to show you these options. Okay. Just have a look at this. So I'm just saying that I want to start a Spark shell. Okay. And I need some help in starting that, right? So what it says, what are the options you can have? So one is master URL. So this we don't have to worry as of now. Okay. If I scroll down, I can show you, can you see this? Driver memory. So when you start Spark shell, okay, a driver will be created. Okay. And then you can ask for how many executors you want, right? How much memory you want for the driver, right? One question. And then here you see, what is this? Executor memory. I told you, right? You can ask for how many executors you want and how much memory. So by default, I think it is 1 GB. It is written here. Default is 1 GB. Okay. But you can ask for executor memory, right? And if I scroll down, see here, executor core, how many processor cores you want for an executor, right? And see here, driver core, how many processor core you want for the driver, number of executor, default 2. So if you are starting the Spark shell like this, interactive shell, you will get 2 executors, 1 driver, each executor has 1 GB RAM, default setting. But using these arguments, I can say how many executors I want and what is their memory and so on and so forth. Now, another important point, let me try this, okay? Just give me one moment. I will just do a PySpark 2, okay? And so what you are looking at here is this history server URL, and this is not really useful to us because once you start a Spark shell and then you exit it, it will display here. You can see here PySpark shell, it was launched by me 1.8 minute. I exit from here and then you can see here. But this is not really useful to us because this will come only in the history server. That means once you exit from Spark. Okay. So there is a real UI. That port number is not working. Currently when you are running the Spark, it will show there. But I can show you something. So this session I stopped, okay? I didn't do anything. I stopped this session. And if I go to this application, this is the Spark UI. So here you can see the jobs and there are no jobs. And if I expand this, can you see executor 1 added? There is executor 2 added because default you are having 2 executors. And here you can see executors. And there was 1 driver and 2 executors. So there was 1 driver active and 2 executors we got as per this, right? And one more important point is that when you simply say PySpark 2, if you simply say PySpark 2, Spark will start in the local mode. That means you are not talking to yarn or anything. If you want to talk to yarn, you have to say -- master yarn. This is the option you have to use. So whenever you are starting the Spark shell, otherwise if you start in the local mode, what will happen? Driver, executor, everything will be in a single JVM. And also the resources will be allocated by your operating system, not by yarn in the local mode. Yarn has no role in your local mode. And that is good for learning. If you simply want to learn, say PySpark 2 and then you can just start writing your code, whatever. Ideally, when you are launching the Spark shell, you have to say PySpark 2 and then you have to say -- master yarn, meaning I want to register with yarn and then launch Spark. So what this request will go to yarn and yarn will allocate containers to you. Now let's try to do one thing. Let's try to launch it with our own parameters, right? So what were the options we have? PySpark 2 -- help. So let's look at what are the options. Let's say we want more executor. I want 3 executor probably, right? So what is the option? Num executor, -- num executors. I will say 3 and -- executor cores, let it be there. I want memory more. So where is memory? -- executor memory, right? Default is 1 GB. I want probably 2 GB, something like that, right? So what I can do, I can simply go to my shell, PySpark 2. I can say master is yarn and I can say number of executors, probably 4, I don't know. And then what is that? Executor memory. Why this is there? Okay. Executor memory, I need 2 GB. Hit enter. PySpark does not support any application option. Why it is saying that? Probably we are asking for more. Let's see whether we can get 3 executors, okay? So first we will try that. then we will see whether we can get more memory or something. So right now I'm saying that, hey, launch a Spark shell. The master is yarn. Sorry? Not mem, right? Memory, right? Yeah, wrong command, correct. So now I asked for 3 executors and it started, and we can't see it here unless we exit. So let me exit from here. So it will go to the history server. Okay. I'll refresh here. This is what we started, right? Can you see? Executor 1 added, 2 added, 3 added. Can you see? So 3 executors were given to me. And you can actually go here, executors. Can you see? This is one driver. These are executors, right? You get executors. And here you see the memory, right? So how much memory did you ask? Huh? I think 1 default we selected, right? 1 GB we selected actually. So for RDD storage, right now you are getting what? 384.1 megabyte. So how this rule actually works, like I told, around roughly 50% of the memory will be taken. And remaining it will give it to you. You will actually get around 600 MB in this. But it will display only this much because you are not loading any data as of now. It is simply running. The executor is simply running. You don't have anything inside this, right?
If it is 600 MB, it is going to give it to the
Yeah, for the RDD.
But why it is showing only 384?
That's what, you don't have any data as such, right? When we load something, we can actually see the memory it will occupy, how much amount of RDD you have, it will occupy.
It's telling that 0 byte occupied out of 384.
So 384 right now it has allocated, but there is no data inside that. 0 byte it is saying that. But when you actually load, let's say 500 MB data, it will show 500 MB actually occupied in this. Because up to maximum 600 MB I think you will get, because 40% anyway will be gone for your system calls and JVM, right? So up to 600, 500 and something, 50 or something you will see here. Okay. So right now you can see only less memory because we are not actually doing anything with here. So that is why it is simply displaying, this much. And I exited from here. So what if we try to change this? Number of executors 4 -- executor memory, right? Memory 2G. There is a threshold value, I think. If it is more than 1 GB, let's try this. There is a threshold value. What is this? It says an error occurred while calling Java Spark context. Required executor memory is above maximum threshold for this cluster. So the cluster administrator has said that you can ask only maximum this much. So what they say? 2048 plus 384 MB is above. So it is saying that max to max you can ask only 2048, 2 GB of memory. But here what will happen when you launch an executor is that initially it will allocate a 384 MB. Okay, then it will keep a 2 GB as, excess to be allocated. So it is saying that the total memory is above the cluster administrator, what he has said, you cannot launch. So we can try 1.5 G or something like that. I think 1.5 gigabyte should work ideally. Let me check if that will work. Okay, I'll exit. I just wanted to check whether the cluster is running fine. Oh, okay. So how do you mention? So see here, size must be specified as bytes, kilobytes, megabytes, gigabytes, terabytes, right? So I think you cannot say 1.5 G. That will not work, right? So how do you mention megabytes? M, right? And here event timeline, how many executors we got? 1, 2, 3, 4, right? And if I go here, it could have allocated less memory. Yeah. So now it is saying some 650 MB only. It is not giving complete. That's fine because we don't have any data as of now. But you can clearly see that you are getting 4 executors here, right? So there are 4 executors. Which one?
Can't accommodate more than 650.2 MB.
Right, correct. So, but now what I'm showing you here is not correct because I'm showing you from the history server. Like I'm starting Spark Shell, then exit from there, then I'm showing you that this is the UI. That is not correct. You should see live, right? If you're running the job, you should see live. That UI is not working. I was asking for that, and I don't know why.
Does it work without internet connection? Because it's installed on your system.
No, this is running from our Cloud Lab. So this UI, so where is Spark installed? No, in this example, it is in the Cloud Lab, right? In this example, it is in your Cloud Lab. So you need internet. If it is local system, you don't need internet or anything. It will run locally. Similar, exactly same actually. Only difference, executors and all will change. How many you are asking? UI is exactly same. So these jobs will display anything which is running. Why you are not seeing anything here? Because we don't have any RDD or any action, or if you have something, you will see here. Okay. And stages I will talk. The storage will show you if you have cached an RDD. If you cache an RDD, it will come here in the storage section. Environment is where it will show the Java libraries and all. Executors will show how many executors and driver that you have added. Jobs is where if you run a job, it will come. Like you said, this thing dot collect, it will display here. Like when you run an actual job, it will display here the DAG and all. Stages, it will show you in the job how many stages are there and how those stages are created. We will see that tomorrow anyway. Okay. Then you have storage, and then you have environment and executors, right? So environment will show you the different libraries and all which are part of Spark. So if you go here, now you can't actually mess with me. What if I want to see this from the shell, right? So I'm just saying PySpark. I'm starting it again, okay? Sorry. So there was a command sc._conf. There is a weird command which can show you all this from the shell. So now you are seeing this in the GUI. What if I don't have a GUI? So I can do an sc._conf.get all. Perfect. So I remember the command. I'm happy. Okay, so there is a weird command. Nobody remembers this command actually. sc._conf. Okay, but the output is weird, but you can see something from the output. What is that you can see? Can you see number of executors? Somewhere it will be, here is driver memory, right? This is driver memory, and you can say master is yarn. Somewhere see here, executor memory, how much it has allocated? 1500. You can also see number of executor. Where do you see? It's very difficult to read from this. I can copy paste, that's better. It's not even allowing me to copy. See here, when I'm copying, I'm getting. So this command is like $1 million command. I'm quite sure nobody will know this command. Even I came to know very recently. How can you see the Spark configs from the CLI? sc._conf get all. It's a shortcut actually. I'll show you the command. This is the command. Please make a note of this because sometimes you will start working in a cluster where they will not give you GUI. Then how do you know how many executors you launched or what happened? You have to look at this way. So this will give you an idea about the number of executors, everything launched. Live you are seeing, like now you launched, now these many are there. sc._conf.get all. This is a Python shell, right? But it is internally communicating to the Scala. This sc command I'm saying, this command only. Other commands normally whatever you write, it's Python only. So this is your Python shell. Normal Python commands you will write here. Only difference we will use those map, filter, transformations. Now the good news is we will try something in the shell. The bad news is you will actually try most of the things like this. Jupyter Notebook. So how do you create an RDD? from PySpark, import, SC, blah, blah, blah. Just all output clear. Okay. So KDD, cup data, row data, parallelize. And these are some of the, so tomorrow we will look at RDD creation and some more. I will see if I can get this UI, live UI, then I can show you some more. Okay, I'm not able to get it. If I get it, we can do some more thing. I know the URL, but it is, so it's not the problem with the URL. It is AWS cluster. If so, when you launch in the yarn mode, there will be an application master URL. If you click on that, ideally it should go and show me the UI, but it will go to the private IP of EC2 instance, and it will say the private IP of EC2 instance, and it will say page cannot be displayed. So they have to give me a UI to see that. I don't know what is a UI. That's the problem, right? Everything I'm doing in one shot: text file, flat map, then reduce by key, and you're storing the word count result in an RDD called counts, because I want to further process it. You can also save it in the Hadoop. We did that, but I'm just saving so I can process it further, right? So all I'm doing is I have an RDD called counts, and the word count output is actually stored in this RDD. Just the word count, right? The word count output I'm storing in an RDD called counts. That is all I'm doing. Why am I doing it? So what you should do, first thing, upload the data in Hadoop. ODI data.csv should be in Hadoop. Second thing, open this notebook called Raghu, okay, as a reference. We will not directly run the notebook because we'll just explore it a bit, but make sure you have this anyway. You don't want to run this notebook as it is because there are so many things and you will not know what is happening. So what I want you to do is that create one more notebook. You can simply say file, new notebook, and say PySpark. It'll create one more notebook for you, right? So, and you can copy paste from here rather than running directly here, right? So just copy paste here. And first thing, we will copy paste this, okay? So these are the imports you are doing. Now, when you are starting the PySpark shell, all these imports will be there. Some of them you have to import, but most of them will be imported. Now, when you are using the notebook, it is like you are writing your own application, right? So these are some of the standard imports you need. Spark context, SQL context, Spark conf, storage level. So these things are required for Spark, okay? I will tell you where they are using, okay? NumPy for manipulations, division, decimal. We are plotting a lab graph for that PyPlot, and then matplotlib. So these libraries we are just importing so that we can plot a graph. Can you try this in your session? These two lines, is it working? If it works, I'll tell you what it is. Just copy paste from here. It is commented here. There is a hash. Remove the hash and just run this. So using this configuration object, you create your Spark context. You'll say create the Spark context and use this configuration. Where this is very useful, like I said, when you're deploying a production code, okay, you will type all the code in a notepad, and there you have to mention, where is the master, how many containers you need. You can also pass them as arguments. It is not always hard coded. If I don't mention these things here, while submitting the code, I can pass them as an argument. I can say num executor, this many I want. But most of the people actually prefer this way. They will just set it in their code. So here I'm just setting my parameters for my configuration in the cluster. Using that configuration, I create my SC. So now I have my Spark context object. This is automatically done in the shell. When you start the shell, SC is available, right? So this is already done by the shell. So now you got the SC, right? And what we are doing, we are reading the captain data, ODI captain, whatever you call, right? So if I look at here, do one thing, change the location. See, I am reading from user, GL faculty, Raghu. So this will be different. Remember, when you're creating an RDD, you can mention the number of partitions. So here I'm saying that read this CSV data with 4 partitions, okay, and Unicode equal to false. So this is the place where, but even if you're running, I'm getting that U character. Okay, I tried it. We will see. Okay, and then you also say repartition to 6. So this will read your data into 4 partition and it'll just repartition to 6. I just wanted to show you that that's what I'm doing. There is no particular use for this. Just want to show it is possible. and if I execute this shell, it should work ideally, let's say. Yeah. And how do you know whether it is actually working? You will do a captain's spelling mistake is there, underscore ODIs dot take 10. So you have to do till this, and you should be able to see the captain data. So just see whether you can read the data and get the first 10 lines just to ensure that it is running using SC. So we have the data. So, but one problem with this data is that since Spark is not really understanding the schema, it is considering that each line is like a string, right? Even though we have some numbers here like 56, 28 and all, Spark will think everything is a string. It doesn't understand what type of a data you have. Now, if I want to do some addition or subtraction, I cannot do it. Even if I extract this part, it will be a string. So I can't add them or multiply them. That's not possible. So that is where you can apply your own schema. You can actually have a schema for this data. So right now we just read the data and nothing else is happening. And if you don't want to see these things, clear it. Okay, you can go to cell. You know this, right? Clear everything. Otherwise it will be displayed there. And just comment this line. Otherwise it will run next time also. So this is, you just wanted to check it. Now you know the data is there. Just hash it, comment it. Otherwise every time it will run and show you on the screen, right? So these are basically what? You have transformations, so coilies, and you have actions, collect. So these are the things you can actually see, right? So you just create, so why are we doing this? We want to apply a schema, right? So this is the actual schema. You just have name, country, carrier, matches, won, lost, ties and toes, right? You just create it in a collection called fields as of now. And once you have it, you can import something called a named tuple. You can create something called named tuple. So I'm doing this step by step so you will understand. So from collections, you are importing something called a named tuple. Okay. And what is the use of this named tuple? So a named tuple is something like we use for pattern matching sometimes. So what happens? You have a pattern or a schema and you want to match it with the existing data. What you can do? I created a named tuple here. Okay. And it has captain and fields. So the name of this is captain and it contains this fields. Fields I have defined here, whatever fields I have. And I will use this name tuple. Then you will understand why we have created this. Just understand its name is captain as of now. We just created. And then what you're doing after this, you will write your own function. Okay. So what is this function doing? If you look at here, you will understand. This is a normal Python function. The function name is called parse records. Okay. It takes line as input. So if you run this function, what this function will do, it can take a line and then split it using comma. Okay. So you have a CSV file, right? So if I call this function on my CSV file, what will happen? It will read every line, split it using comma, and what the function will return, it will return the captain object actually. Meaning it will have this captain, and within that it will take every field and apply this whatever schema you have created here, like name, country, carrier, matches. Okay. And also wherever you want to convert it into integer, you are calling it here, because the first one is string, second one is string, this is also string. From here it is all integers. So if you call this function, what it will do, it will read your CSV file line by line. I will call it inside a map. So it will apply to every line and it will extract every column. It will apply what we have created as captain, so that you have a header kind of thing for this data, and each data type also will be defined here. These all things will be string. Here I am manually calling the Python integer. I am typecasting it, right? Because this is all string. I want to make it integer. So I say integer. So this is how you, so the similar concept in your Scala is called case class. So I can say that name dot, then I can get whatever is inside. So this is schema RDD. This is called schema RDD, where you are applying a schema to the RDD. Otherwise the problem is if I read a text file, so you look at what we did in word count. In word count I read a file, it had lines. I was able to operate them line by line. Like I can say extract this word or count this word. but I cannot say give me from 7th column. That was not possible in our word count example, because there is nothing called 7th column in that word count example. Here, once I apply this, it will get a schema. It will process the whole stuff, but at least you can access the fields. That is what I'm saying. Otherwise, it is not possible. If I don't use name tuple, I can't access the individual columns that I want with the name. So from here, now I can say, give me only the captains with this something. So I can say, let's say name of the captain whose career is something like that I can access. That is why I'm importing name tuple. We will see. Couple of steps, if you go further, you will see why we have created this captain object. So now if I go here, look at this line. Look at this line. This is what you need to understand. So this line, I'm just copy pasting it here. I am saying that this is my RDD. Captains underscore ODI is my original RDD. Do a map transformation, lambda, okay. For every element, call this parse record function. Where is parse record function? This is parse record function. So for every line, this entire function will be called. That means every line, it will split using comma, extract individual columns, and all those columns, this captain object will be called, which means they will have this structure. But even though this is schema, it is not 100% optimized schema. So that's what I'm saying. When you want like proper schema like an RDBMS table, right? You have to go for something called data frame. We will see that in Spark. This is like, for the time being, I want to represent the data in a columnar format. That is why I'm using this. Okay. So I'll run this. Okay. And if I do a captains, so can you see now the difference in data? Do you understand the difference in data now? What is the difference? 10 objects with a schema, whatever field name you have mentioned, like name and a country. It is not a table. Don't think that it'll come like a table, right? So these are called a row objects actually. Each row will be converted into something called a row object, captain object actually. So this is called a schema RDD, right? Because sometimes you want to work with schema, sometimes you don't want to work with schema. Right now I want the schema. That is why each row became a schema RDD. Captain object is applied. So otherwise it will just give me 10 lines. And in each line I will have Hussain, but I don't know who is Hussain, what is Hussain. So here it is saying name is Hussain. So I can say I want to filter all the names or all the countries, like that I can say. So the important point you have to remember here is that you have to create a name tuple with the whatever column names you want, okay? And then you have to apply to the data. Also this is very important. In your original data, you have to say integer of this field, otherwise it will not work. Everything will be string. It will read everything as string and it is useless. Or float or whatever you want to convert, you have to convert there, okay? No, there is no difference. So here you are saying that I am creating a named tuple, okay? And the name of my tuple is captain and it contains fields and I am storing it as captain. You can change this name, it will work. I just use the same name, it will work also. So here it is a bit confusing. So the object name here is actually this captain. This is what we are actually getting. Pipelined RDD is where internally it treats objects. If you have an RDD of object types, it's called pipelined RDD. I will show you. Okay. So now if you can come to this point, till this point, I'll just clear the output because otherwise it is very messy. And just comment this line. Okay. Just comment this line because if you don't comment it, again it will run take 20 and then it's gonna mess it up. Don't do that. And now what you can do, look at here, what we are trying to do. So is this correct data? Yes. Because matches, if you look at the tag called matches. Now the problem with this schema is that in every row you have the schema. It is not a columnar schema. Like if you look at an RDBMS table, you have a column, right? That is columnar schema. A column has a header, then you have the schema. So here it is like associating a tag with every word. Like that you have the schema. So that is why it is not very efficient actually. I can't even call it as proper schema. Every word I'm adding a tag like name or whatever I want. I can do some very basic operation, but ideally if this is the CSV file, I will create a data frame. That's the easiest way to work on that. And you know what this means. Records.won greater than records.lost. What does that mean? I want all the captains who has a history of more winning, right, than losing the match, right? Okay, then what I want to do, I will say captain more wins dot map. I just want to print this. So countries dot collect We will call collect and see what will happen. So can you identify what we have done? You said, I want all the captains whose record is like they have won more than lost. That is what I'm doing here, right? Then I'm saying that from that data, this is that RDD, I just want only their country and match. I want only 2 columns. What if I want only their name and country? I can say rec.country and rec. What is the field? Name, right? What is the schema we have got? Name. Now you see, you are getting the name of the captain and the country. This means these are the guys and the countries where the winning rate is small, right? But do you feel overall writing Spark code is easy? Overall, I mean, compared with writing a MapReduce code, probably. So this is just word count. I don't want to run. So in the previous example, we got the country and the matches, and you just said reduce by key, meaning you did a word count on the matches. It will add all the matches country wise. So that I don't want to run. Okay. You can also do sorting. We have already seen sort by key. And if you want to do ascending, you can say ascending equal to false. This is sort by key. Okay. And you also saw the sort by method. I have shown you this. Okay. But probably I think this data set requires all of them. So I'll just run them. Okay. So we will run them as it is. Probably this analysis requires them in that form. So what I'm going to do here, I'm just copy pasting. I will say that I want all the captains where I want the country and the matches only. Okay. And then what I will do, I will say I want to do a word count on them. And if I do a matches underscore countries dot collect. So look at this code and let me know if you have any questions. Yeah, so I saw this error a bit of times. So just to give you an idea, right? So when you are creating the notebook, right, you have to say file, new notebook, and the interpreter has to be PySpark. Some of you have used Python 3. It doesn't give any other information also. It just says I cannot read. I didn't know what was the problem. So the interpreter has to be PySpark, not Python 3. So then what we are doing, so once you get the countries, okay, you can sort them. We have already done sorting. Okay, so you don't have to worry about that. So now you will see there is an RDD called captains 100. Okay, so where is captains 100? So here is captains 100. Can you see? And what is this captains 100 contains? It contains data where they have played more than 100 matches, right? And I'm just using this. Let me show you what I'm doing. Rec of 1 greater than 0. So what is your captains 100 contain? So captains 1001 is not really required because it is not doing anything. It is saying take the second column and more than 0, whether it is greater than 0. It will not compare actually. It will give you the same RDD. There is no change in that. But I'm using the same RDD name here. This captains 1001 I'm using here. It's the same RDD only. And then what am I doing? I'll say map. I will call a function. I will say, give me the name and then what? What is this doing? Float of won divided by matches. So what this will give you? Statistics of the captain, right? Like percentage, right? And then if I do, so this is their winning probability or whatever you call, right? Because you are dividing what? You are taking a float and you are dividing won divided by matches. So out of how many matches? How many were won? So it seems Ricky Ponting is what? 71% almost you can say, right? Out of matches played, 71% was won. Dhoni is like 55% and so on and so forth. So you're just analyzing this statistically, right? Then you can also sort them. So I'll say sort by in the ascending order so that we can find who is the successful captain. So how do you find the successful captain? Matplotlib, right? So you are saying that for A, B in result, okay, append A, append B. Should be able to run. The error is what? See, what I was doing, so we don't use it normally. When you just run till this, okay, it becomes an RDD. So result is an RDD, okay? And you cannot plot a graph on the RDD directly. So I deleted this initially, then I didn't think that. So, but when you say dot collect, the RDD will be saved into this variable called result. Now result will not have an RDD. Rather, result will have the output of whatever data that you contain, and that you can plot. You can't iterate over an RDD, right? So you have to call an action, and then that result has to be saved here, then you can plot it. But now I think you should be able to see that, yeah, right, it plots. I mean, it is definitely, plotting is very simple, it's not rocket science, but here I had a confusion. Okay, so remember this point, directly you cannot run any normal plotting or methods on an RDD. You have to say dot collect, so the RDD will be available in a variable, Python variable. Then in that variable you can say I want to do whatever I want, right? Now one question we had was about the stages in Spark. So why don't we do this together? Can you open the shell, I mean in the web console? Go to web console and copy paste your username and password, right? And simply say PySpark2. Launch it in the local mode, PySpark2. And I just want to run a normal word count, nothing special, okay? But I want to show you something while doing that. So I'm just launching the shell and I have the code here. So I will just go here and I'm doing a regular word count, no special stuff, right? If I scroll up, so I will just read this book RDD. So here is your book RDD and I will simply say do a word count. So you will get word count output and there is no rocket science. Even I'm not filtering, I'm not doing anything, I just do it, right? And now I exit from the shell because I want to show you the UI. If I exit from the shell, it is gone and we have the Spark history server. So let me access that. So here is the history server and this was my session, GL faculty. One last topic, like somebody was asking what is, stages in Spark, right? So actually you have something called a job. This is split into something called stages and this is split into something called task. There are three things. A job is something which will run when you call a collect. Say for example, you say do this, dot collect. That's called a job. Let's say you write something like this. You have an RDD called A. You say A dot map, something you did. You said filter, okay, something you did. And then you said collect. Finally, you are collecting the RDD, right? So this entire thing is a job. This is a job. And Spark will fire a job only when you call an action. That is for sure. Either you count or you collect. Whenever you call an action, what it does, it understands, okay, I have to create this RDD, then do map, then do filter, then show the output. So this entire thing is called a job. Now a job will contain something called stages. So what is a stage, when a stage will come, right? To understand that, there are two types of transformations. You have something called narrow transformation and wide transformation. So when you write transformation, map, filter and all, I can say either they are narrow or they are wide. Example of narrow transformation is like map is narrow, filter is narrow. These are all narrow. So why do you call them narrow transformation, right? Say for example, if I have two partitions of data, this data has A, B, this has C, D. Okay, I am saying do a map. I'll say lambda. I'll say for every x convert to x comma 1. I want to convert to key value pair. If this is my transformation, if I apply this, each partition can apply this independently. Meaning this A will become A comma 1, B will become B comma 1. This will become like this will become like this. To execute this, these two machines need not talk to each other. Correct? There is no dependency. That is called narrow transformation. In narrow transformations, when you write a transformation like map or filter, okay, it can be applied individually to a partition. So A will become A comma 1. That has nothing to do with C, right? This machine will take care of what should happen here. This machine will take care of what should happen here. And there is no data transfer in between. That is narrow transformation. And an example is map or filter. So then what is wide transformation? An example of wide transformation is something like join, group by. So there are some transformations like join and group by. Okay, so there is something called group by key. Okay, so let's say your data is again like this. You have two machines and you have key value pair. So here you have A comma 1, again A comma 1, again B comma 1. Here you have B comma 1, again A comma 1. Now I am saying group by key. So what group by key will do? It will group all the data based on the key. Now my key is what? A. A is here, A is also here. Can this machine independently do group by key? No. This A should travel here and this B should travel here. This is white transformation. And whenever you write a narrow transformation, all the narrow transformations will be executed in one stage. That's called a stage. Meaning, if I am running this code, I am saying do a map, do a filter, do a collect. What Spark will do, it is a job. It will call for one stage. One stage means all these three tasks will be sequentially performed, one by one performed on all these independent partitions, and your output will be shown. Now let's say after this filter, okay, you called something like group by key, right? Group by key. So what Spark will do, it will know that, okay, map and filter can run independently, but if this has to work, everybody should complete till this. Then only this can start, right? Because group by key requires the whole data. So what Spark does, it will create a stage for this. So this will be your stage 0. So it will ensure everybody complete map and filter. That is stage 0. So probably there are 10 partitions or 100 partitions, right? It will wait for everyone to complete map and filter because they are narrow, independently they can do. And then it will ask everybody, is everybody done with map and filter? Yes. And now we have to shuffle the data. So I'll call for a different stage. This will become your stage 2 or stage 1. Because these two cannot run in one shot. For this to work, these guys should complete first. So that is when, so whenever you write a wide transformation, Spark will call a new stage. But in the DAG, it is not visible. That is where I was confused. Normally, when you do a word count, reduce by key is a wide transformation. In word count, reduce by key is a wide transformation. So ideally, if you look at the DAG, it should show that flat map, then map, all should come in one stage, then reduce by key should come in another stage. There is a special type of RDD called a shuffled RDD. Shuffled RDD. This will come exactly here in the middle of these two. Because once this stage is over, it has to shuffle the data. For that, it will create an internal shuffle RDD. Because it has to shuffle all the data and give it to the next stage. Saying that now you can group by. And reduce by key, group by key, join, all are wide. Because join I cannot do on one partition. I need two partitions then to merge them to do a join operation. So wide transformations are costly for Spark because it requires network. The data has to travel. For word count and all, it is easy. 10 terabyte data you have. If you write a wide transformation, it will take a lot of time. So when you write your code, you should try to minimize wide transformations. You should try to reduce the wide transformation. Okay. So these are the stages and task. Task is your map or filter. So what is a task? That is this individual transformations, right? So first you have a job that will be in stages. Each stage will have task. Task is transformation, either a map or a filter or anything you can say. Let's say you have 3 partitions which are running in 3 machines. What if this machine crashes, right? Can happen. So internally, Spark has something called a lineage graph. Meaning when you run a job, it remembers that, okay, this is the job, I have to do map, filter, blah, 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 okay? And each partition, what is happening, the driver will know. So you have a driver here, right? And the driver is communicating with this executors. So driver is pushing the code. Okay, first run map, then filter. So the driver is the guy who is controlling all this. So if this machine crashes, the driver will know that this executor is gone. It will launch another executor and load only that partition which was here, whichever partition was loaded, and it will ask it to continue. Only thing your program will be a bit slow, but it will execute. It is fault tolerant, only that partition, because these two guys are already running, right? So it knows that what partition was loaded here and till what stage it was processed. Probably it has already done a map. Whatever it has done, it has start from beginning. That is not possible. whatever data was here, it will be lost, right? So you have to start from beginning. Ideally, so when you're creating your own Spark applications, so you will write your own Spark context, right? And one of the problem that we see in production networks is that, let's say I am a developer, okay? I write my own Spark code. So I will say create Spark context, read the data, process the data, and I will submit my program. What will happen? My program will create a driver. It will also call for executor and will process my data. Processing is over. Probably the executors will get deleted. Let's say if they are not doing anything, executors will be gone. My driver will keep running. So this is a common problem in every Spark cluster. So you have 10 developers, they create 10 Spark programs, they will submit, okay? And what will happen? The program will run, no problem. Analysis will be over. But you created this Spark context, right? If you don't stop, it will run forever. So you have to say stop your Spark context once your this is over. What is analysis over? When you're writing the code, you will say import Spark configuration, import blah blah blah, a equal to read sc.text file, map, flat map, collect. Then you say sc.stop. Many developers don't do that. So what happens is sc will run forever in the cluster. It will eat resource, right? A driver will take 1 GB RAM. Executors will be gone. Once your processing is over, Yarn will take care of it. If they're sitting for idle, it will delete it. But your driver will not be gone because that is having the Spark context object, right? It will unnecessarily be running. It will eat resource and it is not doing anything, right? So you should stop your Spark context while launching in a cluster, right? Like we had that, errors RDD and loglines RDD, there we read. So caching is valid only when your program is running. You are not caching for 1 month. Caching will be for microseconds. The idea for caching is not to store the RDD for a month. You can't do it in any cluster normally. You are caching it so that during the execution it is faster. If your program is running during the execution, it has to be faster, then you are calling it. So let's say you do a word count program. You say a dot, flat map. Then you say map, key value pair. Then you say reduce by key. This is your word count program. Then you say dot collect. So if you run this entire code, what will happen? It will do word count and every data will be gone. Okay. Now let's say you got the data till this. Here the data is in key value format, right? Okay. You are saying that I want to save this data. Save to Cassandra. For some reason, this data, I just want to push it into Cassandra. Now, if you call this action, again, it has to start from beginning, right, to save it. Now, I can cache this RDD so that once this is done, if I again say save to Cassandra, it will just save from here if this RDD is cached. That is the advantage of caching. The intermediate RDD can be cached. So, during the execution of your code, it will make it faster. If you're calling multiple actions. Otherwise, there is no use for caching, ideally. So I can do the same thing in Spark. That's called, in Spark also it is called a data frame. Okay. So you have a CSV file, you can read as a data frame in Spark, and then you can write your queries, and it will be much, much faster because since Spark is executing your query, it will be really faster. This is the word count code for Scala. Sorry, flat map, right? What is that? First you do flat map, same flat map. I say take x, convert to x dot split using space. Then you will say again map. You will say take x, x comma 1. Then you will say dot reduce by key. And you will say x comma y, rocket symbol x plus y. Yeah, I'm using same flat map, map and reduce by key. In Python, you will say lambda x colon x comma 1. Here you don't write lambda, you use this rocket symbol. That is only difference. Technically it is done because there is no difference. Plot I don't think you can do because plot requires, I don't think you can plot in command line. You need the GUI stuff, I think. I have not extensively worked with plot because we have something called Zeppelin, very extensively used, like your Jupyter. But Zeppelin is more for the Hadoop world. So whenever we have to do any visualization of something, we go for Zeppelin notebooks. Same concept, like Jupyter Notebook, but in the Hadoop world, we can say. So Jupyter Notebook is not created for Hadoop or something, right? It was created for Python, I think. Then now they have added Spark and all you can run. Zeppelin was created only for your MapReduce and Spark world. So you can run Hive queries, for example. So if I want to run Hive query, one thing is I can open the command line and write the Hive query. I can open a Zeppelin notebook, copy paste the query, it will run for me. So this is usually for non-technical guys, in the sense like managers and all. So you have to show some report to your manager, you have some 1,000 tables. You can't write a SQL and show, even he will not understand, right? So this tool will connect to your RDBMS and it will pull the data, all the tables, everything it will show, right? And with interesting fields and all, like name. So somebody look at it, they can understand this is the data we have. Then you can just, some tools allow you drag and drop to build the chart. So these, I think Spotfire doesn't allow it. There you have to filter and say that, okay, I want this column from this table, and it can create this complex statistics and graph for you. Like it is not exactly like a constraint, like you are not writing a proper join query or something, but you want to find relations and all, right? Then you can do it. So, but actually you need training on BI to work. You cannot just sit and say visualize. Tableau or Spotfire, which one? You need a training, like how to use the tool, and there are a lot of things inside that. SQL is required. If you are a developer, you require SQL to understand this. Okay. The use case is like if your manager want to see the data as a graph or something, this is the best tool. Because in using SQL, you can only show like tabular form, right? You can't do anything else, like a table. But this guy can visualize in many different areas, right? And I think, I'm not sure, the Spotfire also has this interesting fields idea, meaning it will automatically figure out what are the repeating entries and all and plot them. RDD creation is actually reading the data, right? So what type of data you have, what format of data you have, this you will have a problem usually. But most of the types of data is supported by Spark when you are reading it, right? So Spark can read from a variety of sources, right? So that's a good question, like how do you read the data, right? So if you have like .txt, .csv, .dat or any text formats, by default it will read, there is no problem. Any text format, okay? Also you can read JSON, you can read XML, you can read Avro, you can read Parquet. These are the type of formats we use in the big data industry. Now you might be aware of what is text and CSV and DAT and all. So these are like normal text formats. JSON is your key value pair. Easily Spark can handle that data. XML is XML. You know what is XML, right? Tag and all. Avro is very common. This data type is something which you may not know usually, because normally you may not have seen an Avro file, right? Can I show you an Avro file? Yes, I can show you an Avro file. Maybe that will make some sense. That's a good question anyway, since you have asked. I was running one example in Cloud Lab, and the output is actually Avro. So this is typical example. When you are downloading the data from Twitter, it comes in Avro. Most of the cases, Avro or JSON. So there are two options in which Twitter can give you the data, right? One will be JSON, which is like pure key value pair. One will be Avro. It's a serialization format. I'll show you the Avro data and then we can speak so that you can understand. It is an Apache format, avro.apache.org. Avro, two wings and all, right? Avro. First, let me show you the data, then I'll speak about Avro. I think it should be somewhere here. I downloaded some tweets just to see something will happen. Where is the folder? Tweets. Here. So this is actually, okay, this might be different because this is Flume bringing the data, right? So in your Flume example, and if I open, let's download the data, right? How do you download? Actions, download, and we got it, right? If I open this, I have asked it to save it as .txt file. Okay. And open with, we don't have Notepad++, I think. This is Avro. Can you see? Avro.schema. So why people are using Avro, right? So Avro is a text format where you can send the metadata along with the actual data. Normally, if you have a CSV file, you will have column header and so on and so forth, right? It is structured data. Now in plain text data, Avro can append a schema and send it. So if somebody is reading, they will read along with the schema. So it is structured actually. This is public tweet, right? Somebody has tweeted this word, whatever word it is, I don't know. This is not from Avro. Avro has, here you can see avro.schema, type, record, name, some. So it appends a schema actually to your data and then send your data. Now, what data Twitter send is this. This is actually the tweets, and I have not seen this. So some Twitter download phone, something is there. You know, public tweets actually are there. So the point is, Avro files will come with a .avro extension, and normally if you read it in a text file, you cannot make sense of it because it is a proper format. So if you are having Spark can read this and it'll appear like a proper row column table because it has schema, right? So Spark will read the schema and then it can say that, okay, this is a table, okay, from the Avro and represent your data in a structured format. You can read if you struggle a bit. I mean, I know the schema, so we can read it. That's not a problem, but you cannot process it. Not reading, if somebody want to process it, it has to be in a proper structured format, right? Very much like JSON. If I'm getting JSON, I can read and understand what is inside JSON. But if somebody want to process JSON, key value pair, then you have to dump it in a table. And so if you get a .avro file, now why this is very important, right? In most of the big data pipelines and platforms, a lot of data will be sent as Avro. And Avro is serialization, so it will compress your data. So you get savings. Say, for example, I have a very large text file. I want to send it over the network. I can convert it into Avro and send it. So it will actually save the space. So many systems actually send the data in the format of Avro. And in Spark, you can directly read Avro. There is an Avro reader built in, and it can understand what is Avro. And when you are getting sensor data, very common example, they give it in Avro format. Usually, it will come in the form of events. These sensors, when they send the data, okay, let's say every second, some sensor is sending some data. It will be an event every second. You can see an event file landing. This event file will be in the form of an Avro. Now, in case of sensor data, you may not want the schema, because if a sensor is sending the data, the schema will be something like the name of the sensor or something like that. If you don't want that, that's fine. You can remove the schema. Probably you are interested only in what the sensor is sending, not the metadata. But you can add the metadata along with the data and send like a text format. That's Avro. And Spark can read Avro. Parquet is compression format. And in Hive class, we have seen Parquet. Hive can use Parquet. Hive can also use ORC, right? ORC file. So Parquet, ORC, everything Spark can read. So most of the cases, I believe you are able to read the data. Now, second question that people ask is that what if you are getting some weird type of data that nobody on earth is able to understand, and then I want to read it into Spark, right? And then you have to figure out a way, right? So Spark is not going to help you for everything, right? So again, taking the GE use case, there GE's data is coming in the form of Avro, in the format of Avro. They get this sensor data from train engines. They have locomotive engines, okay, which are running in Europe and US. So these engines actually send the data that comes in the form of Avro. But even that data, Spark is not able to read because it is not normal Avro format. So if you give that data to Spark, Spark will say that I'm not able to read. I don't understand what is your data. So there they have written a SERD, serializer, deserializer, to read the data and give some structure and give it into Spark. So sometimes you have to do it. Not every data you will be able to read and process directly using. So most of the organizations will have a data ingestion team. There is a separate team called data ingestion team. Their job is to get the data, raw data, and then make it formatable, useful, and then give it, right? You also have this VXML. Do you know something called VXML? Voice XML. Like in 24/7, there is a company called 24/7 where I went for consulting. 24/7. It's a BPO. It is in Bangalore. Very, very big BPO, right? Call center. So these guys are call center business, but they also do analytics. So what they do, they have call center and chat. So all the chat message they will get, that is text data. So you don't have to worry. All the calls also they will collect, because they are the call center business is outsourced to this company. Let's say you have a company and you need a customer care, you outsource to 24/7. Now they will not analyze your calls. That is not possible. It is possible, but they don't want to. They are not analyzing your calls, but for every call, if I am calling a call center, right, they will get the metadata, like who called, how much time you spend on the call, what buttons you press, like 1, 3, 4, to land. This come in a format called VXML, voice XML. So there is a system which will read this from their telephony and give it in sort of like an XML format. That XML you cannot directly load it into Spark. Spark won't understand. It's not normal XML. Like a plain XML with a root tag and row tag you can load. This VXML you cannot load. There is no voice. Since it is generated by these telephony systems, it is called VXML. There is a system which generates it. It has only text data and it is semi-structured, right? XML means what? You have some structure. But Spark is not able to make out. So in those cases, this company has a team who will get this data. They will write a converter to give a structure and give it to Spark team. So that is for every business, it depends. That will be only for, so what they wrote only they know, right? That is not publicly available. It is their business use case. So reading and creating RDD, you don't have to much worry. Most of the data types you can create. Otherwise, there will be a team who will give you the data in some format which you can understand. And then you have to start working on it. And the total unstructured data is a different use case, like audio, video, and all if you're talking. It is very difficult to handle. Trust me. So you don't want to do it, actually. Given a chance also, you don't want to do it. Because these are all fancy things, like you're learning machine learning. So when you say machine learning, people are like, it's a very fancy term. But when you start learning it is statistics and regression, you get bored, right? Same way people say, I'm doing video analytics. They're like, oh my God. So like in movies, they will match the face. It's pure mathematics, first of all. So you have video encoders. What they do, they will read the video data frame by frame and convert that into binary. You cannot directly read a video in any system that you're using. So we had a project where we were analyzing the security CCTV data, right? Not the whole data, some specific data. So there are third-party tools which will read your data and then they will convert it into binary. And then you have to write logic on this binary data, right? That is only, what is the other choice? There is no other choice, right? There is no other choice. So on the binary data, you have to find patterns or whatever you want to do. So it's not like click, 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 somebody's face will appear. It doesn't work like that. It's very complicated actually. And these encoders are very difficult to work with. Even images we do. Image you convert to binary. Again on binary files you have to work. So that is a whole different area. And it requires a lot of additional knowledge than just Spark. Okay. But normal structured, semi-structured data, mostly what you get is structured data, semi-structured data. This you can easily handle in any way in Spark, right? So this is Avro. We will see Avro later when we run. I ran a Flume agent to get the data. So in the Flume class, I will show you how I got this data, this Flume data, right? So you can also get it. It is not a big deal actually. Getting Twitter data is very easy. It's not very difficult. And I want to give you an idea as to what we are going to do today. So these many files have been shared with you. Okay. This is a slide, so that's okay. We don't need the slide for today. Now there is a file called a PySpark word count. It's a text file. You can see here, I just opened it. Okay. So you need this file to start the session. So as of now, we need only this guy, PySpark word count, and we will see others later. Okay. And what we will do, we will take a different approach in the sense like we will do everything together so that you can also understand what I'm doing, right? Step by step we will do with explanation. Otherwise, I will do something and later, at least the basics. So once you complete today's class, you will have a fair understanding of how to create an RDD, how to work with an RDD. Then if I give you a assignment, you can easily do it. And at least you can run it without any problem, right? But the basics, how it is working, what is happening, that has to be very, very clear, right? One flip side of this is I still figured out it didn't work, the Spark UI, right? The live Spark UI is still not available. So yesterday, but we will figure out a way to look at it because I need you to see what is happening, right? So I will reiterate what we discussed in the last half an hour yesterday, right? Because I was only doing it, you were not doing it. So first thing you need to understand is that you can start the Spark shell, right? And Spark shell will allow you to interact with Spark. One of the ways in which you can work is using the shell. Second way is that you can write a program. So if you know what you need to write, what you can do, you can take a notepad, write your Python code, save it as a .py file, so it will become a Python code, and then you can do something called a Spark submit. So once you have a program, you can say Spark submit and the Python file, it will run for you. So that is actually what we do in production, right? In production, first you will explore using shell, and if you know what you have to write, you will write your code and submit it like a file, okay? If it is Scala, you will compile and create a jar file like Java and say Spark submit, right? Now, remember yesterday I told you that Spark can run in local mode and yarn mode, right? By default, when you're starting Spark shell, it is in the local mode, right? It is not using yarn. And you can also mention to Spark, hey, Spark start only in the local mode. So how do you do it? You simply say PySpark, okay? Then you say -- master. Sorry, I always have this confusion. PySpark 2. Then you say -- master, and then you say local. Local, okay? And let me do something. In local, I will type like this. Local 3, whatever it is. You can also type. So you are telling that, hey, start the Spark shell in the local mode, because master you're saying local, and some number called 3, whatever it is, right? And let's see when if you can start along with me. So now what is happening here? What is this 3, right? So when you are starting in the local mode, you can mention the number of processor cores that Spark can use. This 3 means 3 core it will use. 3 processor core, because it is one machine only. Local mode means you are running on one machine, and by default, I think if you don't mention anything, it will use only 2 cores or something. So now I mentioned the 3, so that means now Spark is running in the local mode and it is using 3 processor cores for execution. Okay, so what, right? Now, if you don't know how many processor cores you have, say you have a server where you have like 8 cores or 16 cores and you don't have any clue, you can also do this. So this, we just started Spark, nothing happened, and this is cluster, right? You have connected to the cluster locally on that machine, wherever you have the machine in the cluster. Now, if you don't know how many cores you have, I'm exiting from here, okay? And you can also say local star. Star means use maximum available processor cores. So 8 cores, if you have 8, it will eat for running Spark. Apart from the operating system, obviously your operating system will be using some processor cores. That's different. How many free processor cores you want, you can mention using this argument. Local, then you can mention a number. Quad core, actually it is 8. It's a bit confusing. Physical cores are 4. Each core will have what? How do you know what is processor core? So here, how many we have? 4. I mean, I don't know the rule. In my laptop, there are 4. If I expand each, it will give me 2 virtual cores. So that's a total 8 I have. So if I was running Spark on this machine, it will use 4, maximum 4, because here I have only 4 cores. So you have to go to the device manager and expand and see how many you have. I'm just saying in case if you want to look at it, right? I think my laptop is actually i7. In that, each processor core internally create 2 virtual cores or something. So you can actually see how many cores you have. Those many it will use. But anyway, local mode is not so great in the sense like you can use it for development. In production anyway, you are not going to use local mode. You will say master yarn mode only. So you are able to start Spark anyway, right? Now let's do one thing. Okay, we will also try the yarn mode, okay? But before we go to the yarn mode, let's try to create an RDD, right? So one of the first things you need to learn is how to create an RDD, right? You can create the RDD in 2 ways actually. One is from a file. So I have a CSV file. I want to read it, create an RDD, you can do it. Second is, I don't have a file, but I have an array. You know Python, right? You have an array, or you have, what else you have, dictionary in Python. So I have a Python dictionary. I want to convert that into an RDD. That is also possible. Because sometimes your data will be in a data structure, not in a file, right? What if I have a dictionary of million objects and I want to read it as an RDD? I can create an RDD from a dictionary or any data type in Python. It can be a list or an array or any data type that you have. You can convert that into an RDD. And the first example that I'm going to show you for this is, all of you started, right? Okay, you can actually do this. Either you can copy paste or you can type it also. So you have a range function in Python. Do you know that? It will, if I say range 1, 100, what will happen? It will give me 100 numbers, right? It's a collection. Range 1, 100 means you get 100 numbers. Now these 100 numbers I want to convert to an RDD. Okay, so how do you do it is, you will call a function called parallelize. You can see here, I have written. Parallelize is a function which will convert any existing collection into an RDD. It cannot be used to create an RDD from a file. Like if you have a CSV file, I cannot say parallelize, it will not work. Only for Python collections like dictionaries or sets or array, anything that you have, you want them to convert, you can say parallelize. So right now I have a range of 100 numbers, or it is a collection of 100 numbers actually. And I'm saying that, hey Spark, parallelize this 100 numbers into an RDD called A. So A is your RDD now, actually, right? And I'm also saying SC dot, this is very, very important. So what is this SC, right? SC stands for Spark Context. You can see here. What is Spark Context? So this is a Python shell, right? What we started is a Python shell or PySpark shell. And if I write something here, any code I write, Python will execute it. That is wrong, right? I want Spark to execute it. Correct. If I write a simple Python code here, Python will run it for me. I don't want Python to run it. I want Spark to run it. So in order to access the Spark libraries, you can use this object called SC. So when you say SC dot, you're saying that talk to Spark library and do whatever I'm saying. So I'm saying that talk to Spark and create an RDD from this set of numbers. Yeah, so there is something called Spark session object that you can use for data frames or what you say, Spark streaming. There, if you want to communicate with the library, you can use a Spark session object. SC is your Spark context object. In Spark 1.6, we don't have Spark session. We have SQL context, Spark context and all. So remember, this object is required, this SC guy is required whenever you want to communicate with Spark. But now you create an RDD called A, right? And if I want to manipulate this RDD, I want to filter, or I don't want to call SC because already A is an RDD. And anything that I do on an RDD, only Spark can execute. Every time I don't have to say SC, but during the creation of the RDD, I have to say SC dot. And I say parallelize, that's the method. And I give the numbers, what is it? 1 to 100, 1, 100. So 100 numbers are now available as an RDD. But remember, Spark is lazy. Nothing is happening now. You typed your code, but it will not execute your code, because unless you call an action, Spark is not going to worry about what you are doing. And if you want to call an action, you can simply say a dot collect, and Spark runs, shows you the RDD. So simply collect is probably the most used action. Just try that. If you do a dot collect, you can see the, so now a Spark job ran. That's my whole point. A Spark job actually ran when you call the collect. It read the data into A, then it printed the data, and now you can see the data. We are okay with it. We are not doing any transformation right now. We are just looking at what is happening, right? Now, interesting question. How many partitions does this RDD has, right? Because I did not read it from Hadoop or anywhere. 1 to 100 is just numbers, right? So obviously Spark should have partitioned the RDD. How many partitions? I don't know. Even you don't know. So if you want to see that, you can simply say a dot get. The method is slightly different. That's why I copied it here. Get num partitions. Get num partitions. We'll do a very interesting experiment. How many partitions you have? 8. I have 16. Fine. It may be different. Okay. Is there anybody who is having 16? How did you start Spark Shell? Did you mention master local star? So that the number of partitions depends on the number of processor core. If you started with 3 cores, you get 3 partitions. I did star when I started. I told you can mention local star. So I think my machine is having 16 cores. So it has allocated 16 cores as of now. Yeah, you may be on a different machine. It's a cluster, right? So I am connected probably to a different machine. Maybe different machines actually. Now, behind the scene, these are all optimized. It does not mean like I'm getting a machine with full 16 cores or something. It will be multi-threaded, right? So I'm handling very small workload, right? So even though cores are allocated to me, if it is sitting idle, some other process may take it. So it is just saying that this RDD has, and I can prove it. If you want to try this, do this. Exit from here, okay? Exit and says I want to start Spark Shell with, let's keep a common number. What you want? 5, right? I will say what? 5. So I'm starting with what? 5 processor cores. And if I create the same RDD, I should get how many partitions? 5 partitions ideally, right? Let's see what's happening. You can also try along with me. In the Scala Spark, up arrow actually works. Here it doesn't work. So I will say I want to create the RDD. Now, even if I exit and start, in the Scala shell, it will remember. At least the commands you typed. Python shell, I don't think it will remember. Now, if I do a get num partitions, how many I have? 5, right? Now, so that is what, when practically you do it, these are all confusing. You are in local mode. That means you are only on one machine. It's not a cluster. In that machine, I asked for local mode. I asked for 5 processor cores, and it has given me 5 cores. And now if I do a get num partitions, I see 5. Because by default, how Spark is going to partition your data, it will assume that you have 5 cores. I'll create 5 partitions. So each processor core can process 1 partition. Ideally, we are in local mode again. Now, this rule is applicable only if you do parallelize. If you read from a text file or something, it doesn't do like this. There is a different rule. Okay. Now, another question, can I change this? Like now it is creating an RDD with 5 partition, right? I want 10 partition, or I want 100 partition probably. Can I do it? Of course you can do it. Now, one thing is that you can repartition, but while creating the RDD itself, I want, let's say 10 partition. So you run this command, right? You can simply say comma 10. So while creating the RDD, you can mention the number of partitions. This is what we actually do in production. When we write the Spark code, be it you're reading from Hadoop or Mars or wherever you want, you will say read comma 10. That means I am explicitly asking for 10 partition, right? So it depends on the size of the data and all. then you have to make a calculation how many partitions you want, but you can mention a number and those many partitions will be there in your RDD. No, it is not hard and fast rule. And again, that rule is applicable only in local mode. In yarn mode, you will say what? Number of cores, executor memory, driver memory, that way you manage. This is only for testing. This has no, this number has a value even in production. Even in production, when you're creating an RDD, you will say, okay, read from a CSV file. The CSV file size is 10 GB probably, okay? And comma 10 you say. So I want 10 partition. So now you have 10 partitions of RDD and you could have asked for 10 executors. Each executor will take one partition, then it will process it. So that calculation you have to draw when you are reading it. But my point is, you can mention the number of partitions while creating the RDD. And you can also do repartitioning, right? So I can say a dot, what is the method? Repartition. And then I can say 11. Okay. And then if I do a dot get num partition, oh, okay, wait. You can't change an RDD, right? So if you say a dot repartition, it will just return the prompt, it will not do anything because it cannot edit an existing RDD. So I have to say that repartition A and save it as an RDD called B. Now B will have the same data but 11 partitions. We will launch one more Spark shell, don't worry. But yes, so you can mention, now very interestingly, you can also say repartition 1 million. Possible, beautifully it will work. It will create 1 million partitions, but data will be available in 3-4 partitions, rest will be empty. And that's useless actually. So that number you mention, how many partitions you want, there is no control. Any number you can mention actually, right? It all depends on the resources you have, okay? And when you want to reduce the number of partition, C equal to B dot, can you check the spelling of this thing? I always have a trouble with this. I think it is correct. C dot get num partitions. When you want to reduce the number of partitions, you say what? Coalesce. So yesterday there was a confusion on these two things. That's what I want to explain. So let's say this is your data. These are partitions, okay? 3 partitions are there. And I have data like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 numbers in 3 partitions. And you can say what? Coalesce 2. If I say coalesce 2, what will happen? It will reduce to 2 partition, right? What Spark will intelligently do, it will copy this 5 here and this 6 here and will delete this partition. This is coalesce. Same setup if you are doing, let's say 1, 2, 3, 4, then you have 5 and 6, 7, 8, 9, 10. Same setup, I can say repartition 2. This will also give me 2 partitions. But the difference is it will do a full shuffle. This will go here, this will come here, this will go here, this will come here. It will shuffle the full data, then only reduce to 2. So this increases your network traffic. If you're dealing with terabytes of data, if I do a repartition to come down, that's not a good idea. Always do coalesce. Coalesce will intelligently minimize your data movement. But again, for increasing the number of partition, there is only repartition. There is no coalesce for that. From 3, I want to go to 6, right? I have to always say repartition 6. There is no other way I can do. There is no coalesce, only for reducing. So coalesce came later, I think. Initially, there was only a method called repartition. As an improvement came coalesce, so that when you're reducing the partition, data shuffle is very less actually. So always do coalesce, don't do repartition for reducing. And now your job is to launch your own Spark shell in yarn mode with your own configuration, right? Which means you have to do a PySpark 2 PySpark 2, then do a dash dash help. Type a dash dash help and hit enter. Now this is before launching what I want to do. So we are building our launch script, right? So when you want to launch, you have to definitely say what? PySpark 2, right? Now you want to launch in the cluster mode. So what you say? You say master yarn, right? And now you can give conditions. What are the conditions? So from you here, you can copy paste. What are the things you want to mention? Let's see, scroll down. Let's say driver memory we want to mention. So I'll just copy this. Okay. Driver memory, I want 1G. Okay, 1 GB. Driver class path, executor memory we want. I'll copy executor memory. Executor memory again I want 1G. Default is 1G, but we are still saying it. Okay, or let's keep it as 1500 or reduce it probably. Let's say 500 M. 100 M. Okay, because all of you are launching, right? Cluster will be busy. So executor memory that much. Then driver cores I don't want to mention. Let it automatically take. Executor core I want. So for the executors, I want 2 cores probably. Executor cores 2. Okay. And number of executors I want. Here is number of executors. I want 3. So you can build your script. I mean, we will not run it. First, let you build it, then we will run it together. So I'm saying that, hey Spark, launch in the yarn. You will have a driver and executor, we know. For driver, I need 1 GB memory. I need 3 executors. Each should have 500 megabyte of memory, and executor core is what? 2. You can kill it. Or if you're already in the shell, say exit and open close brackets. It will exit from the shell. All of you can exit. I think it might be resources. In that case, if I run, let's see if it is running. So all of you can exit. I'll just try if I am getting it. Okay. So it is not allowing to mention the argument. I think the reason might be that all of us are requesting resources. So it is denying. So we have only 8 machines, right? 7 machines actually as worker nodes. But what is the configuration we get if you launch by default? sc._conf.get all. So this is the default configuration, right? That we get if you simply launch saying master is yarn. How many executors you have? Can you see here? So you mentioned number of executors 2. You got 2 executors right now. You can also mention the RAM and processor core. I think because all of us are launching, yarn is denying the resources for us. Yesterday, if you remember, I showed you, right, that we launched and saw that these many executors it is asked. So right now I just started with 2 executors. Number of executors is 2. Okay. This is just to show you that we can launch in the yarn mode. Let's do one thing. Let's start in local mode only, because if all of us are loading the data and analyzing, probably resources also will go less in that case. So you can simply say PySpark 2. Okay. And then you can say master local, master local, and I'll just use 2 processor cores probably. And start the shell along with me. I want to show you something. Okay. You can say 2 or 3, doesn't matter. Okay. Keep it 2 if you want. So we are on the same page. And let me know whether all of you have started the shell in local mode. So what I want you to do is that we will create the same RDD with different partitions. So I have 2 processor cores only right now. And if I say parallelize and create the RDD, you know that 2 partitions will be there, right? So I'll just create the RDD and I will simply say a.collect. Okay. So when I do a.collect, I will get the output. Now what I will do, I will create it with, let's say, 10 partitions. Okay. I say 10 partition, and then I will again say a.collect. So very simple. You create the RDD and then you're just calling a collect. Again, you're creating it you say 10, I want 10 partition. Again, you're doing a collect. You're not doing anything else, right? And now what I want you to do is exit from the shell. Okay, so once you're done this much, do what? Exit. Now you are out of the shell. Why I want to do it is the Spark UI, right? So I'm not able to access it when Spark is running. If you exit, you can see the UI. It will go to history server. And in the Notepad, if you go, this is the history server UI. Just copy paste this in your browser. Just open the browser, copy paste it. And you can see your name, username, right? So which one? This one. Create an RDD, collect it. Again, create an RDD with 10 partitions and then collect it, right? And then exit from the shell. And then go to the history server. You should be able to see your username. Where is me? But see, in the UI, what you see 2 collect. This is my first collect. This is my second collect. And do you see the number of partitions? 2 by 2, 10 by 10. First I created default, that will be 2, then it is 10. So you can actually see in the UI, 10 partitions were here in this job, 2 partitions were here in this job. And look at the time, 0.4 second, 90 millisecond. Meaning if you increase the number of partitions, your job will run faster, ideally. So you can actually see these statistics from the UI, Spark UI, right? This should be visible when you're running normally. For some reason, I'm not able to access this UI while we are running. That is why you're exiting and coming here and checking it. So all the jobs you run, you can see here. And also, if you click on one of the job, I'm clicking on this job, okay? You can see the DAG visualization. Can you see? Now, this is very simple because it says you have done a parallelize. That is all you have done. You have not done any special. But if you do some transformations, it will all appear here in a graph. And here it says you did a collect. Okay. If you expand, you can see here, Spark was running some methods inside this collect. And it says duration was this much for doing this. Event timeline, anyway, will just show you the executor driver added. Very important point. What it shows in the event timeline, it says executor driver added. If you are in the yarn mode, it will say executor added. In the local mode, driver and executor are running together, I told you, right? So it will always say executor driver added. This is like one thing, right? In the yarn mode, I can say I want 5 executor, 10 executor, separately it will launch. Here everything is one, local. Stages, we will talk about stages later. These things we already know. Executor will be only 1 because everything is running inside 1. Okay, so that is same. And jobs, we can see 2 jobs. And now we will launch Spark again, local mode only, that's fine. And we will do some analysis. So if you go back to your data sets I shared with you, there is a file called a book. Can you see? And if you open this, it's a book, actually, some book. God only knows what book. Okay, some business book. It has a lot of data, so we like it actually, right? So this is the sample data we will use initially. We will change it also. So I want you to upload this book to Hadoop. So go to your Hue. Hue is your file browser, right? Go to HDFS browser and upload it in your home folder only here. So I think I have it in my home folder. Here it is. Upload it in your home folder. You can upload anywhere, but for this, we will keep it there. So what we are going to do, we will read the data from the book into an RDD, which obviously we have to do. And then we'll do some analysis, whatever possible, right? So first thing you need to do is that you have to read the data. Very simple. If you have the driver, you can connect and you can start working on that. It's all behind the scenes connections only, right? So how do you connect to a RDBMS? You will have a RDBMS client. Same way there is Spark drivers and Hive drivers, like Hive, for example. One way to write Hive queries, you launch a shell and then you start writing the query. But in production, I told you, right, one story when we discussed Hive. I have a friend who is working for 2 years and he didn't know that he was using Hive because he has only one screen. Behind the scene it will be connected to Spark or Hive, so you don't need to use this. Now what I want you to do, say book equal to sc.text file. See how easy they have developed the code. You want to read a file, so into an RDD. So what you do is that you will say sc dot, you don't say parallelize. Previously you were doing parallelize. Now you say text file. Text file is a method, and it can read any text file, meaning DAT or CSV or any type of text data, and then you give the name of the file. Now what is going to happen? By default, it will look in your home folder in Hadoop. So this book is in my home folder. If it is in some other folder, you say user blah blah blah, what is the location, and now this book should ideally contain my data, my book, right? I mean, it could have read here, and you can actually verify that by doing a book.collect. So in the Scala shell, when you do a collect, it will display only 30 lines or 40 lines. This is displaying all the lines, which is bad actually, because you don't need to see everything. I mean, just if you want to look at it, okay? So 10 elements from an RDD. So how the RDD is created, right? So normally if you give a text file, every line is an element in a text file. So that is why here if I do a take 10, I get 10 lines. I think this is one line, right? And then achieving something something, and my book file does not have a proper structure. So sometimes even a word is a line. So that is why it is coming like this, right? Now the most important point you have to understand is in Python, what is this? This beginning and end. When you call a collect method, the output is always presented in an array, collect or take or anything, right? That is the way the data is represented. So you have to be very careful. I'll tell you why later, but look at this, everything, even if you do a collect, it will come with a array. All the outputs on an RDD actions you call, it will present it in an array to you, okay? That's fine, we are not bothered right now. So we got 10 elements. You do a take 100, you get 100 lines from the file, up to you to decide, right? You can also say book. So book, it clearly says it's an RDD, PySpark.rdd, right? Within book, you take 10 elements and let it be a list or an array. Let's keep it as it is as of now, right? Now what you can do, what you need to understand is that, so I have an RDD, I have stored it, right? And I can also say book dot count. So when you do a count, actually, it will show you how many elements are there in the RDD. So you can see 926, lines are there, elements are there, right? Count is an action. Count is an action, take is an action, then collect is an action. There are many more actions, but you can also do a first. You can say book dot first. First means it will show you the first line from the book, right? It doesn't matter actually whether it is ordering, because end of the day, if I read a text file, I have 3 partitions. If I call a shuffle function, there is no order, right? Everything will be shuffled here and there. Or if I create an RDD with 3 partition, I say repartition, order is gone, right? So order data, it is very difficult. When you're transforming, you can mention an order. I want to take only this line and this word and count. That way you can mention. Otherwise, there is no order guaranteed. So another thing you have to understand, we are not working with order data here. Order doesn't matter here because all the data, so if you're looking at a text file, you just have lines. That is all you have, right? So whether you process first 10 lines or last 10 lines, it is similar data, right? So order is not guaranteed. But usually when you do a text file, it will read from the beginning. That is where you say first, it will show first one. But if you look at Python dictionaries, what is happening? In a dictionary, there is no order, right? When you have a dictionary, there is no order. So it depends on the data type also. You can apply data types here, okay? So by default, this is not having any particular schema. That is another problem. Now I read this text file, some of the data will be numbers, right? And some of them will be words, right? Well, I don't have a way to say that this is a number, this is a word, because it is just reading line, every line, string. Everything becomes string now. Even numbers become string. You have a way to mention schema, Okay, you can apply a class, create a class and apply and say that this is the schema I want. That is possible. But by default, when Spark is reading, there is no schema or anything. That is where I said data frames are more efficient, because there you have a proper column schema, right? Okay, now let's do something interesting. I think we have read the data, right? Okay, we started. Probably have to create it again. Book equal to sc.text file. You can say book.txt. And always just run at least one action to verify that the data is already there. You can say book dot what is that, count, or I can say just count, right? This means the data is there. Otherwise you will keep on writing your code, maybe the source file does not even exist, right? Now what I want to do, I want to take this book file and I want to do a word count. You remember the word count, we did it in MapReduce, right? Where you have a data and then you just count the words, right? Same logic I want to apply here. And in MapReduce, it was very difficult if you remember. You had a driver class, then some other things, mapper method and all. And let me show you how easy it is to do here in Spark. So the logic I'm going to follow, now this data is a very sparse data, so we may not get the exact count, but the logic I'm going to follow is that first I will take each line and split it using space, because my words are space separated, right? So you will have all the words separated first, right? And once you get an individual word, right, I will convert that word into word comma one, like what we did it in mapper. So mapper, you remember you took a word and said word comma one, right? And then I will just group the words together and I will count them together and I'll do a word count, right? So let's do this step by step so you understand how we are doing it, right? So let's keep the same variables, okay? You can copy from here, okay, in this notepad. Let's call it as text underscore file. So I know that you already created something called book, but let's keep the same thing. I will say text underscore file equal to sc.text file book.txt. So you're just reading this book.txt into a RDD called this, and I will say text file dot take two, just to see whether I have the data. Yes, I do have the data, right? So 2 lines you can see. So it is working. Now the first thing that you are going to do, we will do it step by step so you understand, okay? Let me do this and I will explain what I'm doing. Let's say A equal to, and just I'm pasting this code, whatever code I got from the Word file. You have to paste till that line dot split, okay? You have to paste till that, this part, line dot split, okay? Whatever is here. Now what are we doing here? So there is a transformation called a map and flat map. There are 2 transformations. One is called a map, another is called a flat map, okay? First let's try the map, then we'll come to the flat map. So just press up arrow and change this to map. So I know it is flat map, I'm just changing this to map. So this is what you need to run. I'll just highlight this. This code you can get from the Word file. Just paste till this, edit this flat map, make it just map here. Okay, I'll explain what it is. So what happened, right? I mean, don't do anything, just run it and keep it as it is. What happened? This map, right? Map is a function. Map is a transformation we use in Spark, right? And what map does is that you give any logic to map, it will run on all the elements in the RDD. So whatever logic you want to apply to all the RDD, all the elements in the RDD, you can give it to map. So I'm saying that take my data and I'm calling map, right? And I'm saying that, hey map, do something for me. And this is an anonymous function, this part. You see lambda? So lambda, we have anonymous functions. I told you yesterday, right? If you want to create a function where you don't have to give a name for the function and explanation, that is where you call it as lambda function. So the way you write a lambda function is that you say lambda, okay? Then this line can be anything. So I just used line here, can be X also. I'm saying that take every line or take every element, okay? Split it using space. I can also write it like this. For example, instead of line, I can say take X, and then this line is just for representation, I'm saying. So map is the higher order function. What map will do? It will apply your logic to everything. So in our case, we have a book RDD and we have lines, and all the lines, it will apply whatever logic you're saying. What is the logic you want to apply? That you represent as a lambda. In the lambda, you say X. So here X represents an element in the RDD. So an element is a line in this case. You're saying that take every line that is an input, and there is a split function you can use in Python. You say split it using space. So what this map will do, it will take this logic and apply to every line. Basically every line you will split it into words, right? Now another important point, inside this map function, you can also call a regular function. Right now I am calling a lambda. That doesn't mean only lambda will work. I can write a proper Python function. I can call it inside map. What map will do? It will apply that function to every line, right? You are expressing as a lambda function, right? So you have to say lambda and then your logic, whatever. So now you have to be careful. So usually you will believe that if I do this, ideally what will happen is that my lines will be taken and it will be split using space. I will get words. But that is where the problem comes. Now I have stored this as a RDD called A, only this part. If I do a dot, let's say take 20, I'm doing a take 20, okay? You got the words, okay? You got the words, but there is a problem. What is the problem? It is a list inside a list. Here you see, this is one word it took, okay? And it created a list for that word actually, right? So your output is actually in a list. The total output is in a list. I'll confirm that, okay? Within that, it has created lists further. So each record, it is converting to what? A list. So you are getting nested structure. There is a nesting that is happening, right? So my idea is that I want to take each line and apply this logic, this what you say splitting logic, okay? And if you look at this lambda function, okay, not the lambda function, the split function in Python, split output will be represented in a, if you give a string actually, it will come as a list actually. That is the reason we already have a list and then you're having another list inside that. Now the problem is if I get like this, I cannot count the words because you have the words. We extracted the words actually. You can see the, big, making, you know, it picked all the words you can see. But they are in a list and then another list outside that. That is why you are doing a flat map. People don't usually explain this because, so that is why if I do the same thing with a flat map, only thing I'm changing is flat map, but the difference I'll show you. If I do a dot take 20 now, I did a flat map, okay. Can you see the difference? Do you see the difference between map and flat map now? Because if I do a flat map, it will do map only, meaning it will apply this space splitting to every lines and all. That is the same thing. Map will take your logic and apply to every element. Flat map will also do the same thing, but it will flatten your structure. You will not get this list inside a list, rather than it will expand it. Now you have individual words in a single list. So many people have this question in when they perform basic text analysis. Why are you doing flat map? Map can do this for you, right? So if you do the map and flat map, you see the difference, why it is not possible. So if you want to expand this structure, you can use a flat map. That's my point. If you want to keep it as it is, probably be with map. I don't have any problem. Right now, my problem is word count, and I don't want this. I want this. So that's why I used a flat map. So using this lambda thing, right? I can define a lot of things. I can say lambda, take every element and do something else. So it's very easy to represent. This is called your anonymous function. This part is called anonymous function. And now you understand, if you write something like this, Spark has no way to understand what you're doing unless it runs it. This is your weird logic. I can write anything here, right? And unless Spark loads the data and apply this and run it and get the output, it doesn't know what you're talking about. So these are all without touching your schema. I'm not even bothered about whether it is a string or an integer or a column. I don't do any of this, right? So we are going to discuss something called Spark SQL, okay, which may be more interesting to you because in my last class we learned core Spark, right, where we were discussing about RDDs, then transformations and actions and all. That is also okay, right, but that's more programming stuff, right. Well, when it comes to Spark SQL, like the name suggests, there is SQL. So you can at least do something which you already know. You can write SQL queries and all, but not just SQL queries. You can do much more than that with Spark SQL, right. Now, the first thing that we have to understand is that in core Spark, right, in core Spark, what you did, you have something called SC. You remember this thing? You will say SC dot, right, the Spark context object, right, and you are using this SC to communicate with Spark library, right? Then you create RDD and do blah blah blah, right, and once you read your data, it definitely becomes an RDD. There is nothing else. In core Spark, the only thing that you have is RDD. However you read the data, it becomes an RDD. And once you have an RDD, what you do? You do transformations and actions, right? You will either say map or flat map or something, and finally you say collect. That's an action. So this is the flow in core Spark, what you do normally, right? Now when you go to Spark SQL, I'll explain what is Spark SQL. Spark SQL is Spark's module where you can process structured data, like rows and column type of data, right? The first thing is, this is also a bit confusing. Okay, in Spark version 2, they have introduced something called a Spark session object. In Spark version 2, that is, we are using Spark 2, right? They have introduced something called Spark session object. Okay, using this you can access Spark SQL. So you will never say SC dot. If you say SC dot, that means you are talking to core Spark, right? And the Spark session will be available as a name called Spark. This is again confusing. So you will type Spark dot something. That means you are using Spark SQL, right? So the name of the object is Spark by default. When you start the shell, you can see Spark created, it will show in the shell when you start the Spark shell actually. So this is the name of the object we will be using to talk to Spark SQL library. Whatever you want to do, you have to say Spark dot, read or write or anything, right? And we will practically see that. Now, once you have some data, right, in Spark SQL you create something called a data frame. Data frame. This is the data structure we have in Spark SQL. Okay, and you may be already aware of data frame in your Python class. Very similar, like a row column format. That's called a data frame, right? So in Spark SQL you will create something called a data frame. Once you have a data frame, you can analyze the data. You can say select, filter, particular column which is greater than something, or all these things you can do. This data frame can be registered as a table. So a data frame is not a table, by the way. Data frame is a structure, like you have a row and column, right? It is not a table as such, right? But in Spark I can say create a data frame. Now I want to register this data frame as a normal table. Once it becomes a table, you can write SQL. So this will be the flow. So let's say you have some data, say a CSV file. You will say read the CSV file, create a data frame. Okay. Once you have a data frame, you say save this data frame as a table. So now you have a table. Once you have a table, you start writing SQL on top of it. This is usually what people do in industry, right? Like so very few people actually write data frame queries, because if you want to directly write queries here, you should know the dot filter or whatever commands you are using. SQL queries are very common, right? So usually people will register it as a table and then start writing your SQL queries. Data frame is a data type actually that is inside Spark. It is like an integer or a float. It's a data structure that you have. It's not a table. It looks like a table to you, right? Internally it's not a table. So I cannot run SQL on a data frame. That's not possible, because SQL need a table. So once you say register, the same structure is coming as a table. There is no difference at all. Same column row will come. You start writing your SQL queries. The question is, what am I missing? Because for Spark SQL there is very less theory. It is full of hands-on. Okay, but some theory is there which you need to really understand. Otherwise, you will get confused, right? Most of it is hands-on. Okay, but I'm just thinking whether I'm missing something. So you have to create a data frame, register it as a temporary table or a permanent table. Then you start writing your SQL queries. Fine, that we understood, right? And some of the experience from the industry, from my point of view, is that what is happening in the industry right now, right? Spark is currently on 2.3.1. This is the latest version of Spark. Okay, 2.3.1. And mostly Spark is on 2. Everybody is on Spark 2, right? Bank of America is on 1.6.3. I was with them last week. So my point is, why I'm saying this is a very important point, because a lot of companies actually run 1.6, because you can't migrate in one day. You can't say like tomorrow I'll go to Spark 2. It doesn't work like that. A lot of jobs will be running, right? Now why am I talking about 2.3.1 is that after 2.2 of Spark, there has been a lot of improvements. Spark 2 itself has got a lot of improvement. After 2.2 version of Spark, especially 2.2, 2.3, they have introduced like n number of changes in Spark, lot of improvements, right? And what the open source community is saying is that do not use RDDs. You learned RDD in the last class. I know that we did map, transformation and all. Okay, but now what Spark people are saying is that they say, if you are writing a code, write it as a data frame. If you can. If you cannot create a data frame, so maybe there is some type of a data where you cannot give a structure. Not possible, let's say. Probably you have to go back to RDD. That's fine. But if you want performance, okay, always use data frames. And there is something called a data set, data frame or a data set. So I will talk about what is this later. I don't want to confuse you a lot. Data frames, you already know what it is. There is another thing called data set. Data frames, once you create a data frame, if you are a Python developer, you query using Python here. If you are a Scala developer, you query using Scala. SQL runs on table. There it is pure SQL, no Scala, no Python, nothing. These two are equally efficient. So internally, there is something called a catalyst optimizer in Spark SQL, catalyst. You can search for project catalyst in Google and you will get tons of information. Catalyst is the optimizer of Spark. So if you run a SQL query, this is the guy who will optimize and run it in proper format. And especially after 2.2, okay, they have introduced something called a CBO, cost based optimizer. This is available only after 2.2. It's a major improvement. Cost based optimizer means if you write a SQL query, what it will do, it will try to create 3-4 plans how to run the query, and then it will internally check which is the best plan to run, because you wrote a filter, then group by, then join, then filter. So ultimately how much data need to be loaded and how the query has to run should be decided. So CBO, cost based optimizer in Spark, is available only after 2.2. So if you are using 2.2 or any future versions, if you write your SQL query in any fashion, internally Spark is going to optimize it. So it doesn't matter if you are writing it on a table as a SQL query or directly on a data frame, both there is no performance difference now. We had differences in 1. Spark 1, if you are using, these things are all different. But in Spark 2 internally, you write the SQL in any way, it's gonna optimize. Again, it has to be more than 2.2 for better performance. That's what we have seen so far. Because I was using 2.1. 2.1, it is not so great. I think our cluster is running 2.2. Is it? I remember, I forgot what version we are running. But that's okay. This is a learning cluster. In production cluster, that is what, when Spark 2 came, a lot of people wanted to migrate. Now, if anybody is migrating, they'll be going to 2.3 only directly. Because the benefit of 2.2 plus you need, so the minimum version you have to go is 2.3 for all the performance and all. Right? So here I can use my SQL language. Here I cannot use SQL. Here it is a Python. So it's actually called a language integrated query. What you write here is called a language integrated query, either Scala query or Python query, right? Here or here you write, both of the things are same. Some people are, so if you are a Python expert, right, you have a good knowledge of Python, then people prefer data frames because they already know data frame and they can write a query. Maybe they are not so good at SQL. SQL is also a language which requires some level of knowledge. You can't just write a SQL query. If you are a seasoned SQL developer, then you know how to write your query. So those people will prefer this way. Others will prefer this way. I'll show you both. Whatever you do on a data frame, it is an RDD internally. So RDDs will never cease to exist. Spark is RDD, but you are getting layers on top of it. Like data frame is a layer on top of it. So even though I write a SQL, internally it will convert to a series of RDD transformations and actions. There is nothing else actually. But you don't have any control on that, like how it converts or what it does. So it is, in a way, I can say like Hive. What Hive is doing, you write a Hive query, it will convert to a MapReduce job, right? So here, very similar to that, you write a SQL query. Internally, it will be running on RDD, but the speed and power will be completely different since you are using Spark. Now, last week, we had a meetup, big data meetup, where I was talking to some other folks who are actually running Spark jobs and all, some other companies and projects and all. So they shared a very interesting thing to me. I am not quite sure because I have not actually thought about it. So couple of my friends, they were saying that in their companies, right? So one common question is that should I write in Python or Scala? I want to write Spark program, but should I use Python or Scala? Now here it doesn't matter because you are using SQL, but let's say you are writing an RDD code, okay? So these folks were saying that when you are having, like, let's say a 16 core processor on a data node, Python cannot utilize all the 16 cores, it seems, when it is executing the code, right? And also the memory management in Python is very poor, okay? So what they were doing, so the point is, like, if you have a data scientist in your company, he will prefer only Python. He will say, I will not learn Scala, I will write Python, everything. So what these folks were doing, their Spark developers were actually writing code in Python, okay? But they will convert to Java and execute it. Sorry, Scala and execute it. The advantage is, if you convert to Scala, it is a jar, you can run it in a proper JVM environment, you get better memory management and processor management. It's very easy. I mean, end of the day, if you know a bit of Scala, like if you are a Scala developer and if you have a Python developer along with you, so if you are writing a transformation, right, just as example I am saying, you will say what? Map, here you will say what? Lambda x, x comma 1. Here you will say map x comma 1. You have to manually do it, but in order to leverage this JVM's power, because you get this garbage collection and all these properties with JVM, you don't get it in Python, okay? So even though the community says Python and Scala programs are equally powerful, but when you run in a very large production environment, Python has some small disadvantages. So that is the time they convert to Scala and execute as a JVM code, like normal byte code. So Java is also fine, very much fine. So if you are a Java developer, these guys were using Scala a lot, so they know Scala better. Scala or Java, because the resource optimization of a JVM you cannot get anywhere else, right? Any other language you use, the JVM's power is always with JVM. So Python, so that does not mean like you should not write Python code. That's what I'm saying. You can write your Python code and say that this is my logic, boss, this is the logic. You convert to whatever format you want, you run it. End of it, it's the same logic, right? Because otherwise you have to sit and learn Scala if you're a Python developer ideally, right? That is not required. So that is how they were giving an interesting example. Any Spark implementation will have some Scala, guys, for sure. Okay, Scala is always preferred, but that does not mean you should not write Python. You can convert it anyway. If I'm writing RDD code, first problem is that the code will become lengthy. I can't write SQL on RDD. So a simple SQL code like select and filter might have to write a lot of code. Second thing is that if I am writing my own RDD code, not the data frame code, the problem is that Spark has no way to understand how your data is being represented. Data frames have a schema, so it knows how the data looks like. So that means, let's say you have a CSV file, right? This is nothing but a CSV file, and I create an RDD out of it, right? And in the RDD, I will say there are 10 rows or something I have. I write some reduce by key, okay, and some very weird, complicated transformation. By looking at this, Spark does not know what you are trying to do. So it has to load this entire data to the memory, and then only it can process. The same thing if I create a data frame out of it, I'll show you how to create it. I'll clearly say I have 3 columns. This is integer, this is float, or this is whatever. And if I write a SQL in which I have already written filter this column, okay, only these 2 columns will get loaded in the memory. So it knows that you're talking about this column. It has a view of the data. RDDs cannot give you that, since you are writing anonymous functions on that. If I'm writing an RDD code here, right, RDDs use anonymous functions. And anonymous functions do not have any structure or schema associated with them, right? So if you write a RDD code, this entire data need to be loaded into the memory, because Spark doesn't know what you're thinking. But if I represent this data as a data frame, I'm saying 3 columns are there. Then I say filter the table where I want only these 2 columns. If I execute the query, it will load only these 2 columns to the memory. It will skip this actually, because it knows that you don't want this actually. So the optimizer can actually see how your data is lying in the file or wherever you have it. So it is much more memory efficient if you write data frame queries. That is why Spark says use only data frames. If Spark is converting your data frame into an RDD, it is very powerful. If you are writing your own RDD, it is very bad actually. That's what I'm saying. If I have this file, I write my own RDD code. Okay, I have no way to tell Spark that don't load the full data, load only this and all, because I'm writing anonymous functions, right? But if you write a data frame, it will understand, okay, you want only this, right? It will create the code accordingly every time when you run it, right? So that way data frames are much more efficient. That's what Spark says, okay? In Spark SQL module, what you need to learn is, so this is a data frame, right? You have a data frame. How will you create this? That is exactly what you are learning. You are not learning anything else in Spark SQL module, because once you have a data frame, either you run a SQL query or you can run your own queries. Now, one way you can create a data frame is from an RDD. You have an RDD, you can call it and say convert this RDD to a data frame. I'll practically show you, okay? But there can be situations where your data is an RDD and you want to convert that into a structure like a data frame. So I can call a function to create a data frame for me. Second thing, if I have a CSV file, right? From the CSV file, I can directly create a data frame since it is structured file, right? Third is if I have an XML file, right? I can create a data frame from this guy. Fourth is if I have a JSON file, right? I can create a data frame from here. Then if you have a Parquet file, so these are all different file formats, okay? I can again create a data frame from this Parquet file, right? Text, XML. Now if you have an RDBMS table, this is an RDBMS table. I have a table. From this table, I can read and create a data frame. I'll show you this practically. From MySQL, we'll read. Okay, this is very useful. Sometimes, like in GE, we have a situation where you have they use Greenplum. Greenplum is data warehouse. Okay, so their primary data is in Greenplum, and then they have some data in Spark. It's in a Hadoop cluster, right? Now, sometimes they want to do a join operation in Spark SQL. Now, one table is already in Spark. The second table is in Greenplum. So, instead of RDBMS, here it can be Greenplum also, any SQL store. So, if I have Greenplum here, using the driver, I can say read it into a data frame, then I do join. So, that means Spark can actually get the data from any SQL store, Oracle, Greenplum, Teradata, anything on the fly, and then it will represent as a data frame, and then you can do whatever you want, right? Also, you can create from Hive, very important. Hive, right? Hive is by default your data warehouse on Hadoop, where you create all the tables and all. If I have a table in Hive, I can read and then create a data frame from Hive. Also any NoSQL database, any NoSQL you have, you can read. This is the true power of data frames. Like from any source you can get the data, and you can put ulta, like you can read from Cassandra, dump it into as an RDD, or read from JSON, save it into Greenplum, because read and write is possible, right? So once you have a data frame, you can also save it. I can say I have a data frame here, I want to save it as a table in Hive, save it in a table in RDBMS, or save as a CSV file, or save whatever. Only thing you should be aware of the schema and how to save it. It should match with your requirement and all, but read and write from any of these sources are possible. And in our course, I will show you how to read from Hive, RDBMS, Parquet, RDD, CSV, XML, JSON. NoSQL I don't have right now. NoSQL we used to read from MongoDB. So MongoDB there is a connector. Using that you can read a collection and create a data frame very much. So once you know this, rest story is very easy. In Spark version 1, we had an object called SQL context object. This is where in Spark version 1. We also had another object called Hive context. So this guy was used to talk to Spark SQL. This guy was used to talk to Hive from Spark. In the new Spark 2, you have only Spark session. So we call it as just Spark object, right? But what the community has done, they have retained the support for the backward compatibility. So even in Spark 2, you can create this object and call the data possible. So sometimes you will see that because somebody could have written a code in Spark 1. Okay, we had that issue in one place. Somebody could have written a code in Spark 1 and that will say SQL context. And when they migrate to Spark 2, they don't want to rewrite the entire stuff. So the same code can be retained. So if you see this SQL context, Hive context, these are the objects we use in Spark 1 especially. In Spark 2 there is only something called Spark session, Spark, that's all you have, right? But these things you might see in old versions, Spark 1. Tungsten is a project again from Apache Spark. Tungsten, the whole idea of Tungsten is to speed up your Spark processing, be it RDD, be it data frame or anything, but the majority of contribution is on data frames actually, because Spark says RDDs anyway there is no optimization possible. So data frames are the future, that's what Spark says. So this Tungsten project is actually used to encode and decode your data. So when you actually store your data, right, how it will store? So I say in Spark SQL create a data frame and then I just want to store it somewhere. So Tungsten has something called encoders which will help you to encode the data and store and then decode it. I will probably talk about it in the dataset section. We have a dataset section. There I'll talk about Tungsten, Project Tungsten. And what is that? Jupyter. And upload the notebook. The notebook name is dataframe_basics. Now, very important point, I think in the last class we struggled. Ensure your interpreter is PySpark here. It will be Python for some of you, then it will not work. Yeah, Python means it will run using Python. It won't use Spark at all. You write a Python code, it will execute using Python libraries. It won't even talk to Spark. You will get errors then. It will say, I don't know what you're talking about, because it is just this thing, right? This is actually communicating with whatever is behind the scenes. It is like a web UI, right? So if you select the PySpark interpreter, then only Spark it will invoke. If I say Python, you say 1 plus 2, Python will add 1 and 2. Python program will add. No Spark libraries will be invoked. So you will get error saying that I can't find the library, this, that and all. Okay, so getting started with the data frame. And the first and the most interesting point is that if you have JSON data, so many applications are producing JSON data. JSON is very common, right? So this people.json is nothing, it's not a very complicated file. I'll give you a complicated file later. Yeah, so if you open this people.json, it is a very simple JSON file. It's not a complicated file. I'll give you a complicated one. Now the beauty of Spark SQL is there is a read API for JSON, which means if you give a JSON file, it can directly read and create a structure out of it. But again, you have to be careful. What it does, it will read the key as your column name. So it will create a column called name. The value will be Michael. And again, there will be a column called name. I mean, same column, Andy will be there. For age, here you will end up having null values because you don't have anything here, right? Because it is automatically inferring your schema, right? But the advantage is, if I have a JSON file, I can directly say read it. You don't have to do anything special. So if you just scroll down here, first thing we are doing is from PySpark SQL, we'll import the Spark session. Remember Spark session? That's the entry point to Spark SQL library. Let me see if this will work, because in some of the notebooks it could have already created this Spark session. So it will throw an error saying that, hey, I can't create Spark session. That's fine. So here you are saying that from PySpark SQL, see, there is an error for me. So what this error actually says that it is already running, so it cannot create it. Okay, that's fine. If you get this error, it is fine. But if you are writing your own program, let's say, not the notebook, this is how you start. You will first import the Spark session. Then there is something called Spark session builder. You can give a name for your application, and then you can call this method called get or create. Okay. So now my Spark session is already running here, and if you want to create a data frame, you just clear this output. Okay. If you want to create a data frame, it's very easy. All you need to do is this. You can simply say spark.read.json and then give your path. So in my case, the data is in datasets people.json, and if you want to see the data frame, you can say df.show. So this is your data frame, and I think you might be familiar with this in your Python class, right? The same name column structure. So spark.read is a method, and there is spark.read.json, spark.read.csv, spark.read.parquet. So directly you can read. You don't need any third-party tools. But when you are actually loading XML files, right? If you want to read XML file, you cannot say spark.read.xml. It will not work. Why? Because XML file has a different structure. Who works with XML? I work with XML. Yeah, you have a root tag, then row tag, and so all this you have to mention. So we have a third-party package using that you can read XML. But if you want JSON or CSV or something, you say read, it will read by default. But XML, there is multiple levels actually, right? JSON also you can create, nested key value pairs you can create, but by default XML support is not there. You have to use a Databricks package to read and then create an XML. I'll show you. But make sure you can create this data frame. Anybody who is not able to do it? Two important points here. First, the name of your data frame is df in this example. It can be anything, doesn't matter. Second thing, here when you use this method, there is automatic schema inference. Meaning, you are not saying what is what schema. Spark will take a best guess and apply the schema. If you want, you can create your own schema. So let's say I want to read this JSON, but I want this column to be date or something, string actually, imagine, okay. So that means you can create your own schema and tell Spark that, hey, when you read, don't just infer the schema, I'll give you the schema. You apply that schema. So by default, it will not do it. By default, if you call this method, it's automatically inferring all the schema. And most of the cases, this is sufficient. It can understand your data. A data frame looks like a table actually, right? A data frame is like a row and column. And another important point is, you see each row, right? Each row is called a row object. It is not a table. So one common confusion is a data frame is never a table. Okay, each row is an object. Actually, internally it stores as an object. Okay, and I will talk more about this when we come to data sets, like how each row can be accessed and all these things. But understand, columned values and row by row it is storing object, object, object.
Each row is a row.
Row object. So it's called a row object actually. But there is a catch here. Maybe some of you will understand, some of you may not understand. what will happen? Let's say you try to access this value, right? There is no value here. So what should happen ideally? I want to access this value. You will get an error. You will get an exception, right? Because there is no value here. But the problem is, in data frame, it knows that you have 3 columns and each column has some data. So let's say you wrote your data frame SQL queries and all, you compiled it and run it. Okay, you will get an exception only while running. You will get only runtime exception, and that is bad. Because if you have like 70 columns of data, let's say in one column some values are missing, you wrote a SQL query, and if you run the SQL query, that's what I'm saying, if you type the SQL query, okay, it will say everything is fine, it won't say anything. But when you package and actually execute it, okay, when it actually reads the whole data and try to, you will get a runtime exception saying that, okay, there is a problem. That is where data sets are efficient. If you create something called a data set, okay, it looks exactly like same. There is not difference. You will have columns and rows and everything. But when I am actually coding my steps in the shell, I am saying the shell, if I just write access this value, even before executing, it will say that don't run. It will give me a compile time error, not a runtime error. It will say that there is no value here. Don't compile this code. So that is the major difference in data set and data frame. We'll see what is a data set later. Okay. So data sets are very new, and Spark has started using it now only, and people will slowly migrate to that. So that is because in data set, each row will have your own schema attached. It will not be like a raw object. You can write a schema, proper schema, and say that attached to every row. It will internally encode and store it. It knows in each field what is there. So it knows there is a null. So if you write a select on this, before actually running, it will say you have a boss, you have a null, don't compile me. Okay, I will throw an error, please correct it. This is just an example. Null, or if let's say something missing, nothing is there, you want to access, you end up in an error. So where will you troubleshoot? That is the question, right? So if I get a runtime error or a compile time error, which is better? The better one is compile time error, right? So because the internal structure is stored in a data set, in a data frame it never stores. It just assumes these many rows are there. It never knows what is inside the row, right? So here if I access null, I'll get an error, right? It will give me an exception. So I just want to be aware that if I run my code, I should not get an exception. A lot of people, what they do, they don't take care of nulls. They just say read and create. They don't really care whether it is nullable or not, right? And then when you actually run, then you start getting exceptions saying that I don't find a value here or there. So that time when you create a data set, it can actually, even before compilation time, I can say that these values are nulls or data type mismatch, maybe something else, not even null, data types mismatch, right? So those kind of exceptions you can easily handle in data sets. But the problem is, I have not seen people actually using data sets these days. It's very new. Data sets came in Spark 2, okay, it's very popular, but people are still using data frames only. Probably they are more comfortable doing this. I don't know what is the reason. It comes more or less like in an alphabetical manner. Okay, you can switch it and save it if you want, but the structure comes like this. The JSON actually has name and age, but column names are projected like this. That is where you might want to apply your own schema. You want to say that I don't want this, I want first column as name. Either you can write a query and extract the column and create another data frame, or you can say I'll create my schema where the first column I want this, second column I want this, then it will create like that. So here it will automatically decide age and name. You don't have a control on that actually, right? Now once you have a data frame, you can just print the schema. So there is a command called print schema, and this shows that there is an age column and a name column. Okay, age is long and name is string. These are the data types associated. So here you have nullable true right now, right? Null values are true. This you can also have nullable false. You can change it. Okay, so and you can simply say df.columns. It will just show you what are the columns you have, right? And there is also a describe command. So describe command is very much like you are describing a table. It says data frame summary string age string name like this. When you call a describe, it is like as good as collecting the statistics. So in SQL you have this table statistics, right, where you collect information about the team. So when you call a describe, actually what is happening is it will actually summarize whatever you have in a data frame. And then if you do a df.describe.show, what it has collected, it will look at here. For example, age 2, the mean is this, standard deviation is this, min is max. So wherever possible, it will calculate. So this is useful if you are running aggregate queries and all on the data frame, because once you describe these values, it will find useful information from this column. So this is like you do table level statistics, right? How do you say you table dot generate statistics you do, right? So very similar to that, if you do a describe, it will attach a column and it will say that these are the summary of the tables, interesting field summary. If you want, you can do it this. We don't actually use this describe and all, I mean, because describe method and all came long back actually, right? So now you don't have to run this method in 2.2 and 2.3, because every data that you are storing, it will already analyze, like whether say for example you are storing gender column. So gender column usually has male and female, or let's say not applicable, so only 3 values are there. So you can actually choose to encode that column in a data set. You can say that instead of male, store it as 1, instead of female, store it as 0. So you are actually reducing a lot of data in that column, right? If I store it as string, I am taking a lot of data. So these kind of statistics are not, you don't actually run describe these days. These what you say encoding techniques are there now on data sets, which can store your data, like instead of a male store as 1 and female it is run as 0. So the column values are much reduced. So are you able to do till this, till the describe? Yes, right? Okay, now some data types make it easier to infer schema, like tabular formats and CSV. However, you often have to set the schema yourself if you are in dealing with a dot read method. So what we are trying to discuss here is, if you are getting a proper JSON file or a CSV file, you can simply say read, it will create a data frame because you have rows and columns. Now what if you do not have a proper structure to your data? Then how do you read the data, right? That time you can apply your own schema to the data, right? And to do that, we have a data type called a struct. Have you heard about struct anywhere else? In SQL you have, right? RDBMS, have you used struct data type? Not in Spark. Like struct is a data type where you can have multiple values. Within one struct, you can have multiple types, and then you can say dot and access it. Say for example, you want to store your address. So address will be like house name, then what, city, then street, then state. I can store this entire thing in struct. Okay, then I can say I want to access only my city. So I can say a dot city, it will give me only the city from the struct. Something like that. Okay, so that is the original struct. I have used it in Java. Okay, long back, not now. From that, they have created this struct data type in Spark. This is a data type. So what I'm saying that import struct field, this is general. Within that, I want string type and integer type. Whichever data types you have, there is a type, like there is a float type, integer type. Okay, so I am importing this so that I want to represent my schema, right? So first thing is that we import this data types to represent our data. And next, what you need to do is, okay, you will create your schema. You will say struct field. You will say age. I want a column called age, that is integer type, nullable true. I want another column called name, that is string type, again nullable 2. So this is your schema, actual schema. Okay, struct will hold everything in one kind of like a container. So that is a struct field. You are saying that these are the fields I want. There is one thing called age, that is integer type. Another is called a name, that is string type. So this is each field you are representing, or each column. Struct field is a wrapper like thing. Okay, inside that you are saying I want an integer type column, I want a string type column. So you have created 2 columns here. So this is like your schema that you are defining. Okay, and then you will create something called final structure. this is optional, you will say struct types, and here you have fields equal to data schema. You are saying that use these fields I have defined here as my final structure. And then in the same JSON read, you say spark.read.json. You will say read the JSON, comma, you will say schema equal to this schema. So what is going to happen? Your own schema will get applied here, right? Now, actually in I think in Python also it is there. There are two ways to attach schema. One is using this struct type. Okay. Apart from this struct type, do you remember in that captain example, named tuple, right? You can also use named tuple, but the drawback is if my memory is correct, named tuple can have only 22 or 23 columns max in the schema. So if you want bigger number of columns, you have to always use struct type. Struct type will support as many columns as you want. Like you have a very large table, right? In Scala, it is called a case class. If you don't have a named tuple in Scala. So if I am creating a Scala program and I want to attach my own schema like the captain object, right? I don't have a named tuple in Scala. Named tuple is only in Python. I'll create something called a case class. Very similar idea only, right? So then you will say attach the schema and print the schema. So I'll just run this. Yeah. So now it is coming with whatever schema that you have attached, right? You can see df.print schema. Again, the same schema we have given, there is no difference, but I just want to show you that this is possible to attach your own schema. And you can actually refer the Spark documentation. So if you don't believe what I'm saying, right? So I'll show you in the documentation. Older versions 2.2. There is a Spark SQL data frames and data sets. Okay, you can scroll down, go to the Python code, and there is creating data frame. Scroll down. Somewhere it is written this struct type. Can you see? Here it is written, right? So it says here it create an RDD of tuples, create a schema represented by struct type matching the structure, apply the schema. So struct type can be used in many places. Here they are creating an RDD, then applying the struct type and creating the data frame. What we did, we created a JSON with the struct type. Wherever you want to apply the schema, you can use a struct type actually. I'll show you, there is an example. So this is not that, this we are using only this thing, what you say, struct type. When you are using named tuple, what you need to do is that if you have an RDD, from this RDD I can create a data frame, right? I have an RDD, so right now we don't have an RDD, we have a JSON file. So from this RDD, if I create a data frame, either I can say apply a struct type or apply the named tuple, because RDD need to hold some schema if you want, right? So I can create a named tuple and say that, hey, just convert into a data frame. It will create a data frame. I'll show you that. Okay. Now, are these queries familiar to you? Like how to access a column? Because I don't know whether you have seen this in Python data frame. Like you want to access a column, you simply say df age. So that's a column age. And if you call the type on this age data frame, this age column, it says PySpark SQL column. So this is the column type that we want. And you can also select individual columns. So you can say df.select age, and you always do a show thing, show. So when you want to see the output in a data frame, you have to always say show. There is no collect. Collect will give you the underlying RDD. That's a different thing. Okay. So here in your notebook, it's df.select age, right? That won't show you anything. But you say dot show, you can see that column or whatever is that data frame contains. Show will show you the first 20 rows. Show argument will show you the first 20 rows. These are similar to Python. Okay, you have a Python data frame commands, right? Very similar to that. But there also you have filter, then you have group, join, kind of operations, right? Very similar to that, similar commands only. It is similar. Some commands are slightly different. Like you don't have this show command there for sure. Yeah, show command, because you don't see something in Python. It's not like this. Here we have a data frame. So anything that is there in a data frame you want to see, you have to say dot show, and it'll show the first 20 rows ideally. Something else will be there.
No, it's just you type it and you just.
It will show. You don't have to say show, because here everything is stored internally as a data frame. So if I simply say df.select, okay, it will have the age, right? But it'll just get stored as a temporary data frame. I have to say dot show to see anything in a data frame actually. Okay. You can also say the type of age. This again you will have a data frame. So look at here. So when you do this, right, I can store it as a different data frame. I can say Raghu equal to this. Raghu equal to df dot select age, which means you can select a column and so store it as something called a Raghu. Now Raghu will become a data frame actually. Okay, and if I want, I can say Raghu dot show here. So any operation you do on a data frame will result in another data frame, and you can save it if you want, like Raghu this way. If you don't want to save it, that's also fine, right? And that is what we ran here, type df.select. I'll just remove this so that we don't confuse it. So type is actually a PySpark SQL data frame, and here you have the same show command, right? You can see what is inside this. And then there are some head command. For example, head will actually give you a list of raw objects, right? So this is important in one way, because if I do a, where is it? Head 2, okay, head 2 command will give me the first 2 rows from the data frame, and see what it is. It is a raw object. This is your data, this is row, ROW, row object. So you can actually see that it is storing the data as a raw object. It is not storing like a text file or anything, it's actually an object. Okay, this is called the raw object. So head will give you individual row objects from the data frame. You can also do this, and they say show, same thing you will get, no difference at all. Now you can also create new columns. For example, you can say with column new age. So if I run this, right, I am saying that df dot with column, I am saying new age, comma, then I say df age dot show. So you are adding a column called new age, right? So any idea how these values came in the new age column? So you are saying that I want to create a new column called new age column, okay, where it is just a reflection of the same column. But you can modify that also. You can say I want to add values or something, and this will create another data frame here. And if I do a df.show, the difference is your original data frame will remain unchanged, because very much like RDDs, data frames are also immutable. So this could have created a temporary data frame in your session as of now, right? You can also rename if you want, df dot with column rename. There is an argument called with column renamed. You can say age super new age, something like that. So you are renaming this column basically. More complicated operations to create new columns. I mean, here all you are doing is that you are creating a new column, you are referring to the original column, and then you are multiplying by 2, adding 1, dividing by 2, and like that you are creating new columns, right? So I hope these things are very clear. Now the important thing is, how do you use SQL? So I will show you another use case where we will be running some queries using Python. As of now we have not run any queries. The important thing is that how do you use SQL? So this is not a table. So far what we are writing is just a data frame. If you want to use SQL, you have to use something called create or replace temporary view. You are actually creating a temp table. See, you have to say df dot create or replace temp view people. What this command will do, it will create a temporary table called people, and then if you want to run SQL queries, it is like this. If you
It is possible to run SQL queries.
yeah, very much. See, what am I doing here? I create a temporary table called people. This name can be anything, and this temporary table will register with Hive. It's a temporary table. If you exit, it will be gone. Okay. Once you have this table, if you want to run SQL query, simply say spark.sql whatever query you want, right? But again, I'm storing it as a data frame, and if I do a show, I can see here. So this Spark is Spark session object. You say spark.sql, any query, it will run on that table. Got it? But if you exit this shell, this table will be gone, because it's a temp table, it's not a permanent table. If you want a permanent table, there is a command called save as table. If you use save as table, by default it will go to Hive. Okay, or if you want to dump it into a RDBMS or something, you can create a connection. Then you say save as table, it will go to the RDBMS. That is also possible, right? I'll show you how to save it in a Hive table. But now any SQL query you can run here. Any SQL query that you want, regular SQL you can run. The results are always a data frame. You get a data frame as a result, right? Okay, great. And we will run this later, this filter approach and all we will do it later. Okay. And what are we trying to do? We will create an RDD. From the RDD we will create the data frame. We will create an RDD. From the RDD we will create a data frame. Sometimes that is required. Now there are two ways to do this. One way is that I have an RDD, right? This is RDD. So let's say this is RDD. Each row I will convert to a row object. So this is normal RDD lines. I can say that convert each line into something called a row object. And once, so this is row object now. Then I use a method called create data frame. It will create it. This is first method. Second method is that I have again the RDD. Okay, and I'll have lot of lines in the RDD. I will use my struct here. So we used struct type previously, that was for the JSON data. We directly read a JSON. On the RDD also, I can say I have an RDD with 10 lines. Okay, I will create struct. I will say I'll split it using comma. First column is integer type, second is string, third is something. Then I'll say create a data frame. So both ways you can do actually. First update is that each row I have to convert to a row object. And while creating this row object, I have to mention the data type. So I will say in the row object, first column is integer, second column is blah blah blah. Then I will say create a data frame. Here what I will do, I don't have to create row object here. I will create the struct type schema. Okay. So normally if you have simple RDDs, this is the way we do it, this row object. If you have nested structures and all, then struct type will be better because it can define so many columns internally. These two things we are going to do actually using this file we have, right? Schema inference example. Right? So here we are creating SC, right? So what we are doing is we are saying that read the people.txt into an RDD called lines. Lines is an RDD, it's not a data frame. Remember the sc.txt file, and you can actually look at the data also. I think the cluster is a bit slow today. Yeah. So when you do a top 3, it is showing you the top 3 elements of the RDD. We have Michael, Justin, Andy. You can also do a take 2. Okay, so it is working, right? So are you able to read it, the data? Read, right? And now look at what I am doing. I will first create an RDD called parts. And in parts, I will simply say lines.map. I will just say that take every line and split using comma. So how my data will look like? My data will look like this, because each line I am splitting Michael, then 29, Justin, then 19, whatever I have. So first I am just splitting my data using comma, okay, and then I will say dot map. I will say take every element and convert to a row object. This ROW is a row object, and then I am saying that the name should be of the column should be name, and this should be integer. Age should be integer. And if I do a top 2 now, your data is now converted into row object, right? So here you are converting it. You are saying that map the data, okay, take every entry from here, okay, convert that into a row object, okay, and the first part will become name, second part will become age, right? Name and age. So P0, P1 both will become. And then if I do a people.top2 or take 2, you can see there are 2 row objects now. This is one way of doing it, okay. And now this is useless to us now, because it's a row object. You can't do anything. Now you will say create a data frame from this. So we'll simply add it as a data frame, these 2 lines. So when you do a day_of.show, it comes like this only. Like it is probably alphabetical order, A and N, right? So, but you're just looking at the data, right? The operations may not matter. For example, if I say count the age or something, it is going to work only on the age column, but the display will be on this manner. That is one thing that is specific to this thing, Spark SQL. And you will say spark.create data frame people. So this is the method. Create data frame is the method that you will use if you want to create a data frame from an RDD. This is very important. Create data frame is the method which will take this people, this is people, right? People RDD, and then create this data frame. So the schema people is your data frame now. Can you do a schema people.show? It is not there in the slide. Do a schema people.show. What we did, we read a text file into an RDD. Now the question is that how do you convert your RDD to a data frame? One way is this. One way is that you split each row into different column, and then you say this is my schema, and you convert that into row object, right? So this is where you have the row object, right? This people is actually row object. See, row. Once you have the people thing, okay, you will say create data frame, pass this people. This is one way. Now if you have much more complex data type, then you can use the struct type. Struct type also, there is an example if you scroll down. So here you can see this thing came, and you can also register it as a temporary table and then run the SQL queries, right? So this part is fine. You can, I will ask you to run that later. Now programmatic schema example for complex nested schema, right? Here look at what I am doing. Again I am reading this people.txt. I will again say split it using comma, okay, and I will say that parts.map lambda. I will just extract the first column and second column. So I will run this first, okay. So if you look at the data is now like Michael 29, Andy 30, same data we have, but the only difference is you can also define the schema as a struct type. So I will say the schema is struct type, where I have a name column of string and an age column of string, and same thing you are doing. You are saying that spark.create data frame, you will pass the RDD, you will also pass the schema. So two ways. One way is that either you manually convert to row object and say create a data frame. Second way is that don't convert to row object, define your schema in struct type, say create data frame, give the RDD, give the schema, it will merge. How many of you are aware of this company called Yelp? You have heard about Zomato, right? All of you have heard of Zomato. Zomato actually came from Yelp. Yelp was the first company who started this food thing. You order food, and Swiggy, these kind of stuff actually got started with Yelp. Yelp is not in India. It is available only in US as of now. Probably that is the reason we may not know much about Yelp. Now, one good thing about Yelp, maybe it is good for you in future also, is that so Yelp has lot of data because lot of restaurants get registered with Yelp, and they use MongoDB to manage their orders and all. Okay, they allow you to download all their data for free. So you can actually, and every year there is something called a Yelp dataset challenge, where they will ask you to, so you can just go to Google and say download download Yelp dataset, and here you can see Yelp dataset download, right? Download Yelp dataset. So so the dataset has these many reviews. How many are there? 5 million, right? 5 million reviews, these many businesses, these many pictures from this. This total data set you can either get in JSON format or SQL compatible format. Now don't do that, okay, because this is like 8 GB or 10 GB size data. But if you are interested in doing some your own project or something, right, this is very good. Because the data is also good and you are getting some good huge data, right? You have that website, right, for all these machine learning folks where you get the data. What is its name? Kaggle. They have a copy of this, but I am not sure whether it is the full data. What I did, I downloaded a small part of this data, okay, and it is already available to you. Here if you go, there is a file called business.json. Can you see? If I open this, this is the file from Yelp. So you see, this is how the Yelp dataset will look like, and you can also use it for your projects and all, like I said. So every business has a business ID, right? And if I actually go to Yelp, where is Yelp? If you look at the business, right? So let's say you are searching for, I don't know, breakfast near San Francisco. Yeah, you get these businesses, right? And the point here is that if I open two businesses here, so this is first one, restaurant, you will have the name of the business, star, and then the location, the photos, and so many other things. If I scroll down, there is this more business info. In more business info, they will give you additional details. For example, takeout, yes, accept credit cards, something, right? If I go to another restaurant, see, these guys are saying accept Google Pay, accept Apple Pay, whether it is no or yes, but here that option is not there. So that means every restaurant data is totally different. You don't have a common schema or something, right? And this whole data is in that business.json file. Not the whole data, we have around 60 megabyte of the data. So you have a business ID, then you have something called full address, right? And if you look at here, this is nested JSON, right? See, I have a key called hours, okay? Within hours, I have Tuesday. Within Tuesday, I have close. So this is nesting, right? Pure nesting, right? And again, if I scroll down, see the level of information you have. It's like very big in terms of nesting, I'm saying, right? All these fields are there. So what we are going to do is, we'll probably use this, what you say, a shell rather than using the notebook, right? So I can just open the console, copy this, paste it here, and we are uploading this business.json in a common folder for you, okay? And I can say PySpark 2. I think I have already uploaded it here, so you can see business.json here. This is my personal folder. Yeah, so we are running 2.2.0, so that is a good version of Spark actually. Now in your datasets folder, there is also one more file called Yelp. Can you see a text file called Yelp? Just open this. And I will do this first because I want to overtake you. All of you will read, I know, then I will not be able to read, okay? The point I want to show you is that if I simply do a spark.read.json, okay, and giving this data set, Spark read it, okay, and you will get this warning, that's fine, okay. Now if I do a biz.print schema, right, print schema. Look at the schema. In less than a second, you got total structure to this data. How many columns are there? Look. So all it took is less than a second for you to read and create a data frame. Now it's up to you to write SQL queries. Everything is stored as a data frame. So once you read it here, now I have this biz, that is nothing but my data frame. But if I do a biz.show, it may not show me properly because so many columns are there, right? So I may not see this in a proper format. But what I can do, I can just register it as a temporary table. I can say create or replace temporary view, and let's say I want to understand how many restaurants are there total in my data set. Isn't that fast? It is really fast because you are looking at 61,000 records, right? Each has around 70 columns, not more than 70 columns, and the queries run really fast comparing it with something like Apache Hive, right? So can you try to do this along with me? You have to start your shell and like this. So PySpark2 you have to type, start the shell, and then you say biz equal to spark.read.json /gldata/business.json, and then you can follow the text file I have given to you. Now if I actually want to run some complex queries, not so complex, but if I run something like this, right? No, not so slow. I got the result. Yeah, I got it. 3 seconds. See, the query is not very easy also. Select state, comma, I am doing a round. Average review count as average review. From business, group by state, order by average, descending limit 5. So that's not a very easy query, but it gave me in 3 seconds. Yeah, depends on the cluster also because all of us are started one shell, right? So. And one more thing is that we started the PySpark in local mode now. We are not actually running in Yarn or something. So, but it's okay. The data set is like 50 MB. That will work ideally. So the commands I have written, I think you will easily understand. Here you are finding the total number of restaurants, and here what are you doing? You are grouping by state and understanding how many, you know. You are saying select state, comma, count 1 as business, group by state, order by business. State wise you are calculating. So once you register it as a temporary table, everything is equal then, right? So I am getting warning saying that slow read processor and read took some time, acknowledgement, downstream acknowledgement. So this is because it is reading. Also you guys will have one more problem maybe. Because you are all reading from the same file, right? It should ideally keep it in memory, okay? You are reading from the same file, right? Same location. And these things you can actually see. Connection refused. The file is actually on hard disk, but when you say spark.read.json, it will keep it in RAM, right? So all of you will get a copy in the RAM. Individual, definitely. Individual, yeah. So it should ideally work like that. And yeah, I got error. But I am getting error saying that fetch failed, shuffle failed to connect. So the machine stopped responding for me. That is because all of us are running. Are you getting the output or are you getting error? Output. Then why am I getting error? I got the answer. Sorry, it took some time, but I got the answer. Maybe slow, but you will definitely get some answer. So see how Spark is very efficient at handling nested data. Now I have an assignment for you on this data. I want you to write a SQL query, okay, where I want to know all the restaurants. So let's look at the data, right? This is the restaurant data, right? Give me the output in a SQL query where I want to find out all the restaurants where where all the restaurants which will what you say close at 9 o'clock on Wednesday. Let's see whether we can do it. I want to find out all the restaurants. So you have opening closing hours, right? Tuesday, Wednesday, all the restaurants which will close at 9 o'clock on Wednesday. It's a select query, right? It's a select query, right? You're doing a select. Select star from where? So I want to show you how to access that field. So first you do a print schema. You see the schema and see where you can access it. If you do a biz.print schema, it will show you where you can access it. And what happens is that even though Yelp and all will be using this MongoDB, for analysis they may not prefer MongoDB. MongoDB is good at providing real-time information. Say you search a restaurant, it will show. That's fine. But if they want to find out like last 10 years which restaurant made much money, they will read it into something like Spark. Then write your analysis. So MongoDB is not an analytical DB. It is just real-time performance. Like you are booking an Ola. So what Ola is doing, they are also on MongoDB. That means if a million customer book also, cab they can see. They can get the cab, but they can't do any analytics on that. Analytics somebody else will run. This is like so many customers come, they should get served. That is the purpose of MongoDB actually, right? So what did I ask? Even I don't remember. So how do you access that column? That is my question. Select star from the table, right? Where select star from the table where hours dot Wednesday dot what close equal to what? Whatever I said. Try dot show. I mean, because this hours column is a struct, it is a structure. So within that you have Friday, within that you have close, that is a string. So you want to access, you have to say dot 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 starting from hours. So you have to say spark dot SQL within quotes, select whatever where dot 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 equal to the condition I gave. Oh, you could have done a limit. Do with a limit, okay? Don't run directly. Do with a limit, my bad. So it will be something like this, right? Spark dot SQL select star from base where help me with the query. What is that? Hours dot dot So just understand how to access nested structures, okay? Because that might be required. How to get nesting, dot 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 you have to go.
Could we do that using data frames in Kites?
Yeah, you can do very much. You can do the same thing, not like this, it will be different. I'll show you.
Query will be different.
Query will not be like this because this is SQL queries, right?
But you said that
Here, right? So one way is that you can so both will be actually equal, but the execution time will be different, I believe. So actually when you try a show of 5, what it will do outside, if you do a show of 5, so use the business.json for some case studies. And I have one more assignment, don't do it right now, okay? But that assignment will be, if I scroll here, right? Where is your schema? Biz.print schema, right? I have another assignment, okay, where don't do it right now, but I want to select so So don't do it right now, but just think about it. Okay, I want to write a SQL query again where I want to find out all the restaurants that takes reservation. Okay, what is the challenge in writing it? There is a space. There is a space. If you directly type, it will not work. No quotes. Takes reservation, right? So there are two things. Just see what you can do, or try first. If it works without anything, then that's good, right? I don't think it will work, right? It will not work. No, you can't. It won't identify. Like if it is a column like takeout, it is one word, right? No, you have to tell the system that there is a space. By default, it will not take. So in SQL, what you do? That's my question. Normal RDBMS, what you do? Backslash character, escape character, right? So here there is an escape character. Find out what it is. Not now. Find out what is this. Without escape character, you cannot type because it will not understand whether there is a space or not. Okay. Find out what is escape character and tell me. Okay. Not now. You can take time. So this case study is very interesting. You can find lot of things inside this, right? So now what I want you to do is, we will look at the analysis later. But what I'm trying to do is that there are certain type of files called Parquet. Some of you might be knowing it. Parquet is compression, and Hive is excellent at storing Parquet files. So sometimes when you get data from Hive, and it will be Parquet data, right? So how do you read Parquet into Spark? One question. Second question, how can I run queries without using SQL? Like right now what we did is SQL queries. I don't want to use SQL. I want to use Python. Just query the data. So this folder will be shared with you right now, names.parquet. If I open this, what is inside this? This is how the Parquet files will look like. This is the file actually, this is the metadata of the file, okay? And if you try to open the file, one of the file, it will throw error. It should throw error ideally. Come on, at least throw an error. For that it is taking this much time. Okay. Yeah, you can't read, by the way, that's what I meant. It won't display the content or anything. So Parquet files by default you cannot open in Notepad or anything. You have to use some system to read it, and that's what we are going to do. So I will just check whether I can read the data first. Okay. My data is actually in a folder called Raghu. Okay. Here you have a folder called names.parquet, right? And I open this Python script. Okay. Again you have to use the shell. So we already have the shell, right? And how do you read Parquet file? Very simple. You will say spark.read.parquet. It will come. It's warning. Everybody is trying to read, right? I think it read. df.show. Yeah. So sometimes another problem is that Parquet files inherently has lot of problems. You will get a lot of warnings and errors when you try to access the metadata. So when I read also I got it. So this is the data that we have. You have first name, gender, total, year, right? So what is this data? These are the names of babies born in a year and how many were born. Like there were 54,336 Jennifers in 1983 born, like US state data it is. Can you read? Try. So you have to give this location. How? You have to say the folder where the data is there. How many of you can read Parquet? You can read, right? So that means the command is working. Can you also do a df.count? It is there in the Python file to see how many rows are there. df.count 18 lakh, right? So df.count should give you what? 18 lakhs. Good. but I have to wait. So 1.8 million records we have. It came here, I didn't see. Huh? Do you think there will be a difference if they open a Jupyter? I don't think so, right? So around 18 lakhs records are there. You can see here, right? So I did a df dot count. You can also do a df dot print schema. Control Z. And you can see there is a first name, gender, total, year. So these are the different columns we have, right? So these are the columns we have in the data actually. And what is that we want to do? So if you want to select, let's say, specific columns, you can do a df.select. There is a select command, very much like your RDBMS. You can simply say df.select first name, year, and then if you do a first names df.show, you should see only the two columns you selected, right? So select command is very common, like what you do in SQL. You can say I want only these rows, right? You can also count it, okay? You can also say I want to count distinct. So the names will be repeating every year, right? So I can say I want to do a distinct count. So let it show the output. df dot select distinct count. Like these names will be repeating, right? Every year there will be somebody with Mary. So I can say distinct, how many names are there? 93,889. Anyway, let me do one thing. I will just show you a couple of things related to the Python analysis. Okay, you can also run it. For those who are having access, can run it with me, no problem. I think some of the people's shell is down. Okay, but don't worry, the same commands will work. You have access to the cluster anyway, right? So what I did just now is that I just did this, right? Now if you want to find out something like this, view word wrap. Let's say you want to find something like this, original data frame to find the 5 most popular names of girls born in 1980. You want to find out the top 5 female names in 1980. The query looks pretty much like a SQL query. So if I copy this, see, all you're doing is that you are saying that filter, and from the data frame year equal to 1980, gender equal to female, order by total in descending, and then you want first name, select first name, limit 5. So if I run this query and if I do a popular dot show, it should ideally show me the popular names, right? So look at the query. So if you look at the query, do you find it is very similar to your SQL query? Very, very similar, right? Because you have a filter clause, you are an order by. The only thing is that every time you are using this df, that is the name of your data frame that you have created. You can also use the dollar projection. SQL, you have a dollar interpolator, right? I think I wrote it here somewhere. You can also say like this. No, it's not there. I wrote it somewhere. It is not here. Instead of saying everywhere df, you can say dollar, and as this column, you can say projected. So running filter queries or order by queries, ordering them in the descending order, everything is easy. It's like a Python code. Here also you can do same thing. I wrote it somewhere. I don't have it here. You can try it yourself. Scala, the difference will be this will be 3 equal. This equal to operator, right? So this is not assignment. Assignment is single equal. This is what comparison operator. If you are writing the same query in Scala, you will need 3 equal symbols for comparison. That is a major difference. Apart from that, the query will be very similar. No difference at all. Right? Now let's try to do something interesting. Okay, so how popular were the top 10 female names of 2010 back in 1930? So let's say you want to understand this. You want to find out the top 10 female names of 1930 and then 2010, and then you just want to compare them, how popular. Now obviously if I want to do this, the first step will be I have to filter the data of all the female names of 2010, then female names of 1930, and then I'll do a join, and then I say whether it is good or bad, right? Now you can also write your own UDF functions in Spark SQL, user defined functions, right? To do that, you just have to import this UDF. So I'm just saying that from PySpark SQL functions import UDF. UDF or user defined functions will allow you to write your own functions in Spark rather than using Spark's functionality, right? And why did I import this? Because I'm just creating a simple function called lower. Here you can see. So lower is a function. What it will do, it will take any name, whatever you give, and just do a s.lower. It will convert to lower letters, right? Just to show you that it is possible. And once you have this, what you can do is that I am creating a data frame called 2010. So I am saying that I want to filter where year is 2010 and total, as there is a column called total 2010. Gender, I'll call it as gender 2010, first name as first name 2010, and I will pass this function lower. I will convert the first name to lowercase, and I will call this column as name 2010. So you see, you are using aliasing here. You are creating a new data frame, but you say alias, alias, alias. Every column name you are renaming it. Only difference, you are calling this lower UDF function and filtering it with the year 2010. So this will create a data frame called SSN 2010, where you have all the names, right, of people, and we will also create one more for 1930. So here I am saying that again same stuff, the year is only different, 1930. And once you have both these data frames, look at the join query. The join query also looks pretty same. So in the join, what I have written, I said filter. So this filter could have been written before, but I wrote it here. Okay, filter where the gender equal to female, and I want to join. This was 1930, where also the filter is again female, and I want to match the name thing. Okay, order by total, limit 10, top 10 female names. And if I actually want to run the query, I have to do a show. I have to do a join.show, and that is, so again it is lazy evaluation, right? If you write a join query, it will not run the join query. You have to say dot show to fire the execution, and it will do the join. But we are operating at around 18 lakhs of data, right? We're actually, we filtered it, but the amount of rows we have is around 18 lakhs, but still it is able to process the Parquet data. We'll see how popular it is. I think here it is taking a bit of time anyway. So join query you are writing like this. So this filter is actually not required. You can filter above. I wrote it here. Already when you're creating your data frame, you could have filtered. So in join, what you're saying that this is first data set, SSN 2010, or first data frame. Second data frame is 1930. Okay, and this is the column. From here the column is name 2010. From here the column is name 1930. This is your common column. So when you are doing a join, you say using this column, right? Common, you say a dot, b dot, then you give the column. So this is the column condition. So this name column, same name, right? Because you want to understand how the name distribution is there, right? And then what you do an order by total in the descending order, so that the top names will come. You join by name, then you say order by descending, the total count, so that if Mary is the most popular name, it will come at the top actually. And you say limit 10 because you want only top 10, and then you are just aliasing. You want to project the column, right, whichever you want. So you say first name as name, then total. So it should show here, yeah. So these are the aliases we have, and this is the column we projected. So it seems Isabella, there are 22,000 people here, there are only 142 here, right? So I think Elizabeth is a very common name among, even in 2010 and 1930. Both places you have almost similar, right? Apart from that, all other names are like very less here. And here you have n number of people with the same name, right? So join queries and all look very similar to your SQL, okay? But maybe if you are more comfortable in SQL, you want to write it in SQL. Like usually if I give you this data, I don't think you will write it like this. I think you will create a table and then you will say join. That's easy for you. But my point is that you can actually write it like this also if you want. If you want to practice this, what we did, first we read the data, right? This is Parquet, how you are reading it. If you want, you can cache the data, that is optional, right? Then what we did, we selected only the first name and year, right? This you remember. And then we did a count. We understood total how many records are there. And this was the query where what? We were trying to find the 5 most popular names for girls born in 1980. So it's a simple query. And then what I did, we wanted to try joins, okay? So we created a UDF first for converting to lower case, okay? And then I found out all the people who are born in year 2010, all the people who were born in 1930, and here is my join query, right? So like I said, these parts are over. You have reading from RDD, reading from this, and if you want to read from CSV, there are 2 ways. One is that you can say spark.read.csv, give the CSV file like JSON, it will read. But previously we did not have that option. It came now, okay. When I started writing like code long back, we had to use a third-party package from Databricks. So Databricks has a package which will help you to read. So you have to download that package, add it, then only you will be able to read. But this time you can directly say spark.read.csv, it is going to read. All right. So now what we want to do, why don't we try XML? I'll write done. Okay. So the problem is if you want to read an XML file, by default you cannot say spark.read.xml. So far it is not available. So if you just Google, just go to Google and if you search for Databricks Spark XML, okay, this company called Databricks, who is the inventors of Spark, they have created a Spark XML data source. Okay, so what is this? It's a package actually. So you can download this package, and using this package you can read XML file. Okay, and the question is, how do you download this package, right? So while starting the Spark shell, you can ask Spark to download this package. So I have an XML file. If you go to the folder here, there is an XML file called, where is it is? Can you see some XML file? Where? Employees.xml. This one is an XML file. If I open this, see, it's pure XML, right? So it has, this is called a root tag, employees, this one, and this is called a row tag, right? Employee. So this is how this, and within that you have employee number, name, then address, city, country, blah blah blah. Now first step that you need to do is upload this file in the datasets folder in Hadoop. And if you again go back to the folder, there is a file called reading JSON and XML modified. If you open this, it is clearly written to read XML files, you need to restart your Spark shell with the below command. Now modify this, you say Spark shell -- master local, right? Local, and then you are saying packages com Databricks Spark XML package. This means you are starting your Spark shell and asking, sorry, it should be PySpark. right? It's not Spark shell. By mistake I have written. Yeah. Say PySpark 2. Okay. I was writing the other one. So simply say PySpark 2 master local, and you can see it is downloading. Can you see? Resolving dependencies, resolution report, this module it found, right? It will download this XML module. You can clearly see. So now your Spark shell is running, but it also added that XML module, right? So this is the command. There is a mistake in the notepad. If you want, you can edit it. Okay. This is the command. Look at my screen. This is the exact command you have to type. So one way is that you can download in the shell. Now if you are writing a code or something, you can add it in the code, like the package name. While running the code, it will download it actually for you. You can also get a jar of this package, okay, locally if you want to add it. Like every time, otherwise you have to download it, right? So it is available as a jar file. You can add it, but this is the best way to try. Are you able to start the shells? Yeah, right, in the local mode. Great. So it says started. Now if you want to read it, this is the command. It's very simple. So how do you read it? You will say spark.read.format. There is a method called read.format, and you have to mention what package you are using to read. Option infer schema true, which means you want to automatically understand the schema. Root tag is employee, row tag is employee, and dot load give the location. And now if I do a, that's enough. So depending on the structure of your like this has a specific root tag and row tag, so you have to mention what is what. If you want more information, here it will be given, right? So it says these are the features you can add. Path is the location. Then a row tag, you have to give row tag. And if you want, there is something called sampling ratio. We don't want to use it. Whether you want to exclude any attributes, right? Whether you want to treat empty values as null, right? And all these things, column number of corrupted record, value tag, character set. So anything that you want, it is here. So now we used a very simple file, but you can see that it perfectly created a data frame from an XML file. So you have a data frame now. I can start querying the data. Try this by yourself. Now, don't trust everything that I teach. I mean, this is how you read XML, but not every XML you can read like this. You know that, right? If there is a proper structure, you can read. Some XML files will be much more complicated than this. So there you have to manually do something to give a structure, and then only you can. Because we had a use case where we were getting this VXML, you know, voice XML. Like if you place a phone call, you call the customer care, right? So if you're calling the customer care, you will say press 1, press 2. So these call centers, they will record it, like how much you called and all these things. That will come in a voice XML format. It will come from the IP telephony. So these IP telephones, they will push it as a structure called voice XML, VXML. You can't read it in this. It won't, it will know, I don't know what it. Then you will read it. So we actually did that, okay. But if you give this package, it will say, I don't know what you're talking about. It has a structure and all, but not every XML you can read like this. So a lot of applications are there which store or give you the data in the JSON format, that API, if you connect, right? But there is no rule like you should use only JSON or XML. It depends on the application. So today most of the JavaScripts, everything is built on JSON. But XML is also there. Like I said, we had VXML, so voice XML. So some systems produce them. So you are just a consumer. Normally when we are doing big data analytics, we are just consumers. We just get the data. So we cannot say that give me only JSON. If the application is generating XML. Now I told you, I think there is one more format called Avro. Oh, forgot, sorry. You can also read from Avro. No. Avro is normal text data with metadata. I will show you Avro tomorrow. If you open it in a normal text file, it may not make sense. You will see the data, There'll be a header kind of thing where you have metadata, okay, then the original data. I'll show you Avro tomorrow file. If I have an Avro file, I can simply say there is a package for reading Avro, again Databricks. You say start with the package, it will read. Now in one of our project, what use case we had this train engines, again GE, because my major client is GE. So they have this train engine, locomotive engine, right? This train engine will produce sensor data, and that sensor data they send to some cloud, some place. From there it will land on your Kafka, okay? But that will come in Avro format, because there was a name, it is called not incident, I am thinking incident, not incident, what you call in my mind it is coming as incident, not incident. There is a particular name, because every 2 seconds or 3 seconds one file will land in that folder. So the sensor data is continuously streamed, and every 1 second or 2 seconds it will land as a .avro file in a folder in Kafka, actually Kafka topic. Then you have to read from Kafka to Spark. But even with using this Avro Databricks package, we were not able to read Avro file. So they wrote a normal Java program where they will read the Avro, convert and apply whatever schema they have, and give like a proper tabular format to Spark. Spark will process it. So most of the organizations will have a data ingestion team. They will handle, because not even though I am saying that you can read JSON, you can read this, if you actually go to production, you will have a number of other problems. So not everything will happen automatically like this. So you will have a data ingestion team. They will take the Avro and they will convert it into some structure and say that, hey, Spark, take it, right? So not everything will work exactly like it is written. I am just saying event, not incident. So there is, it's called events. Every 2 seconds an event will happen. Whenever there is an event, a file will appear in this Kafka topic, okay, and we were continuously reading it. So Avro files will have a .avro extension, like abc.avro, it will be written. Tomorrow we will be downloading data from Twitter using Flume, and that data will come as Avro. So you can actually see what is Avro, you don't have to worry. So we will see Avro tomorrow. So normally when you use Flume to get the data from Twitter, there are two options. One format you can use JSON, second format is Avro. So we are using Avro in the exercise. So you will see the tweets actually coming as Avro format, okay. The next thing I want to try is reading from RDBMS. Here if I do show databases, don't worry, I'll give you this link, okay. I'll say use retail DB, and if I do show tables, see there is a database called a retail DB which I created. Within that these tables are there, and there is a table called orders, right? I think that's what we are reading, order items, right? There is something called order items, right? So if I do a select star from order items, oh, could have done a limit, but I think it should work. Did you all connect? Yes, right? Maybe that is what it is. So yeah, we got it. So there is around 1,72,198 rows in this table, right? So it's a pretty big table, not so big and all, but some data we have at least. Now what if you want to read this into Spark, this table? We can do that. Now if you want to do that, first thing you need is the MySQL driver, JDBC driver. So can you check, the driver is here in this folder. Can you see this? MySQL connector, Java, something, this file. And I want you to upload this using FTP to your Linux machine. Let me show you. Upload the driver using FTP. See, I have uploaded here. Can you see this? 515. I am just checking. not this one. I think the name is different. MySQL connector it will be. Here. Yeah, this one. Not this one. This is the binaries actually. So this jar file I want you to upload in your home folder. Using FTP. Because what we will do, we will start Spark shell and give this jar file to Spark. So Spark will start with this, and within Spark we will write our connection string, say that connect to the RDBMS, give me the table, it will read it. It should ideally read. We'll see whether it will actually read or not. So we will start Spark shell. So normally you will say PySpark. Now you will say PySpark, use this jar. This is a driver. So Spark will start, and within Spark we will write our connection string for connecting to the DB. What is the username, what is the password, what is the connection string, and it will read the table and create a data frame. It should be able to do it. Scoop is like data transfer utility. So here also you are doing data transfer, but you are not storing anything. You are just bringing the table to Spark as a data frame, so that you can write SQL queries on top of that. And typically what we do is that, so this is very rare use case, you are actually reading from RDBMS. So in MySQL you can do that grant privileges for the user. So you have to say full grant privileges for this Spark user, otherwise it will complain. So if the username, now the username is what, lab user something. So lab user should have full grant privileges, then only it will not work. That's one more problem. So I have not actually used it much because the use case is very less, but in one of our customers case they had Oracle. So we wanted to read and it didn't work because that has n number of other problems. Driver and all you will get, but it will not read at all. So then he did something and permission issues and all. Finally we were able to read the data because his requirement is like he had data in Oracle, okay, and that was some terabytes of data, and already he had a lot of data in a data warehouse that he brought into Spark. This Oracle data he will not allow to touch. You have only read, you can't transfer it actually. So when he was running join queries, he wanted this data to be available. So initially we did like this. Later he used some sort of a caching layer on top of Oracle where it will be already cached. Spark will read it from there and then process it. So this method is not so efficient if you have huge amount of data actually. We did it only once. So once you have the driver, okay, I didn't tell you what we need to do, right? So you have to start the Spark shell like this. Do you have this file called reading XML, JSON XML modified? Yeah. So here you have to say PySpark2, then you say -- master local, add this line, okay, and you will say driver class path and the jar, meaning you are just saying that use this particular jar. So you are saying that start Spark shell, and this is the class path, driver class path, and this is the connector that we have, okay, and it starts. And if you want to read, let me first try, because all this is so this is jar you are giving here. The location is same. Here it is something called driver class path. Both you have to give. So the arguments are different. Let me see if I can read, okay. So how do you read is you say spark.read, there is a method, and then you say format is JDBC, this is very important, okay, and URL is this, that is the connection string. Then there is something called DB table where you have to mention the DB dot table you want to read, username, password dot load. Now ideally if I do a JDBC df dot show, we have the data. So this is coming from MySQL, right? This is coming from MySQL. So you read from MySQL directly to Spark. See how easy it is. My whole point is, rather than the functionality, things are very easy. If I have to do this in some other programming language, I could have sit and write. Imagine Java. Java can do it easily, but I am saying the functionality is very easy, right? Anybody can read and understand, okay, what is happening. You don't have to explain at all. So we are actually passing two arguments here. One is the jar and one is the driver class path. Okay. So ideally the jar is enough if you are running in the local mode. I added it just for the safety. In the yarn mode it will throw error sometimes saying that I can't find your class path. So the entire table is in a data frame. This is a data frame. Right? I can say any queries I want in Spark. Try this by yourself. Don't trust me unless you can run by yourself. And if you are working in Spark 1, this is different, completely different. You don't have this format JDBC and all. They're very similar, but the commands will be slightly different. There we say you will create a Java object first for system utility object. There will say put. Username is this, password is this, URL is this, then call that object. That's how you read. So in Spark 2 only they introduced this method. So and I don't know if you start working, maybe you start working on a Spark 1 cluster, right? And you may not see this. So we are running Spark 2.2 version. So here is 2.2. And if I go to Spark SQL, can you see the menu? Reading RDBMS, somewhere it will be there. JDBC to other databases? No. So DB table, the JDBC table that should be read. Not that anything that is valid from clause of a SQL query can be used. For example, full table, subquery. I think it has to be a table. That's what I think, DB table, right? And of course, I showed you only the basic option. URL is there, DB table is there, driver is there. There are a lot of other things you can have. You can have a partition column, okay? You can have a fetch size, the JDBC fetch size, which determines how many rows to fetch per round trip. These are all performance considerations. You can say truncate and a lot of other things, right? So we will look at them. Now last but not least, since a lot of you were asking about installing Spark, right? I thought I will show this. So maybe something which you can do, right? Some of you have already done this. You can just visit Databricks website and there is an option called a try Databricks, a button, okay? Just click here, try Databricks. Databricks gives you a free trial of their platform. This is for 14 days only. So don't do this. If you are signing up for this, you have to use your credit card and all. There is a community edition here. Okay. So community edition, you can just say get started. Give your username, password, no credit card required. And once you sign up, because I have already saved that account in my laptop. Okay, this is the one. So once you create your account, you should be able to log in like this. Yeah. So once you sign up, okay. You will be able to do like this. You will get this page, okay. And the important feature is that you can just go to this clusters. There is a menu called clusters, and you can simply click on create a cluster. So click on create a cluster, give some name, and it supports up to 231 Spark. There is a major version 4.2, that is Databricks version. Don't worry, Spark version is 231. So let's say you want 2.2.0, you can say something like this, 2.2.0. And Python version, do you want 2 or 3? Okay, whichever you want, you can select. And this, don't make any changes, say create a cluster. And now the cluster is getting created. So this will give you a single machine on AWS with 6 GB RAM. And it is totally free, right? So, and it is very fast also. I mean, the cluster creation and all, ideally it will not take much time. You can see the Spark UI from here. If you are running something on this cluster, you can stop it and delete it, the cluster. So I was running some clusters previously, and you can see it is here. So you have this cluster menu like here. Yeah, so now the cluster is running. I'll just get back to you, okay? The cluster is running and you can go to the Spark UI, and this is the Spark UI. As of now, there is nothing in Spark, right? Now the question is that how do you work with the cluster? So first thing you can do is that you can upload your data. So just go to this data part here, and here you can simply say create a table. So they store everything in a table format, and let's say we want this JSON file, right? Where is it? people.json. Just drag and drop it here. So, and this will be the location. Just copy this location. This is where that will be. And if you want to work, go to this home page and you can create a notebook, new notebook. Name is something, language is Python, Scala or R. We will choose Python. Cluster is the cluster running, create. And df equal to spark.read.json, this JSON file. We have the data, right? So this is good for practice. It's absolutely free, first of all, right? But the point is, if you create this cluster and you don't touch the cluster for 120 minutes, they will delete it, right? So otherwise they should also get something, right? If you are not using it, they will delete it. But I think that's not a big deal, because let them delete the cluster, your code and all will be saved. If you create a notebook like this, it will be persistent. Data you can have in your laptop or something. Whenever you want to upload and you say run it, right? I feel it is good. You can use it in your whole exploration. So a lot of people wanted to install Spark and mess with Spark, right? So this is your answer, one thing. And a good amount of documentation is there. Please read through the documentation, right? So there is read documentation, and you can just go through their documentation. What are we trying to do here, right? That's what I want to explain. So normally when you install a Spark cluster, okay, there is an option for that to integrate with Hive. Hive and Spark are different things actually. They don't talk to each other. But what we do is that when we install Spark, okay, we tell Spark that there is Hive. And if you remember Hive class, Hive has something called a metastore, where it remembers all the tables you create and all. So basically you are telling Spark, hey Spark, there is Hive somewhere, go and talk to it, okay? And that support, two ways it is available. If you are starting the shell, like you say PySpark 2, by default it can talk. If you start a PySpark 2 shell, because everything will be configured, you can simply say read the table, it will read. You don't have to do any configuration. But let's say you are creating your own application in a text file or something. There you have to write these statements. That's why these statements are important. If you go here, in your Hive copy, you will create the Spark session. You will say this is the name of my session, and some configuration you can pass. You have to say enable Hive support, get or create. This you have to do if you are writing your own source code. Like you are writing your analysis, you want to read some table from Hive. So you have to compile and then run it, right? I mean, not from the shell. Let's say you are writing like a Python script, right? So there, remember, you can create your own SC Spark context. Same way, you have to create your own Spark session, and by creating, you will say enable Hive support, get or create. This means now this using the Spark session, you can talk to Hive. So from the notebook and also from the PySpark 2 shell, you will be able to access. But I am saying you are writing your own source code. Let's say you write the source code here, submit to some cluster. In that cluster, you will say run this program, right? So there you have to create your own Spark object. So right now, ideally, if I run this cell, okay, it should tell me that Hive support is there. So let's run this. I will run this. So with Hive support, we have done that. You don't have to run this Spark again. That should throw an error sometimes. Let's see. Yeah, it says already the Spark object is running, because in my notebook it was already running. How do you delete this error? Clear, right? And then what you do is that if you want to create a table, this is how you do it. So you will say spark.sql create table if not exist, some table name, okay, key comma value. So this create table command is what? It's a Hive command. Create table command is Hive command. You are saying spark.sql. So from Spark, you are telling that create a table in Hive. Now there is one catch here, the table name, right? So this table name, it will go to your default DB in Hive, and you cannot use the same table name. So if you have a DB, better you say db.table. Otherwise, if all of you type the same thing, it will throw an error, right? Saying that the table already exists. Are you getting my point? So in Hive, if you have a database, you can give the database name, or you can simply give some other name. So I said create table if not exist, source 100, okay, and then key value, that is my schema. And then if you want to load the data, simply say load data in path. In my case, the key value should be here. I'll just copy that file. So in your case, it is in /gl data. Can you see this this? Now do one more thing. There is one more point. If you load a file into Hive, Hive will cut this file from here, right? Do you remember that point when we discussed Hive? If I load this file, Hive will delete it from here. So the first guy who loads will get it. Rest everyone will get an exception. So ideally copy this to your home folder. Use in Hadoop, so that everybody will have a copy, right? Otherwise, if somebody load this data, then the data will be copied to warehouse folder. You will not get it again. So copy this to your home folder wherever you are. So here you see, I can simply say I want to copy this. I'll say action, copy. Where do you want to copy? I will say, what is my username? User. You're not able to see the file? Also, one more point is give the different table name. Don't give the same table name. Okay? All of you should give a different table name. I don't know how to make that happen. Probably give. Oh, then you can say db dot. If you have a db, you can say db dot. Add it. I have not added. I just say table, right? So I say create a table called src100. Instead of that, you have to say create a table something dot src100, your DB name. Okay. And you should be able to see the data as a data frame. So once you do this, okay, you can start running queries, right? And they will be what? So you basically created a Hive table, loaded the data, now querying using Spark. See, here we created a table. This is in Hive. We loaded the data. That is also Hive. Now, if I want to query the data, I should open Hive shell. Here, if I query, it's a data frame. I am saying select star from dot show. It will read from Hive and show you in Spark. So you will see data frames only here, just to show that you can read from Hive. So like that, any Hive table you can do. So now I am saying select star from this, right? If you have a different table in Hive, try that. Do a select star from some db dot some table. We create a transaction table. Any table you have, it will show here as a data frame. So directly, easily you can read from Hive. You can also write. So during Spark installation, Spark will not know that there is Hive. And the interesting point is, if you install Spark in a Hadoop cluster and you are telling Spark there is no Hive, I don't know what is Hive, you start Spark SQL, it will create a metastore separately. Spark SQL requires metastore, right? If you are not telling there is Hive, it will create a Derby based metastore. Derby is the DB. Okay, it starts storing all the tables and all. But then your problem is you have one Hive metastore and a Spark metastore. That is bad, right? So ideally what people do, Hive configurations are in a file called Hive site XML. They will copy that file and there is a Spark conf directory. There they will paste it here. So if you put it inside that, Spark will know that, okay, this is the Hive configuration, this is the metastore URI. If you create a table, it will by default talk to Hive only. If you directly download Hive, not like in a cluster, let's say your laptop, if you download Hive, you say start create table, what Hive will do, Hive comes with a small DB called Derby, RDBMS. It will dump all the metadata there. But it is not very, so to say, professional, like Derby is not very efficient database. So Spark SQL can independently work, but then the problem is that you can't communicate between them. Ideally, you should be able to. You should be able to read from Hive, right? So that is, this configuration need to be done. Then only it can talk. So another point I want you to try is, if you run any query, right? I said spark.sql select star from this, and I can see a data frame. And this query can be any Hive table. You have Hive, right? And you created some tables. Try this query, simply say spark.sql and any query that you want .show, it should run on a Hive table. And see the result here. So you are practically accessing Hive tables from Spark, and it will come as a data frame. Everything is a data frame. Even this is a data frame. So Hive configuration is in a file called Hive site XML. That file contains all the Hive configuration. A copy of that file need to be placed in Spark configuration directory. I think I should be able to show you. We have a command line access, right? I don't know whether this will work. Where will be it? cd slash no. Yeah. So guys, just a quick thing. If you install Hive, right, the configuration in Cloudera will be on etc hive this folder. Here you will have a file called Hive site XML. This is the file. This file contains all the Hive settings. So this file should be copied into Spark configuration folder. Then only Spark will know that. Otherwise, if you simply say select star, how does it know where is the table? You are simply saying select star from some table from Spark SQL. So it read this file and then get the information actually. Here you have the Metastore URI and all. How do you search slash, right? See, Hive Metastore URI. This is where Hive is running. This is the where Hive is storing all the metadata. Hive Metastore URI. This Spark will know. Thrift is a, how do I say, Apache project where it is an interface. It allows you to talk using any language. Let's say you have a Python program, you wrote a Ruby program, and you want to connect with Hive. So again, you have to use a JDBC connector and all, but it will hit this Thrift server that can handle any language connections actually. So different languages you will be using, right? Java, Ruby, or something. So in any language, if you write your program, if you want to talk to Hive, Thrift will be the server that will be handling. Thrift is a protocol actually, Apache Thrift. There is a conf folder. I don't know where it is in this cluster. Should be somewhere here only. Let me just check. etc. No, they have not copied it here. They have copied it somewhere. There is a conf folder. One place is here, or I think it is not available to us. So usually it is in the conf folder. If you copy it in the conf folder, it should work. Or they could have copied in some common environment variables path, loaded it as a property, probably. So if you just copy to this conf folder also, it will work normally in any cluster. We used to do like that. Thrift is a multi-language protocol. So it is used to handle connections that is coming from any language. It has multi-language support. So if you are writing Python, in Python you will say, if you want to communicate with Hive, this is my Hive server URL, this is my username, this is my password, and that request should hit the Thrift server. Thrift is a server who is handling all these connections actually from wherever you are connecting to Hive, right? And Thrift servers are very common, like in Hadoop ecosystem, a lot of places you have this thing called a Thrift server. So this proves you can read and write, will show write also, you can read from Hive. Now you can continue with this, but I want you to start this shell. Can you start this web connection? Yeah, and simply start PySpark 2, because I want to show you how it is in the shell also. Oh, don't do it, PySpark 2 local, master local. I forgot. Because if all of us start the shell, it will give error, right? So say PySpark 2 -- master local. Even I will exit, because otherwise it will show a lot of errors. You say PySpark 2 -- master local, and I want you to find a CSV file, some CSV file, any CSV file will do. and upload it in the datasets folder. I don't have a CSV file. Yeah, I have a CSV file here. Can you see? So this is just a simple CSV file. Can you find any CSV file, .csv extension, and then upload it in Hadoop? Any Hadoop folder. I am using a file called train.csv. It need not be the same file. Then I have to, so shall I copy this? It was not available in this folder, right? Here, do you see that file? Train.csv? It's available. Oh, then good. It's available in GL data, it seems. So slash GL data, okay, sorry, slash GL oh, it is searching here. In JL data, you have the same file. Where is it? Yeah. So copy this to your home folder. Don't use the same file. Just say actions. Copy this to your home location. I have it in a dataset folder. So here is the datasets folder. I have it here, train.csv. I just want to show you, you can simply say df dot equal to spark dot read dot csv. You can say see how to read a CSV file. You say spark.read.csv, it will read a CSV file. You can actually write it into Hive. So this is a data frame now. I want to write it as a table. I want to write it in Hive. So I think I have a DB called June. I have a DB called June 28 in Hive. And simply say df dot write dot save as table. I think the syntax I have to just look at it. Yeah, so you can say June 28 dot and that's it. It's saved as a table. So this is one of the shell I'm saying because everything is configured. You simply say write dot save as table, DB name, table name. It will create a table and push it into Hive. No, it was not there. And there is something called a save mode. In Spark SQL documentation, you can see that. Save mode will allow you to define how to save the data. So, three options are there. One is called append, which means if the table is there, it will append. Or there is rewrite, overwrite, or skip. If the table already exists, it will just skip the data. So, for that, you have to import a library called save mode. You have to simply say import from spark.sql.save mode, and then you can mention the save modes that you want. They're in the documentation, Spark SQL documentation. Second interesting thing, while saving, you can also mention in Hive what format it needs to save, ORC, Parquet. You can say format ORC, format Parquet. So this is like text now. It won't compress or do anything, right? And quite interestingly, you can also do one more thing. This data frame is there, right? I think I wrote it somewhere in the notepad. Here it is. Do you see what happened? I have a data frame. I said df.write.json. This will be stored as a JSON file in a folder called Raghuram in Hadoop. Conversion, file conversion. It was a CSV. I just read it in Spark, say store as a JSON. There is df.write.json, write.parquet. So you can easily do conversion from one file format to another format. Now, if you can try yourself, and if you go to this folder, JSON file will be there. It's a folder. Should be a folder. Folder will be created. So now I said Raghuram. I'll show you. So now I said Raghuram. So if I go here, it should have created a folder called Raghuram somewhere. Here is Raghuram. Inside that, what you have? JSON file, right? If I open this, right? But I am not sure whether you have a way to save the file with a name, like it gives some weird name. Maybe you can say the file name also. That I have not tried so far. So you are reading a CSV file into a data frame, and from there you say save as a JSON. You can also say df.write.parquet. It will save as Parquet. So these methods are available. Just explore how to read and write into a data frame, right? Wasting much time, let's move to scoop, right? So let's eat a scoop of ice cream, right? Scoop. It is not SC, okay? So many people write scoop, not scoop, scoop, right? Different, right? The ice cream scoop spelling is C, right? Not this, I think. So anyway, this is this scoop, right? So what is scoop, right? So we are done with Spark SQL. Now there is an assignment with solution. I mean, to practice, I am saying your assignment. There is a different assignment for you to submit. There is a retail data analysis case study, which is very good, using data frames. I will share the solution and along with the code, so you can run it yourself. Again, it's the same thing. You will read a file, then understand. You do group by queries and all on a data frame, right? So what exactly is scoop, right? And why do you need to be aware of it? Very simple. If you install scoop, it will allow you to bring data from any SQL store. Which means the SQL store can be an RDBMS like MySQL or Oracle. It can be a data warehouse like Teradata or Exadata or Greenplum, right? Whichever store understands SQL, you have a table here or databases and tables. Using Scoop, I can say get the data from here, and then it can just dump it into HDFS. So it's a data transfer tool, to be very fair, right? It just brings the data from this point to this point. Or I can also say, hey Scoop, get the data from there and store it in a Hive table. So one thing is that you are directly dumping in HDFS as a file. Okay. Second possibility is that I already have a Hive table. I have an Oracle table. I can say read from Oracle the whole table, dump it into my Hive table. Just transferring data. Third possibility, I can also say store it in an H-based table. This is not fairly used, but it is possible. HBase is your NoSQL database, right? So I can say read from MySQL, dump it into an HBase table. So this guy is like an ETL tool. It's a typical ETL tool. You can consider like that. It will extract the data. There is a bit of transformation you can do. Dump the data wherever you want. And it can do the reverse as well. What do you mean by reverse? From Hadoop, can take data, dump it into MySQL. So both ways you can transfer the data. So data transfer tool. It is not an analysis tool. You are not doing any analysis with Scoop. You are just bringing data from point A to point B. That's all you are doing in Scoop. Right? Now, where should you use it? Right? If you are having large scale production setup, people actually use their own ETL tools like Informatica or Talend. So in GE we are using Talend. So we will be writing Talend jobs.
So Talend is an ETL tool, and Talend is much versatile than Scoop. Scoop is a very lightweight tool. Compared to Scoop, Talend can do 1000 other things actually. So in large setups, people will be using their own ETL tools like Talend or Informatica. But where is your requirement? So the biggest challenge is that, right? So you join a company, you start working in a big data project. Now you have some data with your customer, right? The customer says, I have 5 terabyte data in my Oracle table. You want to bring it in, right? Now definitely the ETL tools can help you to bring it. But the problem is you go to the ETL guy and he could have never heard about Hadoop. So that means he might be a Talend developer, but he has to integrate Talend with Hadoop first. Then only Talend job can run. So wherever I have gone, I have seen that ETL guys will be a separate group altogether. They may know about Hadoop and all, but they may not be like experts in Hadoop. So if you go to the Talend guy and say that, hey, can you help me using a Talend to bring from this to Hadoop? You say, no, I don't have time. You do your job. That is where Scoop is useful. You don't have to take help from anybody. You can write your own SQL job or ETL job, get the data by yourself. So you become a small scale ETL developer by yourself. That is the actual use case of Scoop. And we have used it like in n number of experiments we have used Scoop. And while importing or exporting, so this is called import. This is import. Import means from RDBMS to Hadoop. This is called export, from Hadoop to RDBMS. So if you are sending a data from HDFS to MySQL, that's an export. MySQL to HDFS is import. You can do both. Another point is, how does this work? So is it just like magic it will work? No. Requirement number 1, you need the driver. So if you are bringing the data from MySQL, of course you need MySQL driver to be available in Scoop library folder. Otherwise Scoop cannot understand what you are talking about. Second point is, this data transfer is done using MapReduce. So you are saying MapReduce is extinct, right? It is not extinct. Meaning, what Scoop will do, it will understand, okay, you have some data to transfer, let's say a table to transfer. It will divide your table and launch mappers to copy the data. So you can actually see the mappers running when you are copying the data. So from the point of view of Hadoop, it's a MapReduce job. The mapper is not doing anything, copy paste it is doing, like it is copying the data, that is all it is doing. But it is a mapper job. You will see the mapper running when you run Scoop. Anybody has run Scoop so far? So you could have seen that, right? And you adjust the num mappers and all. No. So what you need to actually learn here is how the transfer works. And that is a very confusing topic. In many trainings, this questions come, I don't understand how it is happening. See, point number 1, you have a table here, right? You have a table. So you say, I want to bring this table into Hadoop. You write a command in Scoop, that is understood. And since Scoop has the driver and the username and password and all to connect to the DB, it will inspect the metadata of this table. Okay. Step number 1, it will try to find your primary key. So there is an order of the error, meaning your table should have a primary key. Point number 1. So imagine this is the primary key. I'm just taking some examples. So this is my primary key, right? So it will automatically detect this column as primary key, and by default it will divide your table into 4. Number 4. So this whole table, so let's say you have 1000 rows. So divide like 1 to 250, 250 to, there is a boundary query it runs. 250 to 500, 500 to blah blah blah. 4 equal chops it will do, right? So let's say 1, 2, 3. Logical, like this. Based on this value, primary key value. This primary key value is used to divide. So now your table is divided into 4. It will launch a mapper 1, mapper 2, mapper 3, mapper 4. Each mapper will copy one part of your table. And it will store that in HDFS. Meaning, you will get 4 files as output. If you run a normal Scoop job, and if everything is ideal condition, right, it will inspect the primary key, it will understand, okay, you have a primary key, Based on the primary key, it will divide the table into 4. 4 mappers will be launched. Each mapper will pick one part of the table and mutually exclusively transfer it. Your Hadoop destination folder will have 4 files. Very simple. This is the default behavior. But the default, now the question is why 4? People ask all weird questions, right? So when I explain, the question is like why 4? Who decided the number to be 4? Any idea why 4? Now even I don't know. So I checked the documentation. Some guy in Stack Overflow suggested that initially when Scoop was created, they thought that each machine at that point in time had 4 processor cores, quad core. So each core will, one mapper will take 1 processor core, ideally. So to leverage the full maximum computer, 4 mappers will be launched by default. When Scoop was created. That rule remains the same now also. 1 core, not the whole core, and it will not utilize the full core. There will be multi-threading and all, but 1 core it requires, ideally. Each mapper, one core, ideally. And this number 4 was created long back. So now you have better performing computers like 16 core and 32 core. Now the second point, okay, I want to do normal transfer. I run a Scoop job. It divides into 4, gives me the data. I am happy. But my table has 1 trillion rows. So dividing it into 4 is not a good idea because one mapper will get a lot of things to transfer. You can use an argument. You can say number of mappers. I want 10. So what it will do? It will divide your table into 10. So depending on the size of your table, if you have large tables, you can override saying that, hey Scoop, divide my table into 10 or 100 or whatever feasible number that you come up with. But the problem is, so if you say you have a very large table and you say divide your table into 1000, that will happen. But 1000 concurrent sessions will hit your RDBMS. That is bad. Your RDBMS should be able to handle this load, right? So if you tell Scoop that divide a table into 1000 parts, it will launch 1000 mappers. 1000 mappers will attack your RDBMS at the same time. So your RDBMS may suffer in that case. So don't increase the degree of parallelism beyond a point that your RDBMS cannot support. We can actually look at the job output. It will show you how many records were transferred exactly. So if it is like 1 to 1000, it will actually divide like 1 to 250. Exact. But if you are like 1001 rows, then the 1 or 2 here and there will change. Apart from that, load will be equal. Again, I am talking about the default settings. We have not overridden any setting and we are assuming primary key is there, blah, blah, blah. First setting you can override is that you can increase the mapper, right? So, now, what if you type a Scoop command and in that table there is no primary key? Your command will fail. Scoop will say that I am not able to find out primary key or anything. It will simply fail your import. So, in case if your table does not have a primary key, if it does not have a primary key, in your command you have to mention a column which has to be used for splitting. It can be any column, ideally an integer column without null values, like some unique values, right? Any column you can mention, doesn't matter, okay. But if you are mentioning a column where there is a lot of repetition happening, you don't have much of a unique values, then the division may not be ideal, normal cases. So chances are there you have a table no primary key, right? But you have a transaction ID there, transaction number. So that can be considered like a primary key. So you tell Scoop, hey Scoop, transfer the data, but I'm sorry, I don't have a primary key. Use this transaction ID column to split the data. It will do it for you. It actually calculates a hash of the values that is there in that column, and then it decides how many number of rows are there in each split. So if you are having unique values, the split will be equal. If you are not having unique values, split may not be so equal. So one mapper may get, let's say 1000 rows, the other mapper may get 900 rows, slightly. So most of the cases what I have seen, you will have a primary key, then you don't have to bother. But if you don't have a primary key, you have to say use a column and give some column, and can I use a string column? By default, no. By default, if you give a string column, it will say I cannot split. You have to use an argument for that. I'll tell you what to do. Otherwise, string column it will not understand. Integer and it will understand. String you have to use an argument, then only Scoop will understand, okay, this is the column I have to use. And import, so this is import, right? This is you are sending from here to here. Export also works the same way, but the difference is in export you should already have a table in RDBMS. Scoop cannot create a table. So you create an empty table and then you say, hey Scoop, I have a table. From Hadoop you dump it here, it will dump it. And couple of more interesting things. If you are using Hive, let's say I did an import. I again did the import. It will work. Hive does not understand what is a primary key. Constraints cannot be validated. Hive has no clue what is a primary key. So if you do an import and again you import the same data, it will not say there is a duplicate entry or something. It doesn't understand, just append, right? So you have to intelligently think what is here already. Should I copy the same data or should I append the data, or you have to pass a condition. By default, if you dump the data, it is append. And we may not be able to cover this topic in hands-on, but I'm just saying how do you ensure if the data changes, right? Like this is a table. I said Scoop import. Scoop pull the whole records. Okay. Next time some values are modified in the table. I want to catch only those values. Are you getting my point? You originally have a table, you pulled it. All the data is available to you. Now updates can happen, it's an RDBMS, right? So next time when you import, you should not need the full data, right? You need only the updated records wherever it is possible. So that option is available. In the source, if the data changes, right, it can track based on a timestamp, and only those modified values will be copied. It will not copy all the values. Otherwise, every time you will get the full table, right? It will do a full table scan. So another problem that will end up in export is that I created a table and I have defined primary key. So where is my primary key? In RDBMS. Scoop has no idea of primary key. Even Hive has no idea of primary key. So when you export the data, it will again split into 4 mappers. What will happen? 4 mappers will come to your RDBMS table. One mapper will dump the data, second mapper will dump the data, third mapper will dump the data. When the fourth mapper tries to dump the data, there will be a primary key violation. Maybe that guy has a value which is already here. Fourth mapper only will fail. So you have inconsistency in data. Because for 75% of the data will be loaded into the table, 25% it will fail because only that mapper had some duplicate key. No, that is where you have to use a staging table. You bring it into a staging table. You can use a staging table option in Scoop. In RDBMS, you bring it into a staging table. From there, you say in RDBMS, you copy. There you can validate the constraints, right? Scoop cannot validate, doesn't know. Export, when you do, what it does is that first of all, when you are exporting, if you are exporting from Hive, Hive doesn't even understand what is primary key. If it is a file, file also does not have primary key. So it will take any random column and split and export. That is how export happens, and it may not be equal and all. Like 4 mappers will be launched, each will get some data. But the problem is that the destination will have a primary key. So when you hit the destination, some records will fail, some will get inserted. That is a very big problem because you can never troubleshoot it. You have 1 million records, some records will be updated, some will not be updated. So we bring a staging table, you dump it in the staging table. From there, you validate the constraint and insert it. That is the way. It's not the full table. You can do a full table dump. You can also query. I can even say join 2 tables, output I want to transfer. But all those will happen at the cost of RDBMS. Who will do the join operation in RDBMS? Scoop doesn't do any join, right? So if I write a join query in Scoop, it will execute in the RDBMS and the output can be transferred. Scoop does not have so much of a great enhancement because most of the functions, they support more databases. Like Oracle support was less before, now Oracle support is more like that. Apart from that, basic functionality remains the same. There is not much of a difference. Scoop user guide 1.4.6, this is the Bible. Anything that is you want to do in Scoop is in this guide. It's an HTML file. So just open this and it will have all the commands in the world which you can run on Scoop with explanation. So we will run it, okay, but I'm just suggesting that later in future you want to do something with Scoop, This is the best guide. Scoop user guide 1.4.6 version. So here everything is there. How to connect with the DB server, selecting the data to import, how to write a query, controlling file, everything is there. We will go through some of them in the hands-on for sure. But later you want to do something extra. This is very easy. Once you get a feel of it, I don't think you need a lot of input to do it. You can do it on yourself. And I just want to check how much the lab can take, our load, right? So in this file, right, I shared a file with you, right? The first scoop command which you have to learn in any scoop project is that you should be able to connect with the DB, right? So what are you trying to do? You are trying to pull the data from a DB. So first thing is that you should be able to connect with the DB, and that is this command. So if you just copy this and paste it in your command line, it says scoop list databases. So this is the argument. So you're just asking scoop to list all the databases, and you will pass a connect argument, and this is where your MySQL is running. Username is lab user, password is great learning. Ideally, so you can see all the DB, right? So these are all the databases in my MySQL. So first step you always do is that make sure you can connect with the DB. Otherwise, what is the point in doing import or getting the table or anything? So for our practice, I have set up this DB called retail_DB. It has some tables and all, so we can try it out, right? So if this command is running, if this command fails, either hostname will be incorrect, you may not have permission to list, or some port may not be open, you have to check with your admin. First, always you do this, you have to check scoop, list databases, connect, username, password. It's like standard for every scoop practice. And obviously, you can also check the tables. You can also say, see, the second command I ran is slightly different. I will say scoop list tables, right? And then I will give my connection string and the DB name, retail DB. Rest everything is same. You cannot connect to the database. There are two options. One, there is a password file. So if you don't want your password to be typed every time, you can add it there. Second, there is an options file, a text file. So I can create a file called options.txt or any txt, and there I can add all these things commonly used and call it. Okay. But as of now, I just copy pasted it. One is like there is a password file. It's a text file where you store the password, and you will say -- password file. You don't have to type. Second, there is an options file. So you create a file called options. In that you can add all these things: connection string, username, password, everything. So every time you don't have to type it, you call the options file, right? So I'm actually showing this in a way a real project actually works. So normally what happens, we list the databases, we list the tables. Now there is something called a eval query, which means so next thing is the scoop eval. Meaning, let's say you want to import a table. Before you import the table, you want to ensure that you have permission, right? The table exists, values are there. So that is where you run this eval. Eval is like any command. You can say scoop eval and connection string, and I can add a query. I am saying select star from here limit 10. So if this runs and I see the output, that means I have access on the table. I can run the query, data is there, everything is fine. So before you try the import, you do an eval to ensure that any query you can run, output will be on your screen just to see. So that is a safe practice, eval queries, we do it. So there is a table called order items. We can try to access it. So I can simply do a scoop eval. Okay. You can also try it along with me. I am saying, see, the output is there. I am saying, hey scoop, evaluate the query that I am typing, and here is my connection string, here is my username, here is my password, and this is the query. So you have to say -- query, give whatever query you want, and you get it. Very interestingly, using the eval argument, you can even create a table and insert values. It is running any query that you give in RDBMS. From scoop, I can say create a table, insert values. Because eval is just any query it will run, even create table query it will run in RDBMS. Because we have full connection, right? It is just like you are accessing from Todd or what you say, SQL Workbench or something like that. Scope is just a transfer utility. Eval is just to evaluate whether everything is working fine. I don't think multiple queries will work. Just try. Or in the eval document, you can check. I have the web page, right? Scoop user guide. Do you see eval somewhere? Yeah, Scoop eval, right? So, the purpose. The eval allow users to quickly run simple SQL queries against a database, right? See here it is clearly saying eval tool is provided for evaluation only. It is not supposed to be used in production workflows. I don't think you can run multiple queries and all, just for evaluation, right? Okay, so now, so here you can see you don't have to do this, but I was doing a scoop eval. I was creating a table called a dummy. Then I was inserting a value 1 into the table. All these things you can do, but I don't want to run this. And now let's try the scoop import. This is what you want to see actually, right? So when you want to import the data, the command is here. You can see you have to say scoop import, and then you give the connection string, database, user, password, table, and then you pass something called warehouse directory. So you can have two arguments. One is called a warehouse directory, or you can say target directory. What is the difference? If I say warehouse directory, what it will do? It will copy the table and create what you say a folder with the same table name. Got it? If I say warehouse directory, what is going to happen? I am copying to user, GL faculty, scoop import, retail DB. Within this folder, another folder with the table name will be created and the file will be dumped. If I say target directory, it won't do that. It will simply dump the data, right? It will not create a table. So it is very useful if you have like thousands of tables and you want to replicate the same structure. You say warehouse directory. It will read the table name, create a folder structure. And we can actually try our first import. Now you can actually check RDBMS, this table called retail DB. Okay, this has a primary key. This sorry, not retail DB. What is that? Order items. Order items actually has a primary key. Okay, so that means the default should work, right? If I don't do anything, default should work. I will try first. I don't mind you trying, but I'm just thinking if everybody runs, will the import actually work? Okay, go here, run. Looks like it is working. Let me check. It is working for sure. I will explain what happened. Okay, let it run, then I'll explain what happened. See, MapReduce is running. Can you see? 25, 50, 75, 4 mappers. Done. Retrieve 1,72,198 records. So you can try the query yourself, and then go to the Hadoop location, check whether the data is there. And then I will explain what happened during this. So I did this. There is an argument you can pass. You can give column, comma, and table, it will import. So if I go to my HDFS browser, the folder name is scoop import I had given. Here is scoop import. Here is retail DB. So can you look at this? It has created a folder called order items. In the import command, you asked it to import to where? Scoop import retail DB. This was the folder you gave. But when you look at Hadoop, what it did, scoop import retail DB, it created a folder with your table name, order item. And then within that, you have four mappers dumping the result. Each one, if you look, it will be normal, comma separated values. Working, right? It should work. I mean, it's very simple actually. This folder order items, it got from the table name. When you mention warehouse directory, to read the table name and same will be created, and inside that we see 4 part files. There are multiple conditions. I'll show you how you can append. Now if you rerun, okay, so let me try this. Now if I rerun the command, Okay, that was a good question. What will happen if I rerun the command? This was the command, right? So one exception will come for sure, and I want to show you the exception. So what is the exception? Output directory already exists. Why that exception is coming? It is because of MapReduce. If you remember, when we were running MapReduce programs, the folder you have should not exist, right? When you run MapReduce, job will create a folder and dump it. Now, if you want to get rid of this exception, there is an argument you can pass. You can say that don't worry, even if the folder is there, just copy it. Then it will append it, start appending. You will already have 4 files, 4 more files will come there. We will run that. There is an argument. Actually, it is there in the command set. So now there is an exception because the folder already exists. And now what I want you to do, delete this folder because we want to run this again. So go to Hadoop and delete this scoop import folder. Otherwise, you will get exception, right? As of now, delete it. Say move to trash. Yes. I want to show you the difference between target directory and warehouse directory. So now when we ran, we mentioned warehouse directory and you were mentioning the folder till retail.db. You can also say target directory, okay, wherein you have to give even the folder name. Within that, it will create the file. Oh, I did not show you what it is doing, right? I will show this time. So let's run this again. Hortonworks has a tool called Accumulo. Anybody used Accumulo? No? Accumulo also does the same thing. Ran the same thing, but what I want to explain here is what happened when you ran the query, right? So this is the query I ran, the scoop command I ran. And the first thing that it does is that it says I am running scoop version 1.4.6. It says setting your password on the command line is insecure. You can say capital P if you don't want. Preparing MySQL, beginning code generation. And can you see the SQL statement it is running? Select T dot star from order items as T limit 1, right? So I'll tell about it. It says that I am running this command and scroll down again. It says writing the jar file, right? So it created the jar file. It looks like you are importing from MySQL. That's fine. Okay. It says beginning import of order items, right? And here you can see the statistics. See, what is the total size of your data? 1,72,198. How many splits are there? 4. What is the split size? 43,049. Almost equal, we can say. It says number of splits 4, submitting tokens for job. Okay, and then it runs the job. You can do one more thing. You can actually go to this job browser, right? Job browser. And this is the job we ran. You can go here and it will have all the metadata. Where is it? The mapper stuff. Wait. So this was what we ran. Tasks, right? So there were 4 mappers. Okay, and you have individual logs for them. And if I open this, here it does not show something. Resource Manager actually shows these logs in a better way. Yeah, so here it is somewhere. The only problem is I'm not able to scroll through this, right? Can you see working on split? What query it is running? This is what an individual mapper runs. This is a first mapper. So it is actually saying where order item ID greater than 1 and less than. So this is the primary key. It is getting only 1 to 43,051. Next guy will get from 43 52 to next whatever. So actually it runs this query and then splits and then get the data. You can see in the logs what it is doing. So 4 mappers each will run the same thing. So where is it? Okay, and then the query runs. Now what else you can do, right? If I scroll down, one more thing is that some of you were asking, what if the directory already exists? So one option you can do is that you can say delete target directory. So if you pass this argument, it will delete the folder and then recopy. So previously you were getting an error, and also in this particular example I am giving a number of mappers 1. So this is how you can control the number of mappers. So instead of 4 I am saying 1. So if I try this import, I should get a single file ideally. Let's verify. It is running. So this time you did not get an error because you are passing this argument called a delete target directory. It's going to delete the folder, then recopy it. Retrieve the records. If I go to my Hue, HDFS, where is it? Spark. What is the name? Scoop import. You will have only a single file. See, single file, because number of mappers are 1. Try that by yourself if you want. Sorry, in this, yeah, it is that MapReduce program is created as a jar file. When we were writing MapReduce, you created the jar, right? So this is also a jar file. So try this by yourself, how to import using one mapper and also how to delete the target directory. And if you want, you can also say this. You can pass an argument saying that append. So this means it will append the data to the existing folder. I am just running the same command, but this time I am saying -append. So append will append your files. I think all of us are running now. It's taking a bit of time for me. Mine is stuck. Everybody is stuck. But so far then how it was running? No, but so far we were running, right? How does that work? So if it is stuck, why it is stuck this time? Am I doing something else? Oh, okay. There is one mistake here. But if it is a mistake, it should throw an error. The password is different. I by mistake pasted something. So in that command, the password is different. Oh, if I do a Control C, it will not stop, right? It will copy. Sorry? Yeah. So this entire thing is different. I had to change it. You can just add it here, right? So I can just copy this. Just do this, copy this, because I don't want you to make a mistake also. You say table, warehouse, number of mappers, and you say append. Just paste it here. Instead of this, you can simply say append. Just make this change, otherwise in the documentation, if you look later, that is the reason it is stuck, I believe. Run. So make sure you can run it with the changed settings, whatever it is. Run, right? It says appending to directory. You can clearly see at the end, the log will say appending to directory. But no matter whichever project you land in, Scoop is a must. So it is a mandatory tool. You should know. People will ask you to do something on Scoop for sure. Right? It's a very common utility. It's very easy also, it's not rocket science. Even if you don't know, you can learn on your own. It's not very difficult. So that is change this line for append, right? Change this line for append here. No. By default, it will throw error. It will say the target directory already exists. So if you copy, again you copy, it will throw error. Two options, either you say delete the folder, it will recopy, or you say append. Otherwise, error is for sure. See here, I have written already split by. So if you do not have a primary key in your table, that is when you use split by. So here I have already written, for performance reason, choose a column which is indexed. Okay, one condition. If there are null values in the column, corresponding records will be ignored. And data in the split by column need not be unique, but if there are duplicates, there can be skew in the data. So this condition is applied if you have a table and there is no primary key. Then you have to say split by. Ideally, if you have a column that is indexed, that is good. No null values, that is good. Unique values, that is good. Then use that column. So first try without. So I have created a table called order items no pk. There is a table. This table has no primary key. It is same order items table only. I just copied into another table. So first, let's just try an import without mentioning any argument. Okay, so this is how I have already done that. I did a create table orders items no pk select star, and now what I am doing here, I am doing a scoop import, username, password, table. I am not passing any argument. So if I do this, it should fail, right? Because there is no primary key ideally, right? So first we will make it fail, then we will see what we can do. So I am just copy pasting this part. You can see what I am doing. The table name is order items no pk. Yeah, so very clearly it will throw an error. Can you see the error? It says no primary key could be found for the table. Please specify one with split by or perform a sequential import with -m1. Now, very interesting point. You have a table you want to import. There is no primary key. I don't know any column also. There you can also say -m1. If you do this, what will happen? No split. No split means no primary key. It will, one mapper will import it. So if I have a table and there is no primary key, one option is that I mention a column. Using that, it will split. Now what if I don't know that also, right? Then I can say just -m1, which means only one mapper. It won't split the table at all. So no need for primary key. Primary key is only used for splitting, right? So this will import the whole table in one go, one mapper. If it is small table, it is good. If it is a very large table, this performance issues will be there because a single mapper cannot handle those many. But you get an error, that is important. When you directly try, you will get an error. So you have to mention a split by column. Okay. And how do you mention that? Very simple. Same commands, scoop import, connect username, password, table, warehouse, and you say split by order items, order ID, right? So this is the command that you are passing, right? So if I copy this, should be able to run. Right. So now I think we used a column called, which column did we use in this command? Order item, order ID. So this order ID is a unique column. So ideally this should work without any problem, right? So this is where we use the split by. Try the split by. Okay, now don't do the next step. I want you to first look at it. What I'm going to do, just copy this part. Yeah. So I am trying to again do a scoop import. This time I am copying the table called retail DB. Sorry, where is the table? Orders table, and that has a primary key. Okay, orders table has a primary key. Okay, but again I am using a split by just to show that. I am saying split by order status. So order status is a column which I want to split. That's a string. Okay, that's a string. Now if I run this, I will end up in an error. I should ideally end up. So let's see whether the error is coming up. Because you cannot split by string by default. So the other problem is, this time I think it took it. No, it's working for string. See, some of the scoop imports cannot split string. Okay, I wanted to check how it works in this cluster. In this cluster it is perfectly working. So we use a string column, but it's split without any problem. If you get an error when you are using a string column, that is when you have to use this argument. Can you see here? Apache scoop splitter allow text splitter true. Now in your cluster, when they could have installed a scoop, they could have by default set this property to true. Like it will by default allow strings. In some of the clusters, what will happen? They will not allow. So you can pass this argument saying that, hey, allow me to split using string. Otherwise you will start seeing errors. We don't have access to this actually. It is not in the UI. It is in the scoop conf.file actually, that we don't have access. I don't know where it is. But they could have set it automatically to true. So if it is running, fine. If it is not running, that is when you need to use this property. Otherwise, and especially on Hortonworks clusters, if it is a default cluster, it will be false, this property. That means you have to pass this argument. Otherwise, it will say, you're talking about a string column, I cannot split string. So you're like, why cannot you split string, right? Yeah. So there are a lot of other properties, and you can also have something called a boundary query. So what you mean by boundary query is that if you want to pass your own query for splitting, you can pass it. So normally what Scoop will do, it will decide how to divide your data, best way. What if you want to decide? So you can pass something called a boundary query. You can say that, so here I am saying select min of order ID, max of order ID, where order item ID greater than something. So based on that condition, it will split. I can pass my own query for splitting. Normally what it does is that it will equally split your data. So here I am saying that I want records only where the order item ID is more than this. So it won't bring the whole data. It will bring only the data where this condition is applied. What if I don't want the full table? You can do that also. One way of doing it is boundary query. Second way is that you can pass hyphen query. Not boundary query, you can simply pass a query and the result of the query can be imported also. Both you can do. Boundary query you can pass, or you can say a normal query also you can write.
Is there any other difference between these?
No difference at all actually. So there are two options. Either boundary query came first. Okay, then we got an argument called query. You can directly write a query. Okay. But in boundary query, you will normally write a regular query like this. If you say hyphen query, you have to say $condition. There is a keyword you have to use. I will show you what is that. Okay. So this means you are importing all the records, but the condition is order item ID is more than this. I would request you to try this later because, and this is something I wanted to show you. Where is it? Let me just scroll up. See, look at this query, columns and query. So one thing that we are doing here is that you can pass an argument called columns. Okay, which means I want to copy the whole table, but I want only these columns to be available. I don't want the full table actually, right? So before we actually run this, I will just delete. Yes, in the query I have written it will bring all the columns. Now I don't want that, I want my own condition. Like I want only specific columns to be there. So here you can say that I am setting number of mappers to 2. That is not required. If you want, you can try that. Only difference here is that you will say these are the columns I want. Create a warehouse directory, number of mappers 2. So ideally your output should have only those columns. Order ID, what else? Some other columns, right? What did I mention? Order item ID, order item ID, and subtotal. These 3 columns only should come ideally. Done. And if you check here, what is the folder name? Scoop import. See, only these 4 columns came. We originally had 7 or 8 columns in the data. Now you are getting only 3 columns the data. And you can also import with your own query. So that is this. Have a look at here. I am saying scoop import, connection, these things are same. Okay. Here I am saying hyphen query, and in quotes I am writing my query. So here this is like a join query. It is a total join query that I am writing, and whatever output I get, okay, will be transferred. And one condition is that it's written somewhere. Yeah, for query we cannot use warehouse directory. It must have this $condition argument. You cannot also use columns, and you must use split by. The point is, when you write this query, right, you are saying that the output of the query should be transferred. Now what if I am doing a join on 2 tables, right? In that case, how will it identify where is the primary key? Because I have 2 tables and then output is different. So when you pass the query, you have to mention split by which column, whichever one column you have to mention split by. Second thing, it should be always warehouse target directory. You cannot say warehouse directory, because warehouse directory is where it will create the table name, folder name. Here you have multiple tables and it will get confused, right? So you have to mention the target directory, and you have to use the split by, and then you have to pass the query, whatever query you want. The output of this entire query will be dumped into that folder. So whenever you pass a query, the query is a condition for Scoop. Condition for Scoop. So you are mentioning that dollar conditions, meaning this is the condition that I am giving you. So run whatever, and so this. So if you look at here, I am doing a select star, then I am doing a sum, order by revenue, 2 tables I am using, and then I will say and dollar conditions. So no, it is not a variable. It is not defined at all. It is just a part of your syntax, saying that in fact what it does, it will run this whole query, and the output of that query is matched with this condition. So the condition is actually the output of this query. Yes, whatever condition you are passing here. So this entire query is that dollar condition. And right? So it is the syntax. You are saying that this query and the condition. It can be anywhere actually. It need not be always here. This and condition can be at the end also. I can write a query and say and condition. So you are basically saying that they take this query output, apply it as a condition, and then import the data. So this has been there like from the beginning of Scoop, this condition argument. And why they have come up with such a name or such like dollar syntax and all that, I don't know. I mean, what is the reason? So, and there is one more error. Sometimes when you run this entire Scoop, and that is why I have added here, it will give you a weird error saying that I cannot connect with the database, or so sometimes when you run, you get an error saying that I cannot connect with the database, or some error which you know it is not an error because you have connection, everything correct. That is where you have to pass this driver, hyphen driver. Sometimes the driver name, whichever you are using, now you are using MySQL driver, right, has to be mentioned in the parameter. Otherwise you will get unexpected errors. We have seen this in many conditions. That is why in every command I added this. Here also, here it is not there, but most of the commands I will have added this. In Scoop you have a lib folder, library. There you need the this thing. So I think, how do you check CD, etc? No, they have kept it somewhere else. So in Hortonworks clusters, I don't know where they have kept the library folder. In Hortonworks clusters, it will be USR, HDP, Scoop, lib, there is a folder. Here I don't see it. If I go to etc scoop, there is only a conf folder. That is not the place. There is a lib folder. There you have to copy the driver. Then only this will work. Library folder. Okay. So you also have a way to handle null values and all. Oh, let's run this just to make sure it will run. What happened? Why it is throwing error? Connect command not found. Okay, it's not complete. Sorry. I thought why it is throwing an error now. Yeah, so it's copying the output of the query actually, right? And it will run. You will get the output. You can also mention null values and delimiter. For example, what you can do is that you can say that null string, null non-string, replace it with this value. And there is something called incremental import. I will talk about this a bit later. Somewhere we have, simple Hive import. So if you want to import to Hive, what you need to do is that again you will have connection, username, last name, table, and then you will say Hive import, and then you have to give a database and a table. So can you check what DB you have in Hive? I have something called No, your own DB. Default is there. You need to replace it with your database. Do you have a database? Do you remember we created? I have something called June 28. So here in Hive import, you have to give the Hive database and Hive table. It will create. And I'm just saying number of mappers too. So let me see if this works. Should work. Can you try that by yourself? Check the Hive DB. Don't copy it to default because everybody will be doing the same in that case. So when you do a Hive import, actually what happens, your data will first go to HDFS. From there it will copy to Hive, meaning warehouse folder, wherever location you have. But it is a two-stage process. It will not directly dump. You can see here, first it will go to, so here it went to HDFS. From there it will again take and load it into Hive. Like first it will go to a temporary location. Okay, from there it will load it into user, Hive, warehouse, wherever you have mentioned, manage table. Right. Same command it will run actually. So you can see that the table actually got created in Hive. And I just want to verify this, so I can go to my Hue, query editors, Hive. I'll just go to Hive, query editors, and my database is June 28. Where is the DB? June 28. Oh, okay, yeah, default, sorry. June 28, right? June 28. There is the order item table. Can you see? Order items. Select star from order items. Limit 10. I have the data in Hive. But lot of confusions are there in Hive import. Okay, so the simple import is easy. A lot of other. There is an argument I forgot. I think create table if exist. I had written it in my notepad. I want you to try export later, not now. I will tell you how to try that. It's very simple. You again do export, but before you do export, you have to create an RDBMS table. And you know how to create an RDBMS table. I don't have to teach you. And do the same thing, it will export. I remember when we first started using Hive import in Scoop, it didn't work, some error came. We took around 1 month to understand what was happening. I'll tell you the situation. This is a real life situation. Normally you say Hive import. If you say Hive import, it will import, no problem, right? This is what everybody is doing. There is an argument called create Hive table. Create Hive table. Along with Hive import, you can say create Hive table. What do you think this will do? As per the look of it, it says it will create a table. It does not do that. So somebody had written a query, like very lengthy script it was. Inside that, Scoop was there. Like it was a job actually. We had Hive, Pig, everything running. Within that, somebody has written something saying that Hive import they were doing. Hive import from the table, create Hive table. This was failing. And we didn't know why it is failing or what is this argument. Nobody bothered actually. Then we looked into it. Create Hive table looks like it will create a table, right? Actually, the use of this argument is that if the table exists, import will fail. That is the argument. Already exists in Hive, the import will fail. That is what this argument says. But the argument name is create Hive table. I still don't know how it is. And even if you look at the documentation, spelling mistakes also are there, because I remember looking at this documentation. Here it is, Scoop create Hive table. Yeah. The create Hive table populate with a definition for a table based on a table previously or one planned to be. This effectively performs Hive import, Scoop import without running preceding import. If data was already loaded, you can use this tool to finish the pipeline. You can also create Hive tables with tool. Data then can be imported and populated. This is what the documentation says. Okay. Actually, if you run a create Hive table along with Hive import, what this will do, it will check if the table already exists in Hive, then it will fail. Second problem, it will fail, but before failing, it will copy the data to HDFS. So next time when you run, another error will come. It will say that the directory already exists, and you don't know what is happening. So this went for 1 month, almost, because we were even not knowing that it is actually copying to HDFS, then copying from there. We were not bothered. So initially you don't learn these things, right? So we were thinking, which directory? There is no directory, right? It's copying to Hive. Where is the directory? Again you run, again it will throw error. So then you delete something and again run, and another error will come. So 1 month it went like that. Then some guy figured out that this is the problem. So this means the table should not exist. So then we deleted and created the table again, and then it was able to create a table and load the data. So some of the Scoop arguments are very confusing, okay, and don't just copy paste in production as such. Any command, okay, just run it once and see if it is working, then only. And there was a spelling mistake, I think they corrected. It was exit instead of exist. See, if the table exits, it exists. There was a Jira request file to correct this, that is not done. Okay, so if you say create Hive table, if set, then the job will fail if the target Hive table exists. How can you justify this? Create a table, the job will fail if the table exists. There is no match, right, with what you have written. And then the definition should be changed, right? If somebody use this, what they will think, okay, create a table, right? So these very confusing arguments are there in this thing. Anyway, I will leave you to the export. Export, I will ask you to try yourself, because first thing, it is very simple. What you need to do, commands are already here. Create a table in RDBMS, and then go to Hadoop, say Scoop export, and give the source and destination. It should be able to export. All right. Let me know if it doesn't work. I will figure out a solution for you. Another data transfer utility like Scoop. And Flume is having a lot of documentation and a lot of configuration parameters and all. We don't have to be aware of everything. We'll do basic couple of Flume commands and run them to ensure you know how Flume is working, right? So why do you need Flume, right? So Scoop you are using to bring RDBMS kind of data, like structured data. Flume is used for streaming data. Like you have any source which is generating data continuously, you want to catch it and then send it to Hadoop. That is where you will be using Flume. Originally Flume was created by Cloudera. And why they created Flume? Their use case was that a lot of customers had web servers. So in web servers, these log files will get created, and they wanted to capture all these log files when it is getting generated and then store in Hadoop. the moment. So if you actually visit Amazon or Flipkart, right? If you click on a product or navigate to a department, all of that information is logged and it keeps on coming, right? So they needed a tool which can capture all this streaming information and without losing it, send it to Hadoop. That is how originally Flume came. Later what happened, people added more support. So today Flume can connect with many sources. One is like your log files for sure. Second is like Twitter. If you have tweets, one very common thing is that you can connect with Twitter and then you can download all the tweets using Flume. Flume very efficiently will allow you to get the data. And what you need to understand is this thing. This is the architecture of Flume. If you understand this, more or less you can run Flume, right? In here, so you have to create something called a Flume agent. Flume agent is nothing but a set of configuration, like what you want to collect, from where you want to collect. All this information you will write in a file, and that is called a Flume agent. Once you create the Flume agent, you say run, okay? And once the Flume agent starts, it will start in a JVM. It will start pulling the data from point A to point B. And this part create in a folder called what is it? Twitter data, right? Here is it. And this looks like a text file. Okay, it has a text extension, but it is not text file. This is Avro. I want to show you that. If I download this file, actions, download, yeah, I'll go to the location. This is the data we got, and if I open this, this is Avro. This is Avro format. So you won't be able to see avro.schema at the top. So this is the schema, okay? This is like keys, type, name, fields, user location, something, user screen name, this is the Twitter name, right? So it will have a header like a schema, and these are the actual tweets we got. So pretty much looks like a key value pair only, and I'm not quite sure whether we got something interesting. So in this, it is very difficult to read, okay, but I can search for something. What were the keywords we were looking for? I don't think there is anything on Modi. It is there somewhere. Can you see? Saraswati Vishnu Vidya Mantar, great admirer of Sri Narendra Namodadas Modi. Some tweet, right? From somebody, right? What else we were searching for? Trump. Definitely there will be Trump. See? So this is the tweet. Okay. Oh, sorry. So Avro files will have a lot of metadata. That is what you see, this unread characters. Actually, it's not structured data, right? The tweet will be here. So you can identify it with something. Yeah. So Trump enabler is already saying his scouts pick something. So there is a tweet on Trump. We may not have anything on Netflix. I'm not sure. There is something on Netflix. So but it is in some other language. Okay. So Netflix tweet is in some other language. So some tweet on Netflix, right? So now ideally you cannot process this data as it is. So you have to read the Avro file. Avro files can be read into Spark SQL. Spark SQL has a Avro package. We downloaded a Databricks XML package, if you remember. So we said Spark shell start with XML. Same way we can say Spark shell start with Avro format. Okay, and I think it should be able to read this. We will just try, because I have not even tried it. Okay, so Spark should be able to read it. So what is the package we were using? We may not try it right now, but there is a package which you can read. Now that's what I was trying to do. Normally if you use a Cloudera source, you will get it as JSON. JSON is much more easy to read than Avro. Avro, it's very difficult to read, but you can see the tweets are there. I mean, I didn't fake it, you're actually downloading tweets. I mean, I'm just saying, right? So Trump or whatever you were searching, it was already there, right? So all of you are able to get this. So this one you can see. So you can just start the shell with this. Okay. So I'm just thinking whether I'll be able to read this. I'm not quite sure, but we will try. So I can just upload this in my home folder. I'm just uploading this in my home folder, okay? This Flume data, okay? And then what I want to do is I want to start Spark shell. PySpark 2. So let's see if we can read this, shall we? I am not sure, but we will say. We'll say spark.read.avro. df equal to spark.read.avro. I guess we have to pre-process it. I'm not 100% sure, but we will try it. Spark.read.avro should work. Oh, we have to import it, right? Okay. Java, Python. Okay. Guys, give me one moment. I'm just checking if we can read it. df equal to, what was the file name? The system got stuck. Quotes, yeah. Now, so I'll show you how to process it, but there is a way right now. .avro. I think we have to rename it as .avro. Rename. How do you get file extensions to be shown? Properties. No, I want to rename it. If I just change, it will also happen .txt, right? Where is view? Okay. This one, right? No, not that. View, options. Yeah. I'm just thinking whether this will work. It has to be an Avro. Maybe it will work, maybe it will not work, because the reason is I directly asked Flume to save it as .txt, so it may have a problem with that. Let's try that anyway once. .54951. Now it is showing an error after reading. Block size is invalid or too large for this open. Okay, we have to change it. Yeah, it says error while looking for metadata. Now here, Avro runtime error. So there is something called block size. Anyway, when Flume was saving the data, I asked it to save it as .txt, and that is something I should not have done. So now when I convert to Avro, I'm not able to read it. But there is a way you can read Avro for sure in Spark, right? I want to show you one more example on log data. This is much more easy, not like Flume example. And I can share this with you to try yourself, because getting the Twitter data is one thing. Okay. Second thing is that how do you actually catch log files using Flume? And this is the real application, right? So what I have done in our cluster, I have installed a small utility. I'll just close this window. Okay. Can you see a folder called, not here. Yeah. So there is a folder called gen_logs. Okay. And if I do an ls, there is a script called startlogs.sh. It's a log generation utility. So if I run this script, what will happen? Start logs.set /start. So I just started the script. What will happen now? Log files will keep getting generated. But the question is that where is it getting generated? So there is a folder called logs. If I go to this folder, okay, if I do an ls, there is a file called access.log. If I do a tail on this file, can you see logs getting generated? Yeah. So this is streaming data, right? And this simulates, see, add to cart. This simulates how a user is browsing an e-commerce website. See, categories, golf, shoes, his login page, again departments, fitness, product, some product he is clicking, again department, footwear categories, right? Checkout. So it will keep on generating some dummy data, so you have some data to work at least, right? And this is how an e-commerce website actually will have the logs. So when you click on a product in Amazon, it will log like this. So it will log your IP address, the date, the GET request you are having, the HTTP response code, which platform, Windows, which browser, all the data. So what I did now, I started this utility, and I will give it to you. You can also start it, right? Now this will keep on generating these log files. Now how do I catch it using Flume? So that is usually the application of Flume. It is designed to catch log files, right? So let it run here. I don't want to disturb. And I can do a Control+C, it will not kill it because behind the scenes it will be running. And I have configured a Flume agent. If I go to Raghu, do you see a file called some conf file? Yeah, there is a flume.conf. There is a july.conf, right? Yeah, look at this particular configuration. This is more easy for you to understand. My source is called a gen. Channel is called mem channel, sync is called HD. The type of source is what? Exec. In the last example, we were using a Twitter source. This example, the type is called exec. That's defined by Apache. What the exec source will allow you to do, it will allow you to run a command and get the output. And this is the command you are running, tail-f on the log. So it will keep on tailing the log, right? This exec source, and whatever data it will get, it will place it in the memory. This is the memory channel, and in the HDFS, what I'm doing, I'm saying that dump all the data in a folder called flume_demo, right? And these are the properties. So some of you ask me, like, how do you control? Like, it will create file on Hadoop, but when it should create a file, these are the properties. So you have something called roll interval, roll size, and roll count, which means roll interval is 120. That means 2 minutes. So it will wait for 2 minutes and then create a file. Second property is roll size. This is, I guess, 10 MB. So if the file size reaches 10 MB, another file will be created. Roll count is 100. If it gets 100 lines in the log entry, it will create one more. So whichever of this reaches first, it will work. So you can adjust it. So sometimes probably it starts generating the logs and it reaches 100 logs in entry, it will create a new file because this is the property which you reached first. Or if the log files are very big, probably only 50 lines came, but it crossed 10 MB or 20 MB, it will roll into one more. So using this property, you can configure when the file should be generated on the HDFS. So maybe these two also does not. So you are saying that if the total size of the file reaches 10 MB, a new file should be created. What if you ran the system for 2 minutes, still it is 5 MB? And in that 5 minutes, you got only 50 log files. So these two conditions are not violated. Whatever happened after 120 seconds, a new file will be created. First, it will apply. So these are the 3 thresholds on the HDFS sync that you can apply.
Where do you define them?
Here.
You can change it now?
We can. So here I can change. So anything that you do in Flume, configuration is in this file that you do. Rest everything is simple. This is memory, this is this is this, same thing.
From where it is collecting the log files?
Yeah, this is the location where that thing is running. Gen_logs, access. This is where the logs are generating.
From which website?
No website. It is, how do I say, dummy. It is not getting from a website. Just for class purpose. So you can get these kind of softwares. So you need some data. From where will you get the data, right? So it will generate some random data for you. So you will feel that somebody is giving you the data.
But what is the interval of executing that tail?
It is 1 second by default. But every second will execute. So you will not miss anything. Continuously it will execute. And the tail will exactly tail from last time, like till how many you have tailed, right?
So, but in between this time it will buffer the data which are conditioned.
Correct. So we will actually run this to see if it is working, right? That is one thing you have to do, right? So how do you run Flume? Last time I did not show you. You will say flume-ng agent name. What was the name of the agent? I think I have it here. Just copy paste from here. July, right? It's better to do like this. So you are saying flume-ng, this is the keyword, Flume next generation, agent with a name log agent, and the configuration file is in this july.conf. If I hit enter, ideally it should run. Yeah, so it says component type sync started. See, it says creating the log file here, right? So I think it will reach 100 lines first. I don't know. We have given 3 conditions, right? Either reach 10 MB or reach 100 files or wait 120 seconds. I think 100 files will reach first. 100 lines. I think that might be the case. Even I don't know how frequently it is generating, but you can see that it is running. And if you go to Hadoop, just go to Hadoop. Here, what was the folder name we gave? Flume demo, right? Okay. So here, if I look at here, there will be a folder called Flume demo somewhere. I'll refresh. Flume demo. Can you see a folder? Yeah, there is Flume demo. Yeah. So this is the file that it is generating. See, it is a temp file. You can see 0 bytes, right? Why that is a 0 byte? It will generate a temp file, and once that threshold reaches, it will convert to a .txt. So right now you won't see the file here. Once either it has to reach that 120 seconds or 10 MB or whatever, then this temp file will be converted to .txt and pushed here. Or I can stop the Flume agent, then this file will appear here. Another way is that I can stop the Flume agent, then whatever data it has collected so far, it will come here. So I can just go here, say kill the Flume agent. Oops. Yeah, I killed it, right? So the moment I killed it, if I go here, this could have been created a text file. 2 came actually. There was a role also, right? And if I open any one of them, you have the log files. Same log files which we were user browsing, blah, 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 right? Whatever we were doing, same is available here. So this is how you bring log data to Hadoop. So I will do one thing. I will give you this log generation utility, and you have to copy that in your home folder. It's just a folder, and I will write instructions how to start and stop it. And this configuration file also will give you Flume. So first you start the log utility, run this and change the HDFS path, your home folder. Automatically the logs should start coming in your folder. See whether you can do it. So this is the actual use case of Flume. Normally people discuss Twitter, but rather than Twitter, Flume is commonly used for this. This, if you want to read into Spark, it will directly read, but structure if you want to give, you need a regex. Yes. Once you have your credentials, now what I want you to do is open your web console. Okay, because we have to run Flume from the web console. Log on. Now in the files shared to you, there is a folder called scoop and Flume. Inside that there is a file called flume.conf. Can you see this? If you open this, I have left this here. You have to fill. Can you see this? Consumer key, consumer secret, access token secret. Here you have to copy paste from your credential. Don't use others' credential. We'll simulate a web server log. Like ideally it should be a real web server, but we don't have. But we'll simulate an e-commerce site web log. Then we'll pull it into Flume. So copy paste your consumer key, consumer secret, access token secret here. So that it will look like this. This is on my Cloud Lab. Yeah. So copy paste like consumer key, consumer secret. Don't use this. This is mine. Don't use this. Okay. And then upload that flume.conf file to your Linux. FTP. Do FTP because it has to be in the lab, right? You need to make one more change. I'll tell you what is the change. I will explain what is this configuration. Okay, first you make sure you copy and all, then I'll explain what is this configuration. No, to Linux through FTP. This is in Linux only, not in HDFS. So one more thing, here there is an HDFS path. Can you see? And here after user, change to your username because mine is user GL faculty. So after this, change your username and then any folder that you want. This is where the tweets will land. You don't have that value? You have, I think, right? This value is not there in your file? It's there, right? I mean, I'm just thinking, are we using the same file? One small confusion. I think I copy pasted it twice. So what I will do, I have this file, right? This is my file. Let me just save it. HDFS DFS -put flume.conf to GL data. So I'm just uploading this flume.conf to GL data folder. You download it because this is my configuration. Then I will tell you where you need to change. Got it? You just go to Hue, go to Hue, and if you go to GL data, you will have the Flume configuration. See GL data. Here you have where? Yeah, this file, right? Just download this file in the Linux machine, not in Hadoop. This is in Hadoop, right? You need to get it in Linux, right? So you have to say HDFS DFS -get, right? From your home directory. What you should do, right? You are in home directory. You have to say HDFS DFS -get and GL data /flume.conf to here dot. Just run this command and it will get the file in your home directory. Yeah, don't run this, we have to make some changes. So I will just explain the configuration, then you can make the change and then run the stuff. So all you need to do is one thing. Have you logged on to the web console? Then this is the command you need to run. Just run this command, that's all. Sorry, not that command. HDFS DFS -get this is the command. Log on to web console, just run this command and you will get this file called flume.conf. Make sure you have it. Yeah, yes. And then change the keys. Change the keys. You know how to use a VI editor, right? I mean, at least copy paste. So, are you guys able to get the data? I think yes, right? If you get the file, do a vi.flume.conf and you should see it like this. Now, I will briefly explain the configuration, then I will allow you to edit it. Okay. So, when you configure a Flume agent, you have to give a name for the agent, and that is the first one, Twitter agent. Can be anything, can be Raghu. So, all the lines are starting with this Twitter agent, right? So, the name has to be same, whatever name you are giving. And first I am saying source is Twitter, channel is memchannel, sync is HDFS. That is again some name I am giving. I am saying that I want to create a source, the source name is Twitter, okay? And then you see source.twitter.type. This is where you are mentioning what type of a source you want, Twitter source. So here, this is just a name, Twitter. It can be Raghu also, doesn't matter. I am saying the type of my source is org apache source twitter.twitter source. That means I want to use Twitter source. And yeah, Twitter agent is user defined. Even the names are user defined. These three are user defined. This is where you define. Flume configuration file you have to define, right? And then what you do, you say that in the Twitter, consumer key, consumer secret, access token secret you define, right? And you can also mention keywords. Now, if you want, you can change this. I'm just using some keywords like Netflix, big data, Trump, Modi and all. So what is going to happen? It is going to connect with the API, Twitter API, and then it is going to filter your tweets. Otherwise, if you, no, not hash. Hash you have to further filter. This will give you tweets matching with these topics. And it is not guaranteed you will exactly get Netflix tweets. So the Twitter data is not properly filtered, and it is impossible to filter also because you have millions of tweets. So wherever it finds any match related to Netflix, that entire tweet it will give you, ideally, right? We have also seen in a lot of tweets, you will get a lot of tweets which is not matching also. So how we do with this in production is that when you start getting tweets, you will get like 10 million, 20 million tweets, and then you have to process it. Then you have to say, okay, in these tweets, look for hashtag this, and then you extract it. So this bunch you are downloading may not make much sense actually. It may not exactly have a tweet from Trump or something. This will give you in Avro, because the source we are using is org apache flume source Twitter source. There is another source called Cloudera flume source Twitter source. If you use that source, okay, that is as of now not supported here, you will get in JSON format. Now you will get an Avro, and I will show you, we will get the data. And then what you are doing, this is the sync details. Sync is what? Where you are storing the data, right? So anything within comma, it will consider as a word, right? And this is the sync. Sync means the destination. I am saying that file type is data stream. Data stream means it will create temporary files and then start writing into text files, okay? And the write format is text, batch size, role size and role count. This is very important. So what will happen is that it says batch size is 1000, role size is 0, role count is 10,000, role interval is 600. What I will do, I will explain these properties in the next example. So it will make more sense, right? Because tweets are very difficult to explain using these properties. Then you say the memory channel type is memory. That means your channel is RAM. Its capacity is 1 GB. So this is the value that you are giving. Transaction capacity is 100 MB, which means it can hold 1 GB data, but at a time maximum 100 MB read and write can happen. So source can either write to the channel or sync can read from the channel at 100 Mbps speed, but the total amount it can store is this number. So ideally this is in Mbps. So this is just random values I put, but in production you have to actually look at what is the size of your data and then decide accordingly.
So for this application, the GB was allocated.
This agent. Only for.
So we need to check with the DBA and we need to.
So if you start running this, it will occupy this much space in your RAM, because this is your transaction capacity, right?
Not DBA. This is RAM.
RAM. Whoever is managing the RAM, your system admin. So it will occupy this much space in your RAM first, And then the source can write at a time 100, sorry, it's not 100 Mbps, it is 100 events. So Flume has the concept of event. An event is the smallest unit of data you can transfer. In case of tweets, one tweet is an event. If you're collecting log files, one line is an event. So this means the source can write 100 events at a time, or the sink can read 100 events at a time from the channel. So 1 GB capacity you have, 100 tweets can land at a time, 100 tweets it can read at a time. That is the capacity you are mentioning. And then you mention that you have to store it as .txt, blah, 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 and the HDFS path. So this is like 100 events in a second. So 100 tweets in a second. It's very rare you get 100 tweets in a second, because, and if you get also, you will not be able to store because that much speed it comes, right? So this value you have to decide based on how many events are coming and what is your capacity of your machine. And the next question is that where will you run Flume? You won't run Flume inside Hadoop cluster. Flume has nothing to do with Hadoop, to be precise. Okay, Flume is an independent project. So we don't run Flume within Hadoop. Hadoop cluster will be there. You will install Flume in a separate server, because that needs a lot of resources and connectivity and all, right? So that machine will have connectivity with the Hadoop cluster. Let's say it is getting tweets, it will download and then push into HDFS, right? And this is the location where the tweets will appear. I want you to change these 4 values in your configuration. Also change this location. It is GL faculty. So here it has to be your username. No, that is your project, right? Say for example, we did a project on demonetization. So we want to get all the tweets related to demonetization. There should be a documentation I can give you. I don't have it right now, but yes. So, but if you simply search for Google like Flume source, this one, it will give you a list of arguments you can pass. The most important one is keywords. Like you mentioned, these are the keywords that you want, right? Now change this also, the location. Otherwise, everybody will start accessing my home folder and you will end up in error, actually. Yes, without channel, Flume engine will not start. And very important thing, I think I forgot this. If you look at this line, where is it? Where is the source? Source. So this source is Twitter, right? This source is connecting with memory channel. This line, this is my source called Twitter. It is connecting with the memory channel, and sync will also connect with memory channel. See this line, meaning both source and sync should talk to channel, right? So these lines are, see, the name of my sync is HDFS. That is talking to which channel? Memory channel. Who is putting that in that channel? Twitter source.
But if you change that value, it will never explain.
And it is very difficult to debug. So any mistake you make in this, okay, you have to sit a week to debug, because it's very confusing configuration, right? If you look at the configuration, it is easy to read, but sometimes instead of HDFS you type something else and then you forget what you have typed. Then you have to sit and understand which property you changed, where you changed. It's very difficult to understand these properties. So when should a file be created? Like you are getting tweets. Should 1000 tweets be in a file or 10,000 tweets? So you can control that using multiple properties. Either the number of events, like when 100 tweets come, create a file, or time. If it is 1 minute, roll interval. So that is what we have written here. Here it doesn't matter. Roll size, roll count, roll interval. So here I have just given some random values, but it will start creating multiple files. So there you can say either it is based on the time or the size of the data, or something else that you want, right? So if you have this file, I just want to test run it first of all before we go further into discussion. The command is already here. Can you see this file? There is a command here, and all you need to do is copy paste this. I will copy paste first to ensure it is running, and then you can also run. Very good. See, it is getting the documents, process 100, 200. See, it's downloading the data. Very easy. So it says establishing connection established, receiving status stream, right, and creating the folder. So it is processing, I think at least 100 documents it is getting in each this thing. And it says total documents 1000. Again, it will start processing it. It keeps on streaming the data now. So copy paste and run that and see if you can get the data.
How do we stop it?
Control C, kill it.
Otherwise, it will keep running.
If you don't do Control C, it keeps on like running forever.